In this lecture, we are going to learn about NoSQL database. So the first thing first, NoSQL stands for not only SQL, which means in NoSQL databases, we are not going to use structured query language. NoSQL database is a non-relational database management system which is very much different from relational database management system. So the next big question is, why do we need NoSQL database when we are already having powerful relational database management systems like Oracle, DB2, MySQL and others? So the answer is, with the increase in internet, companies like Google, Amazon, Yahoo, eBay, they started getting huge amount of data with the growing internet traffic and activities over the social media and other websites, which has given birth to a new data called big data, which is unstructured, sometimes semi-structured and also unpredictable in nature. Few examples of getting these kind of data are Facebook, Google, Blog, Twitter, YouTube. So these are the basic sources of getting this kind of unstructured, unpredictable and huge amount of data. What we are getting from these sources are unpredictable in nature and unstructured and also in huge amount on a daily basis. So all we know that RDBMS is designed to handle structured data, and that too they can handle data up to some limit. And these data are, first thing, they are unstructured. Second thing, they are coming in a huge amount. So RDBMS failed to handle these kind of data, which is big data. And this inability of RDBMS to handle this kind of unstructured and huge amount of data has given birth to a new database management system, which is known as NoSQL database management system. Some features of NoSQL databases are like they are designed to handle large volumes of structured, semi-structured and unstructured data. They provide high performance, high scalability and high availability. We discuss all these features in detail when we discuss about MongoDB in the next lecture. They provide quick iteration, they support object-oriented programming, which makes them easy to use and flexible in nature. They support dynamic schema, they support auto-sorting and replication, which make them easy to scale out and easy to maintain and easy to be fail-proof. We discuss all these features in detail in the next lecture when we talk about NoSQL database, that is MongoDB. There are four types of NoSQL databases are available right now. The first one is key value stores, which is Redis, Dynamo and React. In this kind of database, we store data in the form of key value pair. So with the reference of key, we store value, and that value can be anything like number or string or character or a document or anything. We can store anything in the value with the reference of a key. The next is column oriented databases. In these kind of database, we store data in the columnar fashion. So first we store data in the columns with the reference of a row ID. Examples are Bigtable, Cassandra and SimpleDB. Graph oriented databases are the next. In this we store data in the graphical manner. Examples are OrientDB, Neo4j and Titan. The next is very popular document oriented databases, and examples are MongoDB and CouchDB. In this course, we are going to learn about document-oriented database, that is MongoDB. So in this kind of database, we store data in the form of documents, and in case of MongoDB, we store data in the form of JSON documents, which are objects. In this lecture, we are going to discuss about MongoDB. MongoDB is a cross-platform, open-source, document-oriented database that provides high performance, high availability, automatic and easy scalability. So when I'm saying MongoDB is a cross-platform open source, it means MongoDB can be used by anyone on any platform. MongoDB uses document to store data, and so it is known as document-oriented database. And since it uses documents, it is easy to access data with the document-based search, which leads to high performance. MongoDB replicates data automatically over different nodes in a clustered environment, which gives high availability of data even if some of the nodes are going down. So replication is a process of synchronizing data over the clustered environment. So MongoDB does it automatically. So whenever some one or two nodes are going down also, we'll be still getting
same synchronized updated data from the active nodes. MongoDB provides auto-sorting with which many machines can be added without doing much configuration or changes, which leads to horizontal scalability. MongoDB provides horizontal scalability, which means horizontally we can scale out our systems, our applications without worrying much about the server configuration. MongoDB does it automatically. We just need to add required boxes to the existing system, and rest of the thing MongoDB will be taking care. And this is the one of the best functionality in MongoDB. MongoDB is a document database. A record in MongoDB is a document which is a data structure composed of field and value pairs. We will be understanding this with this example. See, this is the format of a document in MongoDB. We store document in opening and closing braces. So here course is field and value is introduction to NoSQL database. We are storing field and value. So field will correspond to the value. So if you want to get the value for a particular field, we just need to provide the field ID or field name. And see, with the category colon in a bracket development comma database. So we are giving two values for category field, which is an array. So in MongoDB document we can store array, we can store documents, we can store integer, we can store character, we can store string, we can store images, we can store anything in the field. We can relate MongoDB with relational database. Like in relational databases we use tables, and in MongoDB we use collections. In relational databases we use rows to store data. In MongoDB we store data in documents. Advantages of using documents: like documents correspond to native data types in many programming languages. MongoDB uses JSON documents to store data, which is an object. So it is very easy to use this object in a programming languages such as Java and PHP. Embedded documents and arrays reduce need of expensive joins. Since we are using embedded documents and arrays inside a document, it is very easy to get required result. Like in RDBMS, we store data in the different tables, and when we need some result or some data, we need to perform complex joins with those tables. But in MongoDB, since we are using embedded documents and arrays, it is very easy to get those results. Ability to perform dynamic queries on document using document based query language. This is another good thing about MongoDB, that we can search with the document. We can use document based query language, which is as powerful as structured query languages. Conversion of object to database objects is not needed, since we are using document and documents are like objects. High performance, because MongoDB uses internal memory to store working set for quick data access.
Now that we are having basic overview of NoSQL databases and MongoDB, we are good to look at difference between RDBMS and MongoDB. So we can understand from this picture that RDBMS will have database server, and then on the database servers we will be having our databases running, and in databases we will be having our tables, and tables will be containing rows, and every table in relational database management system will be having fixed schema. So first we decide on the schema. Schema means first we decide how many columns that table is going to have and what kind of data we are going to store in the table. So first we decide on the table structure, that is schema, and then we store data in that table. And since we are using many tables to store data, sometimes when we need a related information about those data, we need to perform complex joins. We need to write complex joins on those tables to get the required result. And in RDBMS, joins are very expensive. Now let's have a look on the MongoDB. MongoDB will also have the database server, same as RDBMS. And on the database servers, we'll be having our databases running
But here instead of tables we will be having collections. So in RDBMS we will be having tables, but in MongoDB we will be having collections instead of tables, and instead of rows we will be having documents. So instead of tables we will have collections, and instead of rows in MongoDB we will be having documents. And since in MongoDB we are using collections, we do not need any predefined schema. We don't decide what kind of data our collection is going to have. On the go, we will be storing data in the collections. So we don't decide what kind of data is going to be in the collections. So MongoDB supports dynamic schema. And since we are using documents to store data, and sometimes we store data as a embedded documents, as a arrays, so we will be keeping data together in MongoDB in form of documents, and that's the reason when we need some information about data we will be quickly getting that without writing any joins. So in MongoDB we need not to write any complex joins, and that's the reason MongoDB is very quick and fast compared to relational database management systems. One more difference between the RDBMS and MongoDB is relational database management system can store only structured data, and they can store data up to some limit, but MongoDB can store structured data, MongoDB can store unstructured data, MongoDB can store semi-structured data, and MongoDB can store huge amount of data. So there is no problem with the size of data. MongoDB can store any number of data. So these are the basic differences between the RDBMS and MongoDB.
Hello and welcome back. This is Sunil, your instructor for this course, and in the previous lecture we have seen what's new in MongoDB latest release, that is MongoDB 3.6. And in this lecture we are going to download MongoDB 3.6 and we will try to install it in our machine. So let's get started with the download and installation of latest release of MongoDB 3.6. So to download we need to go to the MongoDB website, that is mongodb.com, and here you can find various options about MongoDB. You can go and study about these things, about MongoDB latest release, the companies which are using MongoDB and their case studies and all, like Expedia, Forbes, Boss, MetLife, Cisco. All these companies are using MongoDB for their different projects. So you can go and study about those things, MongoDB latest news, solutions, all those things. But to download we need to click on the top right corner here, that is download option is there. Okay, so click on that and it will take you to the download page where you can find various options of MongoDB. Like you can find the MongoDB Atlas, where you can use the database as a service. Then we can find the community server for Windows, Linux, and OS X for the Apple operating systems. And then we have the enterprise servers, and then we have Ops Manager, Compass, connector for BI, and everything you can find on this page. So we need to download the community server, and here we can get the MongoDB 3.6.1, which is the current stable release. So we are currently on the Windows machine and we are going to download this Windows Server 2008 64-bit. Okay, so click on that. If you are on any other machine like Linux or OS X, you can download the respective download file. And here I'll click on the download MSI, and MongoDB.msi file will be downloaded on my machine. And once it is downloaded, we can click on that and we can install it on machine. So see here, now it is being downloaded. It is 181 MB of file, which will take around 10 to 15 minutes to get downloaded. Once it is downloaded, I'll show you how to install it. So see here, now the file MongoDB .msi has been downloaded. So what we can do, we can double click on this file and it will be opening and it will prompt you to install MongoDB on your machine. See here, now the installation process has started, and see here MongoDB 3.6 64-bit setup is started. So click on next and then read the license agreements and click on I accept and next. From here you can go with the next and it will be installed. So see here, it is getting installed on our machine. So once it is completed, I'll show you how to start the server. So now you can see the installation process has been done, and now we will click on the finish and it is done. So next thing what we need to do after the installation is complete, we need to go and check the directory in the C drive. You need to go to the C drive and there we need to go to the programs files, and inside that you can find a directory called MongoDB. So there will be a MongoDB folder. When you click on that, you will find a server, and inside server you can see there are two folders. One is for 3.2 version which I had installed earlier, and now another folder is there, that is 3.6, which is having the latest MongoDB release. So next thing what we need to do, we need to copy this path and we need to go to the command prompt and we need to go to this directory and we need to start the server. So we know that to start the server we need to type the command MongoD and then we need to specify the DB path. For that purpose I have created a folder in D drive called MongoDB and I have given the data1 and db1. These are the data directory path that I have chosen for this installation. So we need to provide the DB path. So we need to provide this path and then hit enter. So now the MongoDB server has started. It is waiting for the connection. Okay. So next thing we need to start the Mongo shell. For that we need to go to the same directory and we need to type the Mongo. So when you type Mongo and hit enter, it will start the Mongo shell, and here you can see Mongo shell version 3.6.1 has started and it has connected to the MongoDB server. To check whether we are connected to MongoDB or not, we need to type we need to type sodbs and it will show you all the databases that are there, and see here there is one connection open. So now we are connected to the MongoDB server and you can see here default local DB and admin DB is there. So this way we can download and install the MongoDB and we can start the MongoDB server. Hello and welcome back. This is Sunil, your instructor for this course, and in this lecture I'm going to download the latest version of MongoDB, that is MongoDB 3.2.7. So till now we were using MongoDB 3.0 and now MongoDB 3.2.7, the latest version has arrived. So I'm going to update the download and installation process with the new version. So to download MongoDB latest version, that is 3.2.7, we need to come to the website mongodb.com, and when you come to this website you can see the download link here on the right top corner of the website. When you click on this link, it will take you to this page which is MongoDB Download Center, and when you scroll down you can see MongoDB installation and download options. So here you can see community server, enterprise server, ops manager, compass and connector for BI tools, business intelligence tools. Okay, so we need to download the community server for our use. So to download that, you can see here they have given the various operating systems for Windows, for Linux, for OS X, Solaris. So you can choose your operating systems and proceed with the download process. So I'm choosing here Windows, and you can see there are several options. I'm choosing the first one, Windows Server 2008 R2 64-bit later with the SSL support. So you click on the download MSI, and when you click on this, the download process will start, and you will be downloaded a file, that is this file, MongoDB-Windows MSI file, and this file is approximately 101 MB. So it may take some time depending on your internet speed. So wait for the download process to complete, and once it is complete, you need to double click on this. So double click on this, and then the Windows installer will start preparing the installation process, and you can see this message, welcome to the MongoDB 3.2.7 setup wizard. Click on next, and you need to read the general public license information, and once you finish reading all these things, you can click on I accept the terms in the license agreement and click on next, and you can select the custom process and complete. So I'll recommend choosing the complete. Click on complete, and then you'll see the install option here. Click on the install, and the installation for the MongoDB will start, and it will ask for the admin approval. You click on yes, and then it will start the installation process. See here, it is copying new files and all those stuffs in the background it will do. We need not to do anything, and now it is done. So click on finish, and once it is done, you can go to the program files and see here there is a MongoDB folder here which is just now created. So when you click on this, you can see the MongoDB server 3.2, and here you can see the bin. So here you can see all the MongoDB executables like Mongo, MongoD, MongoDump, Mongo Export, Mongo Files, Mongo Import, Mongo Plug, Mongo Performance, Mongo Restore, Mongo, and Mongo Stat, and Mongo Top. So these are the executable files comes with the MongoDB server. So once you have installed the MongoDB, you need to copy this path, MongoDB server /3.2/bin, and we need to open the command prompt, and we need to type cd, and then we need to paste the path and paste it here, and then you can put the MongoD, and hit enter. See here, when you hit enter, it will show you some message. It is showing the PID process ID and the port 27017 default port used by MongoDB, and it is saying DB path C data/DB is not there. So that's why it is not started. So what we need to do, we need to tell MongoDB where we want to start our MongoDB. So what I do, I'll create a folder here in D drive, and I'll give MongoDB. I'll give a name MongoDB. And why our MongoDB server has not started? Because when we try to start the MongoDB server, it will look for the DB path data/DB. So we need to provide the path to MongoDB. So I'll create a MongoDB folder, and inside that I'll create data, and inside data I'll create a subfolder, and I'll give it a name DB. So now we have this path MongoDB /data/DB. Now what I do, I'll try to start the MongoDB server with MongoD-DB path. We need to give the path for the DB to store the data in the data/DB path, and then I'll use the path D : MongoDB, the folder name, and then data/DB, and hit enter. So now MongoDB will be knowing where it needs to store all the data. So see here, MongoDB server has started, and it is waiting for connections on the port 27017. So next thing what we need to do, we need to open another command prompt and we need to go to the this path. So I'll copy this and paste it here, and here we need to type the Mongo and hit enter. See, now it is Mongo Shell version 3.2.7 connecting to test. Okay, and see in the server part it is saying connection accepted from 127.0.0.1. One connection is now open. One connection now open. Okay, so now we are connected to the MongoDB server. So now our MongoDB server has been started and we are connected to the MongoDB. We can use the show DB yes to check whether any DB is there. So since we have just installed, there is only one DB, that is local. So we can start creating our MongoDB databases collections from here. So see you in the next lecture. Hello and welcome to the lecture installing MongoDB on Ubuntu 16.04. I am Sunil, your instructor for this course, and in this we are going to install MongoDB 3.2.9, the latest version of MongoDB. So the very first step is the step which I figured out while installing MongoDB on Ubuntu while I faced a problem. So when I was trying to install, I was getting a problem of unrelated or unmatched dependency and I was not able to install. So very first step is to run this command sudo apt -update. So we need to run this command first. If you are not getting any error, then you can continue with the step 2. But if you are getting the same error, you can use this first step. So what I did, I have ran this command apt -update and I hit enter. When you hit enter, it will ask for the password. So you enter the password and it will continue installing the repository. So what this apt-get update will do, it will just try to update the download packages and update the repository. So it will always keep the newest version of the packages and their dependency. So you will not be getting any dependency error. So once you are done with this step 1, see here it will be processing for a couple of minutes and then it will show you this message. So once done, the next thing is we need to run this command sudo apt-key space adv space -- key server and this key server.ubuntu.com 80. Okay, so this step is for generating the public key. So public key for the software distributed are required by Ubuntu package manager, that is apt, that is advanced package tool, which we need to install the packages or software on the Ubuntu. What this GPG key will do, it will ensure that package is consistent and it is authentic. So we need this step to generate the public key. So we need to run this command. So you type this command and hit enter, it will generate the key. After that, the next step is we need to, let's see the document. The next step is creating source list file for MongoDB. So for that we need to create the Mongo list file in this directory, that is etc/apt/source.list.d, and for that we need to run the command, this command. Okay, so let's see how I ran that command. So see here, we need to run this command. Okay, so I'll attach the document. You just need to copy and paste the command because this is a long command. and you hit enter and you will get it done. The next thing is we need to, since we have modified, we need to update the repository. So we need to run the command sudo space apt minus get space update. So it will update the repository with the latest versions. And then we need to install the MongoDB. For installing MongoDB, we need to run the command sudo space apt minus get space install minus y space MongoDB minus org. So why I'm using y? Because y means yes. For all the prompt, it will be yes. Okay, for that we are using yes. So sudo apt minus get install MongoDB. Okay, so it will read the package list and it will try to build the dependency tree and state information, and it will start installing the MongoDB. So see here, automatically installed and no longer required. So it will show you some messages and it will start installing the packages like Mongo Shell, Mongo Server, Mongos and Mongo Tools, etc. Okay, so once this command is successfully executed, you will get this setting up MongoDB-org 3.2.9. that means MongoDB is installed successfully on our Ubuntu machine. So next thing is we need to go to the directory lib/system d/system, and here we need to create a file mongodb.service. So you can go to the directory, this cd, use the command cd space lib/system d/system, and then you use the command vi mongodb.service to open the file in the vi editor. Okay, and if you are not getting anything inside that, you need to copy these lines and paste into the file. So you need to copy this script and you need to paste inside the mongodb.service file, but most of the time it will automatically be there. Okay, so if it is not there, you copy this script and paste in the file mongodb.service and then save and close the file and come back to the terminal. So when you come back to terminal, next thing is we need to reload the daemon. We need to reload all the services. So for that we need to, what we need to do, we need to run the command, and we need to run this command system ctl space daemon minus reload. So it will reload all the processes, all the daemon processes. And then the next thing is we need to start the MongoDB. So now we have installed MongoDB packages, we have created the MongoDB service file, and we have reloaded all the daemons. So next thing is we need to start the MongoDB server. So for that we need to run the command system ctl space start space MongoDB, so that it will start when our system will reboot every time. Okay, and then after this command is executed, we need to enable the MongoDB service. So for that we need to run the command system ctl enable MongoDB, and MongoDB server will be enabled from this file. See here, mongodb.service, that file we have modified. Okay, the next thing is now the MongoDB server is running in the background and we want to know whether it is actually running or not. For that, to check, we need to run the command netstat space -plntu. So it will give you all the services that is running in the background in our Ubuntu machine. So see here, not all the process will be activated, not owned process info. So see here, when you see this IP 127.0.0.1 colon 27017. This is the MongoDB server. MongoDB server will run on this IP. So if you see this, it means our MongoDB server has successfully started. So next thing is to check whether MongoDB server is running or not. We need to connect to the MongoDB. So for that, just type Mongo. Mongo is the MongoDB shell that we use to write MongoDB script and queries. So type Mongo, and when you type Mongo and hit enter, you will see this MongoDB shell version 3.2.9 connecting to test. It means we are successfully connected to the MongoDB server and we can start running our MongoDB queries. See here, it is saying welcome to MongoDB server, MongoDB shell, and see here all these things. So next thing is we need to check. So you can run a command. You are into the Mongo shell. You can run a command show dbs to see all the databases available in the MongoDB. Since we have just installed, it is showing only the local database. It means there is no database yet created. So we can start creating the database, start creating the collections and inserting documents from the next lecture onwards. So see you in the next lecture. Hi, welcome back. This is Sunil, and in this lecture we are going to download MongoDB. So to download MongoDB, we need to head over to the mongodb.org website, and here you can see they have given information about MongoDB, document, learn, community. There are lots of links, and the company which releases the MongoDB. There is a stats about the MongoDB, like 10M plus downloads, 30k, 300k MongoDB University student, 35k MongoDB user group members, 16 upcoming events, 30k plus GitHub commits, and so many things. So this says how popular MongoDB is now and how popular it is going to be. So that's why we thought of learning MongoDB. So to download MongoDB, we need to go to this link. They have given the link on the very home page. So click on that. So I have opened this link in the next tab, and when you open that, you will get this mongodb.org/downloads, and here you will see the options to download MongoDB. So there is option run with MongoDB Cloud Manager, a UI to run and manage MongoDB. So we are not going to use this. We are going to download MongoDB, the other option. So here you can see they have given options for Windows, Linux, macOS and Solaris. So you select whatever operating systems you are using. I'm using Windows, so I'll select this, and I'll select the option Windows 64-bit 2008 R2 plus legacy. Okay, and here there are two options, download MSI and download zip. So I'll prefer downloading zip file because it gives me lot of freedom to use MongoDB. So I'll download this zip. I have already downloaded. You just click on this and a zip file will be downloaded. So we are downloading the MongoDB 3.0.6 3.0.6 version. So MongoDB 3, the newest version that we are going to download. So click on this and zip file will be downloaded. So I have already downloaded it on my machine here. So once the download is done, you just right click on that, extract that file to the folder or to the directory where you want to run your MongoDB, where you want to store your MongoDB. So I'll click on extract files and I'll go to I want to put MongoDB in a D drive, and I want to extract this file into the folder called MongoDB. So I've created a MongoDB folder here and I'll extract files there. So it will take few minutes to get all the MongoDB files to be extracted. So just wait for that, and once it is done, we can go ahead and we can run the MongoDB. So I have installed I have extracted in the D drive MongoDB folder. See here, the file has been extracted here. So for the ease of use, what I do, I'll just cut this from here and I'll paste all the files here. And now this folder, because this folder is having a very complex name, that's why I have moved all the files from this folder to the main folder MongoDB, and I'll delete this folder. So now we have all the tools that comes with the MongoDB, like bsondump.exe, mongo.exe, mongod.exe, mongostat. So all these tools comes with the MongoDB, but for now we are going to use mongod.exe, which is the MongoDB server, and mongo.exe, which is the MongoDB JavaScript shell. So we are going to use these two in this lecture. So the very first thing we need to do is we need to create two folders. One is data. So I'll right click and I'll create a new folder here. I'll give it a name data. Alternatively, you can put Ctrl+Shift+N to create a folder, and inside data I'll create another folder. I'll put Ctrl+Shift+N and I'll give it name db. So why I'm creating this data/db, because whenever you try to run MongoDB server, it will look for this directory to store all the MongoDB data. So whatever database you create, collection you create, it will look for the data/db directory to store all this data. So now we have the data/db and we have the bin folder here, which is having mongo.exe and mongod.exe. We are good to start the MongoDB server. So I'll open the console, and on this console what I do, I go to the drive where I have stored MongoDB files. So that is cd mongodb/bin. Okay, so here we have the mongod.exe. So to start the MongoDB server, we need to run the command mongod. So mongod is the MongoDB server, so we have to run the mongod. You can run mongod.exe or simply mongod, and then we have to give the db --db path, and then you have to give the directory for the path for the data/db. So mongodb/data/db and hit enter. So now MongoDB server will be started. See here, it is saying MongoDB starting, and port number is this, and process ID is this, and it is showing the DB path equal to this 64-bit, and you will see the host name, your machine name, and see here it is showing the DB version 3.0.6 and Windows, and it is showing the storage. See here, it is showing the storage option equal to db path colon the path, the directory data/db which we have created. So it will store all the data into this directory now, and it is showing waiting for the connections on the port 27017. This is the default port on which MongoDB runs. So now I'll open another command prompt and I'll go to the directory D drive, and I'll go to the MongoDB drive, MongoDB directory /bin, and now I run the Mongo shell. Mongo shell is to connect to the Mongo server, MongoDB server. So I'll run the Mongo shell, and see here it is saying MongoDB shell version 3.0.6 connecting to test. So it is trying to connect to the MongoDB. See here, now it is showing connection accepted from localhost 127.0.0.1, and let's see what is happening here. See here, now it is connected. So you can run a command show dbs to see all the default dbs. So there is one local db already created, so we can use this db, or you can create a database by using a command use, and then you can give the database name. You can give any database name. Suppose I'm giving the database name as database name, and I can use. So now it is switched to database. So this is the way we can download and start working with the MongoDB.
In this chapter, we will configure MongoDB server with the help of a configuration file. So I have created a configuration file and I have given it a name mongo.config file, and inside we will give this configuration like bind underscore IP. We will give the IP address so that MongoDB server will bind to that IP. So this, since we are using on our local system, we are giving the local IP here, and then we'll give the port number. By default, MongoDB server listens to this port 27017, and then quiet equal to true, so that only critical events and errors will get logged in the log file. And then we give db path equal to the path of the data slash db file, and then log path equal to the path for the log file. So here I'm giving mongodb slash log. So for that I have to create a folder here with the name log, so that all the logs will get logged inside this folder, inside a file called mongo.log. This mongo.log will be created by MongoDB server automatically inside this log folder when we start the server. The next thing is log append equal to true. Log append will set this to true so that the log is not overwritten on restart of MongoDB server. So if you keep it false each time when you restart the MongoDB server, the log file will be overwritten. So we'll keep it true. Then next is dia log equal to 3 to give log file permission as a read and write operation, so that MongoDB server can read and write to the log file. And the last one is journal equal to true. Journal equal to true ensures that write durability and data consistency much as any journaling scheme would expected to do. So this is we keep as a true so that data will be consistent, and only set this to false if you don't care about your data. So this is the configuration file. We'll save in the here, and then we will start the MongoDB server with the command mongo d, and then we give -config, and then we give the path for configuration file mongodb slash mongo.config, and then -journal. So this is the command to start the MongoDB server with help of a configuration file, and we will hit enter. So when we see this message dia log file this, it means MongoDB server has started. So to check that, we will go to the D drive. We are already there. We'll just try to start the Mongo shell. So to start Mongo shell, we'll hit the command mongo and hit enter. So see here, again we are connected to the Mongo shell version 2.6.1, connecting to test. So we'll run a command so dbs to see the default databases. So when we see this admin and local, it means we are connected to the MongoDB server and we can see the databases here. In the last section, we have seen how to run MongoDB server, which is MongoD server, and how to connect to the MongoDB server with the Mongo shell. So now that we have all the setup in place, we can go ahead and create first database in MongoDB. So now we will be creating our first database. So here our MongoDB server is up and running. So I'll open another command prompt and I'll connect to MongoDB server with the Mongo shell. So I'll type Mongo and hit enter. So connected to test. So I'll create first database with the command use and then database name. I'll give database name as my blocks. So use is the command to create database and my blocks is the database name. So use and then database name will create the database. So hit enter. So switch to DB my blocks. It means now DB variable will be referring to my blocks database. So create a collection. Now the next thing is we will be creating our first collection inside the database. So create a collection, we need to give the command db dot collection name. I'll give the collection name as db dot articles, means inside this db I'm creating a collection with the name of articles. So here collection name is articles and I want to insert data, so I'll give dot insert and then I'll insert data inside this curly braces. So articles, then I'll give article name. I'll give article name as MongoDB intro category. I'll give category as database, and I'll give tags as a array. So in the tags I'll give NoSQL DB and I'll give big data. So here we are creating a collection with the name articles and we are inserting data as name MongoDB, category as database and tags as NoSQL DB and big data. So here we are inserting a array also in the collection. So I'll just put enter. See here right result inserted one means this data has been inserted. To see the result whether it has been inserted or not, we have to hit the command db dot articles, means db dot collection name dot find. Find is the command to query a document or query a articles, means document inside the articles, and hit enter. So it will show id, which is the auto generated unique number, unique object id generated by the MongoDB server. So we will be discussing this in a separate lecture in detail. For now you can understand it as a primary key in relational database. So this is same as a primary key in the relational database for now, and name as MongoDB intro, category is database, tags. To see this in better format, we will just add at the last pretty. So if you give the command like db.articles.find.pretty, means db.collectionname.find.pretty, it will show this result in a better format. So see here it's showing in a better JSON format. ID, name, category and tags. Tags is showing as a array. So this is the way to create first database and first collection in MongoDB. In the next lecture, we will be learning about how to insert documents in a MongoDB, how to create a document and then how to insert that document in collection. In the last lecture, we have seen how to create a first database in MongoDB and how to insert document in MongoDB. In this lecture, we'll create a document and then we will save that document in the collection. So let's get started. So in the last we have created this collection articles and we have inserted the data. Now I'll create a document variable where, and then document name, we can give it any name. I'm giving article info. So this is the document name article info, and then so we are creating where article info equal to opening and closing braces and then semicolon. We will hit enter. So now we have created a document. So now enter article info dot, will give article name equal to MongoDB introduction. Hit enter. Then we give article info dot author name Sunil, and then article info dot tag equal to, we'll create an array again here, give database comma NoSQL comma DBA comma dev. We hit enter. So we have created an array also in the document. Then we give article info dot metadata equal to, create another object inside the document metadata. Then we give article info metadata dot author equal to, give Sunil G. Then we give another name Kumar. Then we give article info dot metadata description equal to about MongoDB. Okay. Then metadata, then we'll keep created on, we keep new date. So in this document we are creating a document with the name article info, and inside that we are inserting data like article name, author name, tags as a array of tags NoSQL DB, and then article info metadata, another object we are creating inside the document. We are giving this, and then now since we have created this, now we need to save this to the collection. So to save db dot collection name, which is articles dot, last lecture we have used insert, now we will be using save, and then we will pass the document name is article info, and we hit enter. So it is successfully entered. Now to see whether it is successfully entered or not, we'll get db dot article info, articles dot find dot pretty. Okay, to see here, this is the data we have created in our first lecture, and this one we have created now. So this is the document we have created. So in the last lecture we have created this data with this object ID, and here we have created this object with this new object ID, and this is the document. So see here, metadata, this is one object, and inside object we have another object metadata. So this is the way to create a document and save that document inside a collection.
In the previous lecture, we have created a database using command use, and we have inserted a document with insert command, and we have saved a document using save command. So in this lecture, we are going to learn about how to drop a database which we have created. So the first thing we will see in our MongoDB, what are the databases are there. So we will use command so db, yes, so databases. So see here we have our database my blocks which we have created in last section, and now we want to drop this database my blocks which we have created. So to delete or to drop a database, first we need to switch to that database. So I'll use command use my blocks to switch to that database. So now we have switched to db my block. Now we will drop this database with the command db dot drop database. So this is the command to drop any database in MongoDB, db dot drop database, and I'll hit enter. So it's saying drop database name is my block and status is okay. So now our database has been dropped. We will verify it with the command so db. Yes, now our database my blocks is not showing in the list. It means our database my blocks has been dropped from the MongoDB server. So this is the command to drop a database in MongoDB.
In this lecture, we are going to learn about creating a collection using a command db.createCollection, which is having two parameters, name and option. So name parameter is having a type string, and its purpose is to provide the name of the collection. And options parameter, which is having type document, and its purpose is to specify various options like indexing, memory size, maximum number of documents to be allowed in a collection. So we can create a collection with only passing parameter name, which is a mandatory parameter. Options parameter is completely optional.
So we can create a document by passing only name. So db.create collection, and then we pass the name of collection. So we'll see what is this options parameter. Options parameter is a document which is having some fields which we can specify. The first one is capped. If we specify capped true, if we set the cap field to true, it means it will create this collection as a capped collection. Capped collection is a collection which automatically deletes oldest entries when it reaches its maximum size. It means when we set capped equal to true or capped true, we need to specify the size field as well. So size field we can specify in bytes, memory size in bytes. So when we set cap true, we need to specify the size field as well. The next is auto index id. When it is set to true, it will create index on the field underscore id. By default, auto index id is set to false, so it will not create any index on the underscore id field unless until we specify it to true. The next is maximum number of documents, which is max. So max field we can specify if we want to restrict our collection with the number of documents. So we can specify the number of documents, maximum number of documents allowed in a collection. So now we are clear with these two parameters. Let's create a collection in MongoDB. So we will create a database my blocks using command use my blocks, and then we will use command db dot create collection, and we will pass only name parameter. We will pass the name as article, and we will hit enter. So we have created a collection with the name articles. We'll see so collection, it will show us the collections created in this database. So we have successfully created a collection with the name articles. So this is the way to create a collection with the syntax db.create collection. Here we have passed only name parameter, not the options parameter. So we have created a collection with passing only name parameter. Now we will create a collection by passing name and options parameter as well. So db.create collections, and then pass collection name as blocks, and we will pass options parameter which is a document. So we'll pass this in a curly braces, cap true auto index id true, size as we can give any value like 367900, and max as 1000. So here we are creating a collection with the command db.create collection. Sorry, here I have typed wrongly, create collections, should be collection, and I'm giving the name of the collection as blocks and passing the options parameter as capped true, auto index id true, size I'm giving some size in bytes, and maximum documents allowed is 1000. I'll hit enter. So we have created a capped collection as well. So collection, so see here articles and block. Article is a normal collection, and blocks we have created as a capped collection by passing a options parameter. So in this lecture we have learned how to create a collection with passing various parameters. In the last lecture, we have seen how to create a collection in MongoDB database. In this lecture, we will learn how to drop a collection in MongoDB database. So first thing, we will switch to our database myblocks using command use myblocks, and then we see how many collections are there in our database. So collection will return all the collections in the database. So articles, blocks, and system.indexes. So this article collection we have created in the last lecture. We will delete this collection in this lecture. So to delete, we will run a command db.collection name which is articles here. So articles db.articles.drop. This drop method is a no argument method. It will not take any argument, and when we run this method, it will return either true or false. If it is successfully dropping a database, it will return true, otherwise it will return false. So we will hit enter. See, it is returning false because I have given the collection name wrongly. I have typed the collection name wrongly. So since it is not existing in the database, it is returning false. So now I'll correct it. db.articles, which is the collection name, dot drop. So now it will return true. Now we'll check whether it is there or not.
So collection. So it will return only blocks and system.indexes. It means our collection is successfully dropped from the database. So this is the command db.collectionname.drop. The drop is the method to drop a database. Drop is a method to drop a collection in MongoDB database. How does this drop method work? When we call this method, it will take the lock on entire database and it will start executing this drop method, and when it completes it will release the lock. Why it is taking lock on the entire database? So that no other processes or no other command can modify this collection, because we are going to drop this. So this is the way to drop a collection in MongoDB. In this lecture, we are going to learn how to create a collection and insert documents in it using JavaScript file. So the first question which you may ask, why do we need to write JavaScript file when we can directly write scripts in MongoShell? So the answer is, in MongoShell it will be little difficult to write large documents as it is a console, and with the increasing document size it will be difficult to write correctly to avoid mistakes. So it will be always recommended to write documents creating codes in JavaScript file and then load that file into MongoShell. So in this lecture we are going to see how to write a JavaScript file containing document creating codes and load that into MongoShell to create the collection and insert the documents in it. So here I want to create a student info collection and I want to insert student information in that collection. So this is the document which is containing name, class, roll number, subject, attendance, information of students. So I have created one document which will be for John. So first name, last name for John, class, roll number, subject, which is an array of subjects, then attendance is an object which is containing information of attendance for each month. So this is the first student information. Then I'm creating another student information which is containing information for second student, the same information for the second student, and then the third document which is containing the information of the third. Right, likewise we can insert any number of documents in it. So now we have our code ready. We will go and save it in a JavaScript file. So I'll give it a name, studentinfo.js, and I'll save it all files. I'll save it studentsinfo.js. Now we will go to MongoShell. Now I'll create a new database. I'll name it class info. So we have created a new database. Now I'll load that JavaScript file into our console. So this is the command to load the JavaScript file. So we'll give the path for that file and then we'll give the file name. So D exercise files lecture 16 studentinfo.js, and then I'll hit enter. So it is returning true. It means we have successfully created the collection and inserted the document. So I'll write a command show collection. So see here it has created the student info collection. See here we have given name as a student info. So it has created. Now we'll see studentinfo.find.pretty to check whether documents has been inserted or not. Okay, sorry, I have typed it wrongly. Sorry for that. It's pretty. See here, it is showing all the documents which we have inserted through our JavaScript file, like object ID, which MongoDB will be creating, then name for John, roll number, is attendance, subject, all the information has been correctly inserted, then for Sunil, then for the third. So see here, it is quite easy to write a JavaScript file and load that file into a Mongo console to create the collection and documents. In this lecture, we are going to learn how to insert array of documents into a collection. So I have gone ahead and I have created a JavaScript file studentinfo array.js, and inside this I am writing the code to create array of document and insert that into a collection. So here I am creating a document variable studentinfo array, and I am creating a array for this document. So inside the first element I am inserting is student information for the first student, whose name is Sunil and last name is Gupta. So name, age, subject and attendance. Like this I am creating two more documents. So this will be the second element of the array and this will be the third element of the array, and here I am closing the array. So here till here I am creating this document which is having array. So this will be the document which is containing
documents, and these documents are being stored inside a array. Now I have created this document. I need to store that document inside a collection. So I'll be creating db.studentinfo collection, a new collection, and I'm inserting this document inside this collection. So db.studentinfo collection.insert, and I'm passing this variable which is the document name which I have created here. So I'll save this document JavaScript file. I'll go to the Mongo cell and I'll be running the load command. So this is the command to load this file, load, and the path for the JavaScript file which we want to load. I'll hit enter. Since it is returning true here, it means our collection has been created. So collection will return the number of collections, all the collection in the database. So here our collection has been created. So I'll run another command db.studentsinfo collection.find.pretty and I'll hit enter. See here, this collection is containing all the document which we have specified in that array. So this is the first array element, this is the second one, and this is the third one. So this is the way to create array of document inside a collection. In this lecture we are going to learn how to query a document or querying in MongoDB collection. Till now we have used find method to query a document. So I'll show you db.studentsinfo collection.find, and then we give this pretty to get the information in a better format. So this will give you all the documents inside this collection. So we have three student information, like for Sunil, for John, and for Alan. So now in this lecture we will be querying this document based on the specific key or a specific value. Like I want to query the document by giving the student name or first name or age. So we'll query based on providing some information. So I'll use db.studentsinfo collection.find.pretty. So this is our normal query to get all the data. Inside this we will provide the information on inside this will provide the information on which we want to query the data. So here I want to query the data based on the first name. So I'll provide name dot first name, sorry, name dot first name, and I'll provide the name as suppose Sunil. So this query will fetch me the data which is having first name as Sunil. So I'll enter. Something wrong. I have given the collection name wrong. Info I have given info. I'll correct it, info, and then I'll hit enter. So see here, it is giving me the information related to the first name Sunil. It is not giving me the information for Alan or John. It is giving me the data or document related to the student which is having first name as Sunil. The same way we will be querying. Instead of giving this name, I'll give age. So I'll give age 12. I'll hit enter. So see here, it is giving me student information which is having age 12. So here Alan's age is 12. So it is giving me Alan's information. So this is the way to query a data based on some specific value. There is another variant of this query where we can use a EQ, $EQ, which is means equivalent. So instead of giving directly age equal to 12, we can give like age, find the age where age is equal to 12. So this will also give us the same result. See here, age equals 12, it will give us the same result.
So this is the equivalent operator in MongoDB. EQ, dollar $EQ colon the value which we want to query. So this is for the first name also we can give the same thing. We can give here name dot first name, and here we can give EQ. We can give the first name as suppose Alan or John, and we'll hit enter. So it will be fetching name John. So here first name is John, so it is giving us the result as John, first name John and John's all other information. So this is the both the query are equivalent. We can give with the EQ or we can give without EQ. EQ means equivalent operator, so it will compare the all John with the first names and it will give the result matching with the first name as John. In the last lecture, we have learned how to query a document in MongoDB using EQ or equivalent operator, which gives the result by comparing the value with the provided value. Like if we provide EQ 12, it will search for the value 12 and give the result which matches with the value 12. In this lecture, we will learn how to query a document in MongoDB based on the less than and greater than operator. So in this, we will be providing, like if we want to search student based on the age less than 12, so we will provide $LT colon 12. So it will give us the result for the student whose age is less than 12, and same with the greater than. So let's get started. So here we will give db dot student info collection dot find age, and instead of eq we will give lt, and here we will give the value as 19. So since all our student age are less than 18, it will give us all the student information. So see here, it is giving us all the results because Sunil is having 16, John 18 age, and Alan Hill is having 12 years of age. We'll modify the query and I'll give here age less than 15 and I'll hit enter. So it will give us the result for age less than 15, which is Alan. Alan is having age 12, which is less than 15. So it is giving the result only students whose age is less than 12. Same thing we will do with greater than. So instead of $LT, we'll give GT, greater than 15. So greater than 15, it is giving us two results. One is for Sunil, whose age is 16, and another is for John, whose age is 18 years. So this is the way to query a document based on the greater than and less than operator in MongoDB. In the last lecture, we have seen some of the operators such as equivalent operator, less than operator, and greater than operator. In this lecture, we will be learning some other query operators which we can use in our MongoDB database. So let's get started. So in this lecture, we will be learning greater than or equal to operator, which is $GTE operator, and syntax for this is like db.studentinfo. This is the collection which we want to query, dot find, and then we will be querying based on the age. So we will supply the age value, so age, and then we will be giving greater than or equal to greater than or equal to 16. So this query based on the age, it will be querying this collection with the value age 16, and it will be returning the collection values or documents which are containing age greater than or equal to 16. So it will be not returning the documents which are having age less than 16. It will be returning all the documents which are having age greater than 16, greater than or equal to 16. In the same way, we have LTE operator, $LTE operator, which is less than or equal to. In the same way, if we put the query like age $LTE16, it will be returning all the documents which will be containing value less than or equal to 16. So it will not return the documents which are having age greater than 16. It will be returning all the documents which are having less than equal to 16. We have another operator which is not equal to operator, which will be returning if we give $NE equals 16, it will be returning all other document except 16. So it will be comparing age with the 16 and it will be returning all other documents which are not having age as 16. So it will return all the less than 16 values and greater than 16 value, but it won't return the value which is having 16. So not equal to 16. Then we have in operator. In operator is to query a array value based on the array value. So here we have a subject which is containing values such as small business, medium business, or math, physics, chemistry. So we can give $in subject the array name and then $in small business. So it will return all the documents which are having array value as small business. And then we have another operator NIN, not in operator, which will be returning all other documents which are not having subject as small business. And then we have exist operator, which will be seeing if we give subject exist equal to true and then NIN small business. So it will first check whether this subject array is existing in the document or not, and then it will see not in operator. So in that operator, in that collection, if small business is not existing, it will return the value. We can give small exist equal to false and we will be seeing what it will return. So it will return all the documents which are not having subject array. So let's do some hands-on with all these things. So we will first think db dot students info collection dot find. So student collection find age greater than 16. So this is our query, student info collection find age, then $LT16 dot pretty. So it will return all the documents which are having age greater than equal to 16. We'll hit enter. So see here, it is returning documents which are having age 16 or greater than 16. It is not returning the values which are having less than 16. So what we'll do, we will change this to LTE, less than or equal to, and run the query. See, this is returning all the documents which are having age 16 or less than 16, age 12 and 16. It is not returning the result for age 18. The next we will see in operator. So our query is this collection info dot find subject is an array, and then we'll give colon and then $in and we will give small. This should be in the array. This should be the array. So we'll pass this and we will hit enter. So see, this will be giving you the result for the document which is containing subject as a small business. So this subject is an array which is containing a value, array value, small business. So it is returning only the documents which are containing subject array as a small business. And then we can give NIN, next one NIN not in operator, and we will hit enter. See, it is giving the result which are not containing the, see here, it is giving the result for subjects math, physics, chemistry. There is no small business. So it will return all the documents which are not having small business in the subject array. And then we will see exist one. So to what is the syntax for exist. Here what we'll do, we will be adding one more operator exists colon true comma, and then we'll pass this in small business. So it will check whether this subject array is containing small business or not, and this subject array is there in the collection or not, and then it will return the value. So see here, subject array is having small business for the first name Alan, so it is returning only result for the Alan, because Alan is having subject array as well as small business as an entry. So we can modify this to false, and we'll see what is the result. We'll see false and enter. Okay, this exist false in is giving no result, because for a small business there is no like entry in the subject. If subject is not there, we'll see this with the NIN, not in the array. This will give us the document result which is not containing the array subjects. So this exist will be checking in the collection whether some of the documents are not having the subject array. So it finds this document which is not having the subject array, and so it is returning this value. So this subject this exist, we can check whether some array is existing in the document. We can search a document and see whether some array is existing or not, and then if it is existing we can query that array further. So now we have the overview of all these query operators which we can use in the later tutorials when we will be doing our like updating a document or deleting a document. So we can pass this operator as a query, as a parameter. Like if we want to update a document based on this parameter or this condition, so we can use this operator as a condition to update or delete a document. In this lecture we are going to learn about updating MongoDB documents. So we'll see how we can update a document or array in a MongoDB collection. So there is a update method which takes different parameters or different options to update a MongoDB document. So let's see. So here we will be writing this method like db.collectionName.update. Update is a method to update a document in a MongoDB. So it takes parameters like first one is the criteria on which we want to update the data. So name dot first name Sunil. So I want to update a student whose name is Sunil, and I want to update age to 17. So the first one, this first one is criteria, and the second one is the value or the field which value we want to update. So here I want to update the age value. So $set is used to set the value for this field age to 17. This update here is taking two parameters, like first one is criteria and the second one is value. It also takes a third parameters which is upsert. So here you can see the first one is criteria, the second one is the field which we want to update, and the third one is upsert true. So what this upsert true will do, if it finds the first name Samir, a document which is having first name as Samir, then it will set the value of age to 37, and if it doesn't find the matching value for Samir, then it will insert a new document, and if you make it upsert false, then it will not do anything. It will not update or insert. And then the third thing which we will be doing during the hands-on is updating the array element. So here in our collection we have a array, subject array, which is containing subjects like physics, chemistry, math, business, something, some value is it containing as this array. So I want to update the array's second element, that is index 1, to science. So this one is the criteria for the first name Sunil. I want to set the value of this subject array first element, second element to science. So now we will do the hands-on for this. So we have this document which is containing the student information like first name Sunil, subject is an array, so we'll try to update this value, this biology value to some other value. This is the first second element of this array subjects, and then we will uh, update the based on the age value for this different things. So let me copy this. So here I'm trying to update the students whose first name Sunil, and I want to update the age to 17. So we'll see what is the current value. Current value for Sunil is 29. Age 29. We will update it to 17. So I'll just copy paste. Sorry, something else is getting copied. Okay. So now I have updated the age value to 17. So let's run this and we'll see what is the result. See here, the age value has been updated to 17. What we will do, we will be writing the third parameter and we'll give upsert true. I'll give upsert true here and we'll see what will happen. So see here what is saying. It is saying n matched 1. It found the matching value for the first name Sunil. Inserted 0. It has not inserted or inserted any value, modified 0. So because it has found the same value, now we'll modify this to, I'll give this age value to suppose 27. Right now it is 17. I'll give to 47 and I'll hit enter. Now it is saying matched 1, upserted 0 and unmodified 1. It has modified the value of age from 17 to 47. See here. Now the age value is 47. We'll change it again. What I'll do, I'll change the name to some value which is not there in the document. I'll make it summer. So summer first name summer is not there in our document. So let's see what is Dutch. See here it's saying unmatched 0 means summer first name is not found in this collection or in this collection. So what it has done, it has done the upsert means since the document is not there, it has inserted a new document. Modified 0 means no modification, new data has been inserted with this object ID. So let's query the document. See here the new data has been inserted, first name summer, age 47. So this way we can use the upsert. If you want to insert a new data, if the data is not existing, then you can use upsert true, otherwise set it to false. The next is we'll see how to update so we'll see here I want to update the first name Sunil's subject second value means the subject's array second element to science. We'll see what is the value now. Now it is biology. We'll change it to science. So I'll just paste it here. Okay, so here what I'm doing, the first name Sunil, set subject dot one means subjects array second element to science, enter. So here it is saying modified 1. It has modified the second element value. We'll update. We'll see now. See here the second element is updated with the new value science. So this way we can update the document in MongoDB. In the last lecture we have learned about updating documents in MongoDB. In this lecture we will be learning deletion of documents in MongoDB. We'll learn how to delete documents or remove document in MongoDB. So there is a method remove. There is a remove method which is used to delete or remove documents in MongoDB. So let's see. So here db.collection_name dot remove. So this is the method to delete or remove a document in MongoDB. So this takes the usual parameter, means the query criteria on which we want to remove the document. Like here I have given name.firstname Alan. So it whenever it finds the matching document with the first name as Alan, it will remove that document from the collection. And it takes another parameter, like here I have given remove subjects mass, and then I have given 1. We can give 1 or we can give true. So why I am giving this? Because if it finds more than one matching document for this subject equals maths, then if I give nothing here, it will delete all the documents which matches this criteria. And if I give 1 or true here, which means it will just delete the first document, first matching document it will delete. So this is called just one argument in the remove method. And if we don't pass any criteria in the remove method, it will remove all the documents in the collection. So here we will try to delete the record or document which is having first name as Alan, and then we will be trying to remove a document which is containing maths as a array element value. So subject is an array which is containing a math element. So the first thing we will see this one. We will try to delete one document which is matching this criteria, and then we will be running this query to delete all the document which matches this criteria. So let's do the hands-on. So this is our document, student info collection document. So here first name Sunil and subject is having math, science, chemistry. Then John, math, science, chemistry. And then for Alan, and then for Steve there is no subject, and then here. So here we have a document which is containing only one subject. It is having subjects containing history. That is a different thing. So we will try to delete this document with the history. So I'll write a db dot students info collection dot remove, and inside remove I'll pass the query criteria. First I'll try to delete name dot first name. I'll delete this summer. So here I'm trying to delete this document which is having first name as summer in this collection. So I'll hit enter. So it's saying unremoved 1, means it has been removed. We will run this and see here. Now we don't have a document which is having first name as summer. So we have deleted this document. Now the next thing is, what I'll do, I'll try to delete a array element. So here we have a collection, a document with the name David, and it's containing subjects history. So we'll delete this document with this subjects history. So I'll hit enter. It's saying removed 1. Removed 1 means it has been removed. Let's see here. Now we are not having David documents, so that has been deleted. Now we'll do with the just one parameter. So here maths and any other maths Okay, so this subject array containing is also here, math first element here also, and so this maths element is there in two documents, so we'll try to delete the only one. So what I'll do, I'll give subjects and I'll give math. If I give just this, it will delete both the document wherever it finds subjects equal to maths. What I'll do, I'll just pass the parameter as 1 like we have written here. So it will delete the only one document. Think syntax error. Okay, sorry. So I have written wrongly. It should be comma 1. So this is the correct syntax. Saying removed 1. So it has removed only 1. See here. Earlier we had two mass containing, now we are having only one array which is having mass as a element. So now we'll see how to remove all the documents in a collection. So we'll see, so collection. So here we have few collections. We'll delete one of them, db.studentinfo.find. We'll see whether some documents is there or not. There is nothing. Okay, we'll see this is student info. This is also not having anything. Okay, so we will be deleting this one. So I'll remove this document on which we are working. Remove, and I won't pass any parameter, so it will remove all the documents. Okay, I'll give this. See, it's saying and remove 5, means it has removed 5 documents. Let's see how many documents were there. So 1, 2, 3, 4 and 5. So 5 documents were there and it has removed all the documents. So if you give only remove, it will delete or remove all the documents in the collection. So now if we query this collection, it won't return any document because it has been removed. In this section we are going to learn about performance tuning in MongoDB, and this we will do with the indexes. So right, like we know, indexes in RDBMS are created to make the performance improve. To improve a performance or querying operations, we write indexes, we create indexes so that the querying or getting the data from the table or database will be faster. So it will improve the performance of querying, it will improve the performance of database querying. So the same with the MongoDB. In MongoDB also we create the indexes to improve the performance. So what is the difference between if we will not create the index and if we create the index on a collection? So what will be the impact on the performance, that we will be seeing in this section. So first what we'll do, we'll understand what is index and why we need to create a index in MongoDB. So like I said earlier, indexes used to improve the performance, improve the performance of getting the data. So if we create an index, we will get the data faster, and if we not create, it will take more time. Why? Because if in a MongoDB, if we not create a collection and will simply search a data, what it will do, it will look for all the documents in the collection to find the matching document. Suppose in a collection we have 12 documents or 15 documents or 100 documents, and we if we are searching for the first name, then what MongoDB search will do, it will
look for all the documents to match the first name query criteria which we are passing. So it will search for all the documents one by one. So it will be taking time. And what will happen if we provide a index? If we create an index on a first name, and we if we search with the first name, then it will not be looking for all the documents. It will search only one document for the first name matching. Okay, so it will not be searching rest of the 49 documents or 12 document, 11 document. It will be going to that particular index document to fetch the result. So what is index? If we create index, it is like a key to the document location. One, if we create an index, it will be creating a key that will be pointing to a document location. So, and that indexes in MongoDB are the B tree indexes. B tree means binary tree, an array binary tree indexes. So, if we create index, it will be directly pointing to that document. So, in the next lecture, we'll see how it is going to impact and how many, like I said, if we not create the index, it will look for all the documents, and if you create index, it will look for the only one document that is indexed. So we'll see in the next tutorial, in the next lecture, how it is happening by doing a hands-on.
In this lecture, we will be understanding the impact of indexes on querying in MongoDB. So, in the last lecture, we have learned the basic concept of indexing. In this lecture, we will see how indexes are going to impact our performance in MongoDB. So, in this, we'll see by doing the hands-on how if we run a like query with index, so how many documents it is scanning to get the matching document, and if we are creating a not creating an index, then how many documents it is scanning. So the basic difference with index and without index, that is what we are going to learn in this lecture. So let's get started. So here we are using collection. Let me show you. We are using student info collection. So I'll write a query db.studentsinfo collections dot find dot pretty to see what is there. Something wrong I have written. Students info collection. Okay, it is collection. So this is the collection which we are using, which is having id, name, first name, subject, and it is having three documents. First one is this, second one is this, and the third one. So here we are having three objects or three documents in a collection. So what I'll do, I'll write a query to based on the first name. So I'll do name dot first name, and I'll pass Alan. So what I'm doing here, I'm querying based on first name Alan. Sorry, I typed it wrongly. Pretty. So here we are getting the document matching with the first name Alan, and we see how it is working. We have a method or function explain, which will explain how this has worked. So put enter and it will give you result like cursor. What cursor it is using? It is using basic cursor, and n is equal to 1. The number of objects returned is 1. Number of object scanned 3. So it has scanned 3 objects or documents to return the matching one document. Why? Because we have 3 documents or 3 objects in our collection. Since this name first name is not indexed, it has gone through all the documents, all the objects to get the required result. And what will happen if we run this same query or same search with the index? That we'll see, but don't get it wrong that this is the ln is at the in the third document here. That's why it is showing number of object third. No, that is not the case. Where it is in the first place or last, it will be giving the, it will be scanning all the. This is Sunil, which is in the first document. I'll enter. See here again, it is showing number of object 3. So no matter which position your document is, it will be scanning all the document to get the query result. So now what I'll do, I'll run a query based on the ID field. This ID field is, as we know, ID field is indexed by default in MongoDB. So what I'll do, I'll remove this first name and now I'll write underscore ID and then I'll pass this object ID for Alan. So now I'm doing the same thing with the underscore ID, which is index, and we'll see what is the difference, how many object it is scanning to get the result. So see here, the n still 1, but number of objects scanned is 1. It has not gone through other objects or other document to get the matching document. It has scanned only one document because this ID field is index. So what MongoDB will do, it will create a memory for index, small memory for index document, and when we query it will just go there and fetch the required result. So in MongoDB, indexes are stored in a binary tree, B tree, so it will be easier to fetch the document matching with the given criteria. In the next lecture we will be learning how to create a index in MongoDB. In this lecture we are going to learn how to create an index in MongoDB. So in the last lecture and the previous lecture we have seen how index is going to impact the performance. So now we have the basic understanding of how index work and what is the performance gain we are getting with index. Now we will create the first index in MongoDB. So let's get started. So this is the collection, student info collection, which we are using for our hands-on. So for this I'll just query it quickly. So here we have the documents. So now we are going to create an index on the field age and we'll see how it is impacting the querying. So first what I'll do, I'll just run a simple command here. What I'll do, I'll query based on the age. We'll put 12 and we'll see how it is working without creating an index, how it is working, how many documents is scanning to get the result. See here, it is scanning all 3 documents because we don't have the index on the field age. Now what I'll do, I'll create index. To create an index we need to type index, create index. This is the command. Create index is a method to create index in MongoDB. So create index and inside that we'll pass the field on which we want to create an index. So here I'm passing age and I'll give 1. Here 1 means ascending order and -1 means descending order. So I'll give 1 and now I'll hit enter. So here db.studentinfocollection.create index. Create index is a method to create the index on a field. So I'm creating a index on field age in ascending order. So I'll hit enter. See here what it is saying, number of indexes before 1 because we have a automatically created index on the field underscore ID, and number of indexes after 2 because now we have an index on field age. So now we have the index in place. Now we will be running the command, same command again,
find age equal to 12 and I'll put explain, so that we'll see how many object it is scanning after the index. So see here, now it is scanning only one object. Earlier it was scanning three objects. So this is the difference when you create index. So here it is scanning one object and earlier it was scanning two objects. So this is the performance difference. It is not going to scan the rest of the two documents, which will be saving time to get the result. So that is in this way we can increase the performance in MongoDB. In the next lecture we'll see more about indexes. In the last lecture, we have created an index in MongoDB collection. So now we know what is index, how it works, what is the benefit of creating index, and how to create an index in MongoDB collection. Now we have created a collection, and now if we want to know how many indexes we have created or how many indexes are there in a collection, so how to find that? So in this lecture, we are going to find or get the indexes in a collection. So we will be running a command get indexes, which will list all the indexes in a collection, all the indexes created inside a collection. So let's get started. So we are using db.studentsinfo collection. This is the collection, student info collection. This is the collection name, and then we write get indexes. So this is the command get indexes to get the db dot collection name dot get indexes. Get indexes will list all the indexes in the collection. So hit enter. See here we are getting two objects here. The first one is this and second one is this. The first one is for key underscore id and second one which we have created for age. So this is the indexes in this collection, and see here the name space is class info dot student info collection. So class info is database and student info collection is a collection. So in this way we can get all the indexes in a collection. In the last lecture we have seen how to get all the indexes in a collection, and in this lecture we are going to drop an index in a collection. So in this lecture we will see how to drop a index which we have created. So let's get it done quickly. So we have this get index. We will be using drop index. So drop index will drop the index from the collection. So inside this we need to give index name, age and 1. So this will delete the index from the collection. Okay, drop index. Sorry, I have typed earlier wrongly drop indexes. It should be drop index and then the index name we need to pass. So it's saying an index is 2, okay 1. Means earlier it was 2, now it is 1. Now we'll run the command get indexes to see whether it has been dropped or not. See here only underscore id there. So the age index has been dropped. In this section, we are going to learn about object IDs in MongoDB. So in the last few lectures and sections, we have seen when we are creating a document, MongoDB is creating object ID by itself. It is the object IDs in MongoDB is like a primary key which we create in or the relational databases create for us. So the same way MongoDB also creates a object ID. So I'll show you, like we have this collection student info collection. So I'm just querying it. So here you can see MongoDB has created this underscore ID field for us. We have given only name, age, subject and attendance, but this underscore ID field has been created by MongoDB. So in this section we are going to learn more about this field, and we'll also learn how we can create this field by ourselves. So instead of system is creating for us, we can also create, and we will also be learning what are these numbers mean in this object ID field. So all these things we'll learn in this section. So let's get started. In this lecture we will be understanding object IDs which MongoDB creates for us automatically. So we will learn what is this object ID and what does it mean. Let's look at the object ID field. So this is the object ID, which is the combination of some very random numbers and alphabets, something. So it's not a very understandable. So we'll learn what is this. So let's look at what is this. So the first thing, when we look at the object ID, one thing is very specific, which whatever object ID MongoDB creates for us, it is immutable. Immutable means it cannot be modified once it is created. You cannot modify it, you cannot alter it, you cannot edit it once the object ID has been created by the MongoDB. So MongoDB creates immutable object ID that cannot be modified, edit or alter. And the second thing is it is very unique. So whatever MongoDB creates, it's a unique object ID. The third thing is it's a JSON type data type, and it is a 12 byte value. So let's look at the, so this thing is the, this object ID is like it's a 12 byte value, which is a combination of like the time when the object is created and the host name on which the we are hosting our database MongoDB server, that host name also included in this, and then the process ID with that, with which we have created the object ID or the collection, and then it is also having a random incrementing number. So this object ID is combination of host name, time and process ID and a random incrementing number, and that's why it is unique. You may ask a question like, why do we need this much complicated algorithm to create an object ID? Like we can use a simple incrementing number like we do in RDBMS. So answer is, since MongoDB is basically used in a large clustered environment where we host our MongoDB database on a different machines, different servers. So if we create a random incrementing number like 123 or 1234566 and then increment the last digit, it may not be unique on the, if you collect data from all the machines. So on one machine we create with the ID 1, at the same time somebody will create another object with the same ID 1. So it won't be unique. That's why MongoDB is combining all this server ID, host name, time, random incrementing number and process ID. So it will be very unique, almost unique in every situation. So this is the basic overview of MongoDB object ID. In the next lecture, we will be learning how we can create our own object ID instead of MongoDB is creating for us. In this lecture, we will be learning how to create our own object ID. So till now we have not given the underscore ID field, and it has been created automatically by the MongoDB server. So now what we'll do, while creating a document, we will be giving the underscore ID field. We will be creating as per our requirement. So that can be possible. We can create our own object ID. In that case, MongoDB will not be creating a underscore object ID field for us. So let's get started. So what I'll do, I'll create a new collection. In this case, I'll create, suppose, product ID, product details collection. I'll insert some data in this. So what I'll do, I'll be in, suppose I'll create the PRDT name. The first field I'll give PRDT name, and for PRDT name I'll give some name like suppose I'll give microphone. Okay, that's it. So I'll create a simple collection with the product ID, product name. So I'll hit insert. Okay, this is done. So now what I'll do, I'll just query it. So I'll use find. See here, underscore object ID has been created for us by the MongoDB. So we have not given the underscore ID field here. So it has been created by MongoDB. Now what I'll do, the same thing, what I'll do here, I'll give underscore ID, 001.
Okay, and then the product name I'll give television. Okay, so now hit enter. So here I'm giving underscore id field. So let's see. Okay, done. I'll query it. See, while querying, what we are finding, the underscore id field. Okay, let me show you. See here, in this case underscore id is 1 and product name is television, but the earlier it was object id created by the MongoDB. So in this way we can create our own object id underscore id field. So this is the way to create a underscore id field. In the next lecture we will be seeing what is the benefit of object id field created by MongoDB itself, and we see how we can get some more information through object id which MongoDB server has created for us. In the last lecture we have discussed about how to create object IDs and how and what are object IDs. In this lecture we will be going to discuss about advantage of using default object ID that has been created by the MongoDB server. So we'll discuss advantage in this lecture, and in the next lecture we will discuss the disadvantage of using our own created object ID that we are creating. So let's get started. So this is the collection which we have created in the last lecture. So let's query it. Sorry for typo. db dot product details dot find. So see here we have two documents, one with the default object ID and the other is which we have created underscore id equal to 1. So let's see the what we get. Like in the last lecture we have discussed like this object id is 12 byte combination of like server on which we are running the MongoDB, and the process id, the timestamp, and the incrementing number, serial incrementing number. So this is the combination of all these things, and let's see what we can get. The one big advantage of this object id which MongoDB is creating is we can get the timestamp from this. So let's see how we can do that. So I'll query the first document. Okay, find and then 0, it will get the first document. So see here we are getting as a result as the first document in the collection. And then what I'll do, dot underscore id will give us the object id. So this is the object id, and then what I'll do, dot get timestamp. So this will give us the time when this object id has been created, this document has been created. So see here we are getting the time when this document has been created. But if we go and do the same thing with the first document id of 0 television, which we have created our own document id underscore id. So see here if I put enter, it is saying type error, object 1 has no method get timestamp. So this is one big disadvantage with the object IDs which we create. So this is the advantage of using default object ID which MongoDB creates for us. So in the previous lectures we have seen how we can create object ID, how MongoDB creates object ID, and we have understood the mechanism how object IDs work. And we have also seen advantage of using default MongoDB created object ID. What we are going to discuss in this lecture is disadvantage of using default object ID. It is always recommended to use object ID created by MongoDB, but there is a little disadvantage that we are going to discuss in this lecture. So let's get started. Okay, so let me start my connect to the MongoDB. Mongo. Hope you remember we need to type Mongo to connect to the MongoDB server. Mongo is the MongoDB shell, JavaScript console to connect with the MongoDB. So we connected. What we use? We use our, this is the database class info I'm going to use. So in this what we are using, we'll see collections. So collections, to see all the collections, so we have used this product details. So db dot product details dot find enter. So we have created this object id, one default object id and one created by our object id which we have created. So one created by MongoDB and the other one we have created. So what is the disadvantage? Suppose only disadvantage that I can see or I came across while working is like when we do we think in terms of web applications. So suppose we have a web applications like bookshop and slash product details slash, and then we have to give the product id. So suppose you are giving product id here. So what if we will use this object id? So it will be like something like 554f312. So it will be looking very bad if we use this kind of auto generated MongoDB generated object id. So in this case only we need to create our own user defined object id like one, or if you want to give some name like my book or MongoDB book, something if you want to give. So in this case only we have to think about the user defined ID field. So this is the only disadvantage in terms of web application where it will be looking bad or it will be difficult to identify the object ID or the product ID. So this is the only disadvantage. In other ways, we always encourage to use default object ID. In this whole section on aggregation framework in MongoDB, we are going to learn and discuss about aggregation framework in MongoDB. So aggregation framework in MongoDB is very much similar to what we have in SQL or RDBMS. Like we perform the count method to get the number of count, number of documents in the number of record in the RDBMS database, same as we perform the count to get the number of documents in the MongoDB. And we use the group by in SQL, same as here also we will be using group operator to get the result by grouping the data based on some operation. So let's get started. So what is aggregation framework in MongoDB? So what aggregation does actually, it's process the data or process the data records or documents in the MongoDB, and after processing it gives the result. How it gives the result? Like it groups the values or documents based on them some conditions provided. So we will be grouping the data based on some like age or number of students or number of likes if you are using a blog data. So it will group the data based on some specific value in a collection, and then what we do, it performs some operation like when we group the data based on like number of likes, and then we perform some operations on the group data. So that's what MongoDB or any aggregation framework does. It processes the data, it groups the data together, and then performs some operation on the group data. And MongoDB, as I earlier said, MongoDB aggregation framework is equivalent to count and group by in RDBMS or SQL. So next thing is aggregation methods in MongoDB. So we have aggregate method in MongoDB to perform aggregation on a document or on a collection of documents. So what this aggregate method is, in this aggregate method we provide the inside this method we provide the operation to be performed, like we'll pass different operators which will perform a specific operation in this aggregate method. So in the next slide we will be seeing what are those operations which we are going to perform in a aggregate method. So various operations in aggregate methods are like sum, which will give the sum of, like if you are going to get the based on salary, so it will give a sum of all the salaries, or average, it will give the average value of the salary. Like if you want to perform an operation on a employee data and you want to get the average salary of the employees, then we can pass on this average operator. or average method, and then we have min, so that we can get the minimum value. And likewise we have max value, so we can get the max. And we have first, so we can get the first document or first record in the document. And then we have last, and likewise we have many other like push, pop, all these operations we can do in aggregate method. So we'll see all of these and many more in the subsequent tutorials. So this is the basic overview of the aggregate framework in MongoDB. In the last lecture, we have learned how aggregate framework works in MongoDB. In this lecture, we are going to do our hands-on with the aggregate framework in MongoDB. So we will be using aggregate method to do the aggregation in MongoDB document. So let's get started. So first thing, this is the first example in this tutorial. In this lecture, we will be seeing more examples in this section in aggregation framework. So what we'll be using, we'll be using group and sum operator in this example. So what I'm going to do here, there are two steps. The first one is we will be doing a grouping of documents based on the author, and then once we group the document, we will be getting the number of blog posts published by each author. So for this, we'll be creating a document. We will be creating a collection, and we will be inserting documents consisting author information and the blog information. So one author, and we'll create just now. So this is the document I have written. So I'm creating a collection and giving it a name, aggregation example, and I'm inserting documents inside that with the title, that is blog post title, like MongoDB introduction, and then description field, and then a author field, who has written that blog post. So here's Sunil, and then I'm giving a URL, and then I'm giving a tags, and then I'm giving like. So this is the first document. Then I'm creating another document with the MongoDB indexes, author is Professor D, second author, and URL tags and all. And then I'm creating one more document. So this document again written by Sunil, author, and like all those things are similar, only author name is getting changed, again Sunil. And then I'm creating one more document with the author is your success. So we have this total six documents, and we have three authors, Sunil, is your success, and Professor D. So this is the Professor D. So this is the document. So this I have written already to save our time. So I'll save it with the name aggregation example.js, and I'll open the Mongo console, and with this command load and the path for the JavaScript file, I'll load that file to the MongoDB. So I'm using use class info database, and I'll hit enter. So true means it has been inserted. So let's query it. So let me query it, find dot rating to get in a better format. So see here, we have inserted the documents inside the collection. The first one is ID, which will be created by MongoDB, then the title, then description, author. So this whole document we have created. Now what I'll do, I have to perform a aggregation using group operator. So what I'll do, I have to write a query. I have to write a syntax for that. So what we are going to use, db dot the collection name dot aggregate. So aggregate is the method. So inside the aggregate method, we will be writing with this bracket open, then the curly brace, and then we'll be using this group operator with the dollar sign. So dollar group, it will group the document, and then we'll be passing the author underscore id colon author. So what it will do, it will group the document based on the author name. So based on the author name, it will group the document. And then what I'll do, I'll be creating a variable total underscore post. What it will have, it will have the sum of okay, let me make it 1. So what it will do, total post colon dollar sum 1. This sum operator will what will do, it will do, it will first this id colon author dollar author, it will group the document with the author name, and then this sum colon 1 what it will do, it will count the number of blog post or number of document having the same author name. So each author name it will keep on incrementing this total post variable. So first it will suppose it will find the first document as Sunil, so total post for Sunil will be 1. Then again it will find the look at here, first it will come, it will find Sunil one document. So total post, this total post will be incremented by 1, it will be 1 now. Then again it will find down the line here, it will again find this Sunil document, another document with the author name Sunil. So that total post will be now 2. Like that it will do for each and every author, and as a result what we will get, we'll see when we run this query. So what I'll do, I'll just copy it. Okay, remove the space. I'll just copy it. Sorry, copy it, and what I'll do, I will paste it here. Okay, something went wrong. Copy, paste it here. Okay, so what we are doing here, we are using db dot, scroll up, what we are doing, db dot aggregation example, this is the collection name dot aggregate, and then we are using group operator to group the documents based on the author name, and then we are using total post variable to get the total number of documents with that author, or total number of posts published by that author. So let me hit enter to run this. See here, when we run, what we are getting, we are getting underscore id, this is the author name, is your success, total post is 1, then is Professor D, total post is 1, and for id Sunil, total post is 4. So why Sunil is 4? See here, if I do control F, Sunil, I'll getting 1, 2, 3 and 4. So we are getting 4 documents. We have 4 documents or 4 blog posts by Sunil, 1, 2, 3 and 4. So it is giving us 4 here, and for others we have only 1, like Professor is your success is having 1 document, likewise Professor D is having 1. So in this way we can perform the aggregation in MongoDB using group and sum operator. In the next lecture we will be learning more examples for aggregation framework.
In this lecture, we are going to learn about distinct and count methods. So as you may be aware of the RDBMS, there we sometimes we need to find the distinct values available in the database. Like we need to find the some employees in organization drawing the same salary. So we need to find the like or we need to find the distinct employees having a role like manager. So we need to find all the employees who are having a designation as manager. So we need to find the role giving the criteria as a role as manager, and we need to find all the distinct managers. So sometimes we need to write the SQL queries for that. In the same way, we can write distinct, we can fetch the distinct value in MongoDB as well by using distinct function. And sometimes we need to find the number of users or number of records available in the MySQL database or RDBMS like Oracle and all. So we use count. So in MongoDB also we will be using count method to find the number of documents available in the collection. So let's see how it works in MongoDB. So we have created a collection student info on which we are working, student info collection, and then we will give like we need to find the distinct values for subjects. So first we see to revise what is there in our document or in our collection. So I'll just query it dot pretty. So see here we have 3 documents, ID for first name Sunil, first name John, and first name Alan, and they are having name, age, subject as a array, attendance as a objects. So in this, what we can find as a distinct, like here subjects, everybody is having subjects like math, physics, chemistry, and small, medium. So subject is repeating here, like math, physics, chemistry, and then here math, physics, chemistry, and then Alan is having like small, medium, and journalism. So we need to find the number. What are the distinct subjects available in our document? So we can write a query like db. Instead of find, we will give distinct, distinct, and then we will be passing the array subjects. So this will fetch us db.collection dot distinct, and in distinct we will provide the criteria, and we will be passing the subject. Subject is an array, so it will find all the subjects which are having distinct, like all the subject, distinct subject. It won't be repeating math, physics, chemistry twice. It will repeat. It will be giving result only once. So see here, we have chemistry, math, physics, journalist, medium business, and small business. So it is giving distinct result. It is not repeating like in find. It will be repeating for Sunil, and it will repeating for the subjects for here twice, like math, physics, chemistry, math, physics. So in distinct, it won't be repeating. So in this way, db.collection the collection name dot distinct, and then we can pass the value to get the all the distinct value for the passed criteria. And then in the similar way, we have a count method to find the number of count. So I'll simply give count db.collection info student info collection, the collection name dot count, to see how many documents are there. So I'll give the result is 3. Let's see, we have exactly 3 documents here. The first one is this one, second one is this, and then the third one for Alan. So it is giving the number of documents in the collection. In the same way, we can find a particular value, how many times that particular value is getting repeated. Like math is getting repeated for Sunil and for John as well. So we will find, if you want to find how many times math is getting repeated, we can use find, and then inside find we will be giving subjects colon math, and then at last we will be giving count. So it will give the number of times math is getting repeated in our document. So I'll hit enter. It is giving 2, and exactly twice it is getting repeated. Like first for the user Sunil, and the second time it is for John. So math is getting repeated here and here. So this way we can use the distinct and count methods to find the distinct value and number of documents, or number of entries, or number of elements which are getting repeated using the count method.
In this lecture, we will learn about sorting documents in MongoDB. So there is a method called sort with which we can sort the document in MongoDB. db.studentinfo collection dot find is the method to get the data, dot sort, and inside sort we will provide the sorting algorithm. Like I want to sort based on the age, so I'll give age equal to 1. 1 means ascending order and -1 means descending order. So right now I'm sorting it by ascending order. Sorry, I'll print it in a better format. See here, it is getting result in the ascending order of the age 12, 16 and then 18. And if we modify this query and make it -1, then it will be in the descending order. So see here, 18, 16 and then 12. Now I'll sort based on the name. So I'll give here name dot first name. I'll sort in ascending order. So it will be in a alphabetic order. So first A, then J, and then S for Sunil. If I give it -1, it will be in a descending order. So last is A, then J, and then the first one is S. So this is the descending order. And then there is a natural order. We can sort the documents in natural order. So we'll give that natural :1. It will print the document in a natural order. Okay, sorry, I have written wrongly. It is so there is a natural order of sorting, which is sort $natural :1. So it will print the natural order of document. So with the sort method, we can sort the document in MongoDB.
Hi guys, welcome back. So in this section, we are going to discuss about data modeling patterns in MongoDB. So how we design the data, how we design the documents, or how we represent data in MongoDB in the application perspective, that we are going to design in this section. So data modeling or data in MongoDB has a very flexible schema, as we have discussed. It's a dynamic schema, it's a schemaless, or it is a NoSQL database. So it is having a very flexible schema design. And unlike SQL databases, first we need to design the database, then we have to design the tables, and then we can insert the data. But in MongoDB, we can on the go, we can insert documents, insert collections. We can decide the relationship between the documents, we can embed document, we can reference documents. So these are there are different tools which in MongoDB we can use them, and we can design our data. We can do the data modeling in MongoDB with those tools. MongoDB collections do not enforce document structure, and this flexibility facilitates the mapping of document to an entity or an object. We can map a document to an entity or an object. Anything is possible. And we can match a document to a data field, or we can map to an object. So it's so flexible. And whenever we are designing the applications, the key challenge is data modeling, balancing the needs of application as per the data. So that's what we are going to do here. And for data models, we have two tools. One is referencing through references, and another is through embedding the data. So document structure is very essential in data modeling, and key of data modeling in MongoDB is structure of documents and relationship between the data. So how we structure our document and how we relate the data, how we can put the relationship within the data, that is what going to be the key in data modeling in MongoDB. So document structure in MongoDB, and for data modeling we have two tools, as I have mentioned earlier as well. So to relationship, for one is references. Using reference, like we have a primary key and foreign key in relational database, in the same way we have references. So we can reference another document in a document. So one document can be referenced in other document. So that is what references. And then we have embedded data. We can embed an document inside a second document, or we can embed a document inside a document. So there will be embedded documents in a collection or in a document. So this is the way we can achieve the data modeling in MongoDB. So in the next lecture, we will be discussing how we can do the data modeling using references. So see you in the next lecture. Hi guys, welcome back. So in the last lecture, we have discussed about data modeling, and we have discussed about two tools that we use in MongoDB for data modeling. So in this lecture, we are going to see one of them, that is references. So there are two tools, references and embedded data. So in this lecture, we'll discuss about references. So what is references? Like in relational databases or MySQL or Oracle, we create two tables, and then to refer one table to another, we use foreign key. In the same way, in MongoDB, we can use a reference. We can reference another document in a document. Like one collection will have a one document, and inside that document we can reference the other document. So let's see how we can do that. So suppose I have an employee document. An employee document is having like data or document, like it is having ID, the object ID which MongoDB will create, and then employee name and designation. So this is the document structure for employee document. And then we have another address document for the to store the address detail of employees. So what this document look like? This document is having ID, the same ID which MongoDB will create for each document in MongoDB, and then it has a employee ID table, not table, employee ID key, which is referring to object ID 1, and then it has city and it has country. So this is the address document which is having ID, employee ID, city and country. So see, this employee ID is referring to object ID underscore 1, which is same as the object ID of this employee document. So in other terms, this employee ID is referring to this object ID. So in this way, we are referencing this object ID, this address, to this employee. So when you want to get the data for this employee address, you can refer to this employee ID, and which will refer to this document. So, and in the same way, we have contact document which is having data like ID, then employee ID, and then it has mobile number and email ID. So this is the contact. Now how these three documents are referring to each other with the employee ID, and employee ID is referring to this object ID of the employee document. So this is the employee ID, and we are referring this employee ID here with the employee ID. So in this way, we are referring these two documents to this employee document. So this is same as the foreign key concept in the RDBMS. Here we are referencing with the object ID. So object ID or ID which you create. So this employee ID is being stored here. In this ID of employee document is being stored as an employee ID in the address document, and employee ID as a contact document. So with this we can refer the which address belongs to which employee. So this is all about referencing in MongoDB. In the next lecture, we will be discussing about embedded data, which we have done that in our previous sections when we were doing the hands-on. So we have used the embedded data, but once again we'll discuss that. And latter part of this section, we will be doing hands-on with all this concept. So see you in the next lecture. Hi guys, welcome back. So in this lecture we are going to discuss about the second approach which we use for data modeling in MongoDB, that is embedded data. So we have done this earlier. Let's look at again what is embedding document in MongoDB. So let's look at the example. So suppose we have a document which is having like ID, then employee name, designation, and address. So how we do that? This is one document, ID, name, and designation. These three key value pairs are there. Three data is there in this document. Now we want to add the address data as well. So but address will have few values like city name, country name. So how we add that? So we will be embedding one more document, address colon, and then we will be giving city equal to Bangalore and country equal to India. Then we close this. So this is the whole document starting from here, and inside this document we have another document, address, which is having city and country. Then we can embed another document which is contact. So contact will have mobile number and email ID. So we have this document is starting from here with ID, employee name, designation. Then we have one embedded document here, address, and one embedded document here with contact details. And then we close this document here. So this document is starting from here, ending here, and in between we have values like employee name, designation, and one document containing address detail and another document containing contact details. So these two documents are embedded into the main document. So this main document is containing two embedded documents. So these two documents are known as embedded documents. So in this way we can embed the document inside a document. So in the last lecture, in the referencing the documents, what we do, we'll create another document here with address, and then we refer that document with the employee ID. So we'll store this ID in the address document with the object ID. So it will refer with the employee ID. In employee ID we'll store this object ID so that when we refer it will get the correct data. So this is the way we can embed the document in the MongoDB. In the next lecture we will be doing hands-on on the referencing document and embedding document using data modeling. So see you in the next lecture. Hi guys, welcome back. So in the previous lectures we have seen about data modeling in MongoDB, and we have seen how we can do the data modeling using referencing of a document or embedding documents in MongoDB. So in this lecture or couple of lectures from now, we will be discussing about relationships between the documents in MongoDB or relationships in MongoDB. Like we maintain relationships in relational databases like one-to-one, one-to-many, many-to-many. The same one-to-one, one-to-many, and many-to-many, we are going to discuss how we can achieve that in MongoDB. So let's get started. So here also we have three types of relationships, like one-to-one relationships, one-on-one relationships. So we'll see how we can achieve these one-to-one relationships in MongoDB using the two strategies like embedding and referencing. So we'll see how we can do that, and then we'll see the one-to-many, and we'll see with both the strategy how we can achieve that one-to-many using the embedding documents and referencing document, and then we'll see the many-to-many relationships in MongoDB using embedding and referencing. So we'll see how we can achieve these relationships in MongoDB in the next couple of sections. So data modeling and relationships are one of the very special and very important things that we should know, because when you are going to design your data model, you must be aware of the data modeling strategies and things to know before you start modeling your data. So if you know like how you can achieve the one-to-one or one-to-many or many-to-many mappings or relationships between the document, between the collections, then it will be easy for you to design and develop applications using MongoDB, and MongoDB will help you a lot in your endeavor. So let's get started with the one-to-one relationships in the next lecture. So see you soon. Hi, welcome back. So in this lecture, we are going to discuss about one-to-one relationships in MongoDB. While doing the data modeling, many times we need to deal with these relationships one-to-one. So in relational databases, what we do, we map one table to another table with the help of foreign key, and we do the mapping. Sometimes what we do, we keep the data in the same table and we do the one-to-one mapping. Sometimes we go with the foreign key. So it all depends how effective or how efficient you want to design your database. In NoSQL database or in MongoDB, we do this one-to-one mapping using two strategies. One-to-one we do in two ways. One is embedding and one is linking. Linking means referencing. So let's get started with this thing. So suppose I want to achieve one-to-one relationship in MongoDB. Suppose I have a customer data or customer document in MongoDB, and I have a address document for the same customer, and I want to achieve one-to-one relationship between customer and address document. How I will do this? So the thing is, suppose I have customer information like name and age, business, and I have the address information in another document with street and city, which is containing his street, city and state information. Now I want to store these two information in MongoDB. How will I do that? So there are two ways I can do that. First one is embedding these two documents in one document, and another one is I can have two documents and I can reference one with a foreign key strategy. Like I can introduce ID here, and same ID I'll use as a customer ID in this. So let's look at both of them. So first we'll look at the embedding documents, how we can achieve one-to-one in this scenario by storing customer and address into a same document, embedded document in MongoDB. So let's see. Suppose I have the customer name, business of the customer, and then I can use address object inside this document, and I can store street, city, state and all these things, and then I close the main document. So this is the main document starting from here, ending here. In this I have name, business, and then I can store the address here. But I can embed the address document inside this customer document, and I can store this in this way. This is an embedded document inside the customer document. So in this way we can achieve the one-to-one. One customer, one address, one customer, one address, one address, one customer. So in this way we can achieve the one-to-one in MongoDB. So this is the one strategy, embedding the document inside the main document. The next thing we'll see the referencing or linking one document into the other document. So let's see that. So here we'll see the referencing, how we can reference and achieve the one-to-one relationship. So suppose I have this customer document with ID, name and business. So this is the customer document. Now I'll have the another document in MongoDB with the address, and here what I'll do, I'll store the city, state, street of the customer along with this three information which already was there in the previous document. I'll have one more ID, one more key value pair, one more field, customer ID, and that customer ID will referring to this ID of this customer field. So this is the address document and this is the customer document, and these two documents are getting together with this ID field. This ID field I'm referring here with the customer ID field. So in this way we can refer one document into other. So this is the way we can refer one-to-one relationship in MongoDB. So this is how we can achieve the relationships one-to-one in MongoDB by keeping foreign key kind of relationship with this ID. I'm referring here with the name cust ID, and in this way we can recognize that okay, this address belongs to this employee or this customer. So this is the way we can achieve the one-to-one using embedding and referencing strategies. So in the next lecture we will be discussing about one-to-many relationship in MongoDB. So see you soon. Hi guys, welcome back. So in the previous lecture we have gone through the one-to-one relationships in MongoDB, and we have seen how we can achieve that using embedding a document inside a document and referencing a document from one document to another document. So in this lecture we will be going through one-to-many relationships in MongoDB while doing a data modeling, how we can achieve that. So let's get started. So suppose I have a document which is a student document which is having information about student detail, and we have another document with the subject which will contain the which student is having going through what are the subject one student is going through. So this will be having information, and I want to achieve the one to many. Sorry guys, it's not a one to one, it's a one to many. So I want to achieve one to many relationships in MongoDB with the student detail, and one student can have many subjects. So these relationships I want to achieve. So what student data is having? We are having a student document which is having name, school, and we have the subject document which is having teacher name, subject. So and one student can have two or more subject. So it is having two documents like teacher John is teaching science and teacher Mark is teaching subject biology. So one student is having two subjects here. So here we want to do the data modeling using this one-to-many relationships. So let's see how we can achieve with our strategies, embedding and referencing. So first we look at the embedding this document inside the student document and how we can achieve. Suppose what I'll do, I'll write a document like which will have the student name and school as usual, and then what I'll do, I'll have a subject array. So inside this document I'll have another document with subject array, and this subject array will contain documents for each subject. Like this subject array will have first document as a teacher for the subject science, and it will close here. Then it will have another document for subject biology. So see here we have achieved this one-to-many. One student will have many subjects here. Subject array will have the subject science and subject biology both inside this array. These two documents are kept inside this array, subject array. So in this way, if you want to fetch student details, you can fetch with a single query because we are embedding this inside a single document. So this way we can achieve one-to-many. One student is having two or more subject. So let's see the second strategy, referencing, how we can achieve this. Suppose I'll create a document with the student document which will have the ID, name and school, and then I'll have one more document for subject, and it will have the teacher name and subject name along with the student ID. So in this what I'll do, I'll create separate documents for each subject. So here science subject will have the teacher name and subject science, and it will have the student ID 101 which will refer to this one, and then I'll have the one more document for subject biology which will have the teacher name, subject biology and student ID 101. So see here we are achieving one student is having two or more subject, one-to-many relationships. How we are achieving? With this foreign key kind of relationship ID. Here we are referencing with the student ID, and here as well as student ID. So this student ID will refer to this student ID, and this student ID of the second document of subject document, it will refer to this. So here we are achieving one to many relationships with this ID. This ID is referring to this one and this one. So in this way we can achieve one to many relationship in MongoDB. So this way we can achieve one to one and one to many relationship. One to one we have discussed in the last lecture, and one to many we are discussing right now. So this ID field will be referring to these two documents student ID field. So in the next lecture we will be discussing about many to many relationships in MongoDB. Hi guys, welcome back. So this is Sunil. I'm going to discuss today many to many relationships. Last week we have discussed about one to one and one to many relationships, and this one was pending from last week. So this weekend I'm going to cover this and many more lectures I'm going to add in this course. So let's get started with the many to many relationships in MongoDB database design. So when we talk about many to many relationships, what is the many to many relationship? Suppose we have like in relational databases, MySQL or Oracle, we achieve this many to many relationships using joins. So we join too many tables, two or more tables to achieve many to many relationships. Like if we have one table and another table, we use the foreign key and two-way foreign key relationships to achieve this many to many relationships. In MongoDB, what we do, suppose we have a author document, okay, and we have a article document. So one author can write many articles, and one article can be written by one or more authors. So sometimes when you look at the blogs or the articles, it will be in articles in a newspaper. One article will be written by two or more authors. So one article can have one or more author, and one author can write many articles in different categories. So this is one many to many relationships. So how we achieve these many to many relationships while writing documents in MongoDB? So that's what we are going to discuss in this lecture. So there are two ways actually. One is two-way embedding and one is one-way embedding. So in this lecture I'm going to concentrate on two-way embedding. One-way embedding is I don't recommend, so I'm not going to discuss one-way embedding. I'm going to discuss about two-way embedding. What is two-way embedding? Suppose we have an author and an article, and we want to achieve the many to many relationships. So suppose one author, like suppose Anil Ambani, the name of author is something, and he has written articles 1 and 2. And in the same way, another author is there whose ID is 2, and he has written article 2. So see here, article 2 is common here. Articles 1 and 2 in the first author as well, and in the second author as well, article 2. So here we are embedding articles in the author document. And in the same way, if we look at the article document, it is having ID, title and categories, and then it is having authors document embedded in that. So we are referring this from here. In the author document we are referring articles, and in article document we are referring authors. So we have the second article which is written by the second author. So in this way, see, this article is having one and two authors, and this article is having only second author. So in this way we are achieving two-way embedding. We are embedding articles in the author document, and we are embedding author in the article document. So see here, we are this here also we are embedding articles, and in here we are embedding author. So two-way referencing is there, two-way embedding of documents are there. So this is the two-way embedding of a many to many relationships. So here one author has many articles, and one article has many authors. So in this way we can achieve many to many embedding, many to many relationships in MongoDB. So see you in the next lecture. Hi guys, welcome back. So in this section, we are going to learn about user and role management in MongoDB. So in this particular section, in this particular lecture, we are going to create an user in MongoDB database, and then in the subsequent tutorials, we will be seeing how we can grant roles to that users, how we can create different users with the specific roles, and how we can use the user authentication in MongoDB. So let's get started with this user creation in MongoDB database. So I'll open the Mongo console. So this is the Mongo console I'm using. So you can run a command show databases, and it will list down all the databases existing in your MongoDB. So these are the databases I'm using. Class info for this course, so I'll switch to that database. So you can use a command use and then database name to switch to the database, and then you can run a command show collections to list all the collections that we have created. So this is just to revise. And now I'll tell you one more thing. To get the users existing in that database, you can use the command db.get users. So this is just a simple command to list all the users. See here, till now we have not created any users in database. So there is no users, the array is empty. So now we will be creating our first user in this class info database. So let's get started. So to create user, we have a simple command, a simple method, which is a create user. So create user is a method through which we can create an user in a MongoDB database. So inside this we can create an user. So create user, and then we can close this bracket, and inside that we have to write whatever the username and the roles inside the curly brace. So let's get started. So user, the first field is user, and then you can give the username here. So suppose I'm giving Sunil, and then the next thing is password. So per password there is a field called pwd for password, and here you can write a password which you want to create. So I'm giving Sunil, username and password both as Sunil, and then come the roles. So you can assign roles to your user. So roles is an array which will be containing role and database. So inside this we will be giving role, and role for now I'm giving user admin. So this is an role in MongoDB that we can assign to a user, that is user admin. The user admin, this thing we'll discuss in later tutorial what are the different roles, but this user admin is a admin user which is responsible for managing all the users and their roles. So we can create another user with this user, and it will be responsible for all the user management kind of thing. So this is the role I'm assigning to this user Sunil. So you have given, and then we have to specify the which database. So I'll give the database name, and the database name is class info. So this is pretty simple. So see here, we are closing this, and then we are closing this roles array, and then we are closing this, and then the main create user function. So now this is the command create db.create user. Inside that we have to give user, username, password, and roles. Inside roles we have to give two things, roles for that user. So here I'm giving user admin, and then you have to specify the database for which you want to create this user. So now I'll hit enter to create the user. So see here, successfully added user Sunil, role is role user admin, and db class info. So let's query the users. So I'll query now db.get users to get all the users for this class info database. See here, now it is returning. Earlier it was returning a blank array, now it is returning with some information. So get users is giving like id class info dot Sunil. So this Sunil is referring to this database. So this Sunil user is belongs to this database. So id field has been created by default by the MongoDB, and the id field is database dot username, and then username db, and then password. The password is not reflected here, but because the we should not show the password, so that's why it is hidden. Then the DB name, and then the role user admin, and DB is class info. So this is how we can create an user in MongoDB database. Hi guys, welcome back. So in the previous lecture we have seen how to create an user in MongoDB database, and in this lecture we are going to start our MongoDB server with the authentication enabled. So till now we have started the MongoDB without any authentication or authorization. So we can actually start the MongoDB server in two ways. We can start the MongoDB server with authentication enabled, and we can start without any authentication. So till now what we have done, we have started the MongoDB server without any authentication. That's why it never asks for the password, username and password. So in this lecture we are going to start the MongoDB server with authentication enabled. So I'll open the console. So I'll just start the MongoDB server. So we know how to start. We can start with MongoDB-db path, and then we give the path for the data/db folder. So where the MongoDB stores the data by default. So this is the normal command to start MongoDB. In this we can add auth -auth, and then we can give the db path and path for the data/db. So when you give this -auth, it means MongoDB server will be started with the authentication enabled. So let's start it. So see here, now you can see here the server has been started and waiting for the connection. It is saying option security authorization enabled. So here you can see another option, security authorization enabled. So now the server is started with the authorization enabled. So let's connect to the Mongo cell. So here I'll connect to Mongo cell, and earlier we were connecting to the test database and we are doing all sort of things with that. So see, now it is showing connecting to test. So see here, it is showing error while trying to show server startup warning not authorized on the admin to execute command. So why this error? Because we are trying to enter into the MongoDB without providing the valid username password. So see here, if you use the so DB, it will throw you not authorized on admin to execute this thing. So what we can do, we can go to the particular database which you want to connect. So I'll use class info. So I'll be switched to the DB, and here if I try to run the command so collections, again I'll get the same not authorized for query on class info. So now what I can do, I can use the db.auth method to authorize the DB. So I have created the user Gupta with the password Gupta. So this is the user which we have created on the class info database in the previous lecture. So now I'm authenticating this database with this. So I'll hit on enter. See here, 1 means true, means I have been authenticated. The Gupta user has been authenticated to do some activity on the database. So I'll use show collections now, and see here, now I'm getting the result. So here I was getting error not authorized for query. Here I'm getting the after authentication I'm getting the result. So this is the way we can enable authentication on the MongoDB server, and this is the way db.auth and then username and password we can pass to authenticate the user. So this is the way to enable authentication in MongoDB database. See you in the next lecture. Hello guys, welcome to this Q&A section, and here I'm going to tackle a problem which was raised by Hemal. So 4 days ago he asked this question that he's going through authentication problem where he encountered an issue, and what he did actually, he started the server with authentication, then he successfully authenticated the user as well. So first he created the user, then he started the server with authentication on, and then he successfully authenticated the user as well, and then he is trying to get the show collection. When he is getting these errors: not authorized, code 13 error. Okay, unauthorized access. Why he is getting this error? Because he created a user with role user admin. So user admin will not have all the read access. He is having the accesses to just create user, delete user, drop user, all those things for user management. So he may not be having access to the databases. So for that we need to provide the database access to read or write access to this user. For that, what we need to do, we need to run the query, this run db.run command query to grant the user role. We need to assign him a role, read and write. Okay, for this database. So for that we need to run this command. So to run this command, what we need to do, we need to first stop the Mongo shell, we need to stop the MongoDB server, and we need to start the MongoDB server without authentication. And then once server is running, we need to go to the Mongo shell, and there we need to run these commands. Always remember, we need not to run the command with authentication on. We need to start the server without authentication, and then we need to run this command. Once you run this command, this read access role will be given to this user Hamel, which is having a user role as admin. Okay, so once you done this, and then you need to close the Mongo shell, then you need to stop the MongoDB server, and again you have to restart the MongoDB server with authentication on, and then you need to open the Mongo shell, and there you need to go to this class info server. You need to type use class info, and then you need to use the db.auth, and you need to provide this user's username and password. And once authentication is processed, done, you need to run all the commands. You can use show collections, show dbs, all those things you can run. So basically this is the solution for his first question. So now the next thing is, he is telling that he was not able to restart the MongoDB server for some reasons, and what he did, he was just restored his VM snapshot, and now he is successfully started the MongoDB server with authentication. Now he is having one more issue, and that issue is because what he did, he started the MongoDB server with authentication on, and then here what he is doing, he is coming to Mongo shell, and he is going to the database class info by running the command use class info. So now he is switched to this database, and what he is doing, he is running the command show collections, and he is getting not authorized on this database to execute this command, unauthorized. Why he is getting this error? Because he started the MongoDB server with authentication on. So now you need to provide the user information to do anything on this database. So before running this show collection command, he need to authorize the user. So he need to write the command db.auth Hamel, whatever username password he is having. Once you authorize the user and then you run this command, you will not be getting this error. Okay, so Hamel, you need to first, after this use class info, you need to use db.auth, and you need to provide the username password for the user, and then once authorization is done, you need to run the command show collections, and it will be working perfectly fine. Okay, so let me show you this problem's replication. I have replicated this problem, and I'll show you. See here, I'm running the MongoDB server with authentication on, and I'll hit enter. So now MongoDB server will be started with authentication on. Next thing what I do, I will go to Mongo shell. See here, now I am inside the Mongo shell, and what I do, I'll use class info, and here if I run the command show collections, I'll get the error. See here, I'm also getting the same error message, not authorized on class info to execute command. Okay, unauthorized access. To to tackle this, what we need to do, we need to first db.auth, and we need to provide the username password. So for that, we need to provide Hemal username. Suppose you have given username as Hemal and password as Hemal, and then you need to hit enter. So this will authorize the user. See here, now is showing 1, it means the user has been authorized. Now if I run the command, so collections, it will be showing everything. You can use so dbs, everything. Sorry, so dbs we cannot run because we are inside a database. So we can run the so collections, and it is working fine, right? So you need to authorize the user first, and then you need to run the command if your server is running with the authentication. Okay, so I hope this will resolve the issue which Hemal is facing currently. And okay, so Hemal, please go through this lecture which I'll upload now, and you will be finding solution for your issue. I hope it helps you, and if you have any further question, please ask. Thank you. Hi, welcome to the doubt clarification section. So while going through the course, you got a doubt, or you got questions to be asked, question to be answered, which you got when we are going to the course. So just pause the course video, the lecture video, write down your questions, your doubt on a notepad or on a piece of paper, and post your questions on the course discussion board, just like this. You can find on the right side of the course area, and then I will be there to answer all your questions within a day time. So I answer all the questions within a day time, and sometimes, and most of the times, I answer within just 4 hours. So I'll be answering then and there. So raise your hands, ask as many questions as you can ask. So see you in the course and ask. Hi guys, welcome back. So in this lecture, I'm going to discuss about the natural operator which we use for sorting the documents in a natural order. So what is natural order? Natural order means the way we insert the document in a MongoDB collection, it will return in the same way. So when you insert like id student name 123, it will return in the same order 123. But this is not the this is the natural order, but not the insertion order. There is a slightly different between the insertion order and the natural order. Natural order means in the way document stores internally in the MongoDB. So naturally means when you insert document like 123, it will return 123. When you update any document, then it will return the updated document at last. So that's how MongoDB stores data internally. So updated document will go at last when you sort with a natural order. So that is, it's not the insertion order, it's just, you can say, the update order. So the way documents are getting updated, it will return in that order. So the last updated document will be at last, and that's the thing. So I'll be showing this with an example. Why I'm taking this topic now, because we have discussed the natural order much earlier, but we have discussion here. So one of our fellow learner, Muhammad, has asked this question, like natural order means the original order of insertion. So there is a slightly different, it's not the original order, insertion order, it's just the way you update, the way it will return. So most updated document will be coming at last when you search with the sort with the natural order. So let's do one hands-on with that. So this is our MongoDB. So we are using class info for this course, class info DB. So I'll switch to that, and what I'll do, I'll try to insert create a collection. I'll name it learners. Okay, dot, and I'll try to insert something. Insert, and what I'll insert id, sorry, underscore id colon, I'll give 1, and then I'll insert name as Sunil, and insert. So I inserted one document. Now I'll change this to 2, id 2. I'll give a name Muhammad, for 2, and then I'll insert one more for 3, id 3. I'll give it a name something John. Okay, so now I have inserted 3 documents. Let's query this. So learners dot find dot sort, and then in sort will give $natural colon 1. See here, it is giving the result in the way we have inserted the document. The first id 1, id 2, id 3. So it is maintaining the insertion order because we have not done any update. So let's do an update on this. So what I'll do, I'll write an update, and in this, okay, I want to update the id 1, and I want to update id. So I'll give id colon 1. So this, and then I'll put $set, and I'll be updating last name. I'll give last name as, for my name is so I'll update this. Something wrong. Okay, I have given semicolon here, it should be a colon, and I'll hit enter. See here, it has been modified. So now I'll again do the sorting with natural order 1. So let's see here, now it's showing 2, 3 and 1, the one which we have updated, this document we have updated, so it is coming at last. So when you sort with the natural order, it's not the insertion, it's the natural order. Natural order means the way you update the document. If you have inserted and not updated, it will return with insertion order. If you update any document, then it will follow the update order. So that is the difference, and I hope this resolve the Muhammad's questions also. So see you in the next lecture. Hi guys, welcome to the doubt clarifications session. So in this lecture, I'm going to discuss about questions which has been asked by one of our fellow learner, and Mehmet Adin. So Mehmet has asked the questions like explain method do not return execution states. So in lecture 23 here I was showing about the indexes, and then I have used the explain methods to show the execution states, how many object it is scanning. So when you use index, it will scan less number of object, and if you don't use indexes, it will scan all the object. So when you use explain method, it will return the execution stats, like how many objects it's going, what is the cursor, what are the cursors being used. So it will give you some stats. But what problem Mehmet faced when he used explain, he said that instead of returning execution stats such as cursor, ENS scanned object, it just returned the query planner pointer. So he asked, is there any way to exist to get the execution states? So in this lecture, I'm going to show the demo how we can do that. I have replied to him through the message, but here I promised him that I will be doing a lecture to show this. So let's do that. So execution stat, to get the execution stat, we use explain method, but explain method sometime depending on the kind of server MongoDB versions you use. Sometimes if you use the explain method flat without anything, it may not return you the desired result, desired execution states. So why is that problem is happening? So that's what we are going to discuss in this. So execution method takes three parameters, and the first one is query planner, this one, and then execution stats and all plan execution. So these are the three parameters we can pass to this explain method. And apart from these two, we can also pass through true or false, the boolean value true or false as well. So true will be, by default it will be true, and if you use false it will be a flat, like a without any parameter what result you will get. If you use false you will get the same result, and when you use true you will get the result what you get with the query planner. So by default query planner is the parameter. So these are the three parameter we can use depending on the our requirement. So like Mehmet, he was looking for the execution stats, so he can use the execution stats parameter in this explain method to get the desired result. So let's see how he can do that. So for that I have started the MongoDB server. So I'll just connect to our database. We are using class info database here, and I'll just see which collection we are using. Sorry, I have used the huge class info, and I'll use so collection. So this is the collection which we are using, which is student info collection. So I'll use db dot students info collection dot find dot. See here, for me it is giving me the these are the stats, like number of objects scanned, ns scan, ns object, all plans 3, all this. But if I pass the parameter execution stats, what will happen? See here, I'm getting much more detailed result from this explain method when I'm passing execution stats. See here, earlier I was getting only this, now I'm getting all plans, cursor, basic, is multi key, ns object, false. So based on the requirement what the server which has been used, the filters set false, stats, so all these things, if you need you can go with the execution stats to get the much more detailed result. And we can use query planner as well. See, query planner will give more or less same result, and in the same way we can use see here, we will be getting the much more detailed result or execution stats if we use any of these three parameters in the explain method. We can also use true or false. So let's see, true. See here, we are getting more or less same result when we are using true, and if I use false I'll get the less stats. So see here, if you use without false you'll get the same result. So this is how you can use the explain method with these three parameters. So this is how, if you are not getting a desired execution states when you are using explain method, you can try with these three options and these three parameters, and you will be getting your desired execution stats. So this is it, and so see you in the next lecture. Hi, welcome back. This is Sunil, and we are in the doubt clarification section. So today we have a very interesting question from Gaurav Mittal. So Gaurav has asked a question about aggregation, and he wants us to do some group by using the some mathematical calculation. So he has a JSON document. So he is having this JSON document which is having two things, name and prod. So for prod he is having two entries, A and B. For A he is having some quantity, for B he is having some quantity, and he is having for X and Y. So what he want us to get the sum of product group by name. So we will be grouping by name. So for X he want total product, so A plus B 100, and for Y A plus B 25 plus 75 100. So he want us to group by name and get the sum of product. So let's see how we can achieve this. So while discussing here in this course about aggregation, I have explained about aggregation method, aggregate method, distinct count. So I have not explained about the group. So here I'll explain how we can achieve this thing using group. So, and this we can't achieve by simply using group. We have to use the map reduce function. So I'll explain map reduce in a different section. In some time I'll add that section and I'll explain how map reduce works in MongoDB in great detail. But for now I'll explain this doubt of Gaurav with a simple example. In this I'll use a reduce function. So it is not difficult to understand. I'll explain that, don't worry. And for the map reduce I'll add a different section, and there I'll explain about map reduce in MongoDB. So let's get started to get this solution. So I have MongoDB server up and running, so I'll try to connect to the Mongo cell, and now I've connected. I'll create a test DB, and what I do, I'll create the document which Gaurav has provided. So I'll create a collection, I'll call it test DB, and I'll insert the data, the document which Gaurav has provided. So Gaurav has given us a document where, he is having name. For name he is having X, and he is having prod for product, and for product he is having, for A he is having 43, I guess. So let's verify that. 53 and 47. So for A he is having 53, and for B he is having 47. So sum will be 100. So I'll insert this first. Okay, it is saying it is already existing because I have tried. So let me drop this. Let me create a different I'll test database, and I'll try to insert this. Okay, so now I have inserted correctly. Now I'll insert for Y. For Y is having 25 and 75. Okay, so I'll insert for Y as well. Now I'll query db.find.pretty. So now we have the document which Gaurav has provided, name X and product A and B, for name Y, product A and B. So now we want to group by name and provide the total sum of the products. So for that we have to use the group method, group function of MongoDB, and then in group we'll be using key and reduce function. So let's see how we can do that. So I'll use test db dot group. Okay, and this group I'll be using key, and for key what I'll give name. So we want to group by name, so I'll give name :1 so that it will be grouped in ascending order. So let me scroll little up. Okay, so now we have given key name :1, so group by name, and then here we have to use the reduce function. So reduce function, this way we can write a reduce function, and reduce function will take two variable, cur and result. Okay, so I'll be writing this function, and what will be there in this function, we will be performing the mathematical calculation for a and b, which is here for prod a and b. So let's do that. So what I'll be doing, I'll be creating a variable total. In that I'll be storing this value. So total and plus equal to cur dot, what we want to add, we want to add this prod dot a and prod dot b. So prod dot a plus prod dot b. Okay, so now we have this function written. Okay, so I'll add a semicolon here, and I have to give the initial value for the total. So for initial value of total will be 0. Okay, so now let's run this and then I'll explain again. Okay, so here I'm using cur.prod a, so I have to use cur.prod b. Okay, so that I forgot. See here, now we are getting the required result. So see here, we have grouped by name x, and total we are getting 100. For y we are getting total 100. See here, so what we have done, we have grouped by name, so we are getting the result by name x and name y, and here with the use of reduce function we are adding cur.prod a plus cur.prod b. So it is adding the each product. So for y, a plus b is 125 plus 7500, and for x 53 plus 4700, so it is giving total products 100. So this way we can write a reduce function in MongoDB while grouping up the data. So I hope this is the answer, the correct answer for the Gaurav's answer. Gaurav, if you have any doubt, you can ask further questions. So I hope I understood your questions correctly and this is what you wanted. So see you in the next lecture. Hi guys, welcome back. So in this section we are going to learn about the regular expressions in MongoDB. So what is regular expression? Regular expressions are used to search a pattern. With regular expression we can search a particular word in a string. Suppose you have a document and you want to search something. You want to search an employee with the first name Ram or John, then you can use the regular expressions to query this thing. So like in relational databases we have a search capabilities like something like we use like operator in relational database. In the same way MongoDB also provides the regular expressions. So we can use regular expressions to match the pattern in the string while querying the data. Querying the document, we can use the pattern matching with the use of regular expressions. We can also search for a pattern or word in a string like first name, last name, or a name starting with particular word or ending with some word. That kind of search capabilities MongoDB provides with the use of regular expressions. And for this thing we use regex, $regex operator. So this regular expression operator we use for pattern matching or searching for a particular word or string in a string while querying the MongoDB documents. So what we can do with this and how it works, we will see a simple example here, and we will do the hands-on in the next lecture. So regex operators, regular expression operator, we can search for, like you have a document which is having a employee's detail with the first name, employee name, department, salary, and etc. And you want to search for a particular employee detail. So how you can do that? So we can use the db.employee. This is the collection name, and this is the find with which we can search the find the document, and then we can use the employee colon, and then we can use the regex colon Sunil. So it will search all the documents and it will return the result for the document which are having the employee name Sunil. So this is the way we can write a regular expressions in MongoDB. Dollar regex colon the string which you want to search. So this Sunil I want to search, so I have given Sunil here. So this way we can write. We can write this same expression, same query in this way as well. Without using the regular expression operator, we can use this thing slash and then your string which you want to search, and then inside the slash you can put the string. So this way also you can put the query. So in the next lecture we will be seeing how we can use this regular expression operator in MongoDB, and we will do more hands-on using the like finding the this thing first name, last name, or employee name starting with A or ending with Z, something like that. So we'll do more hands-on with regular expressions in MongoDB. So see you in the next lecture. Hi, welcome back. So in the previous lecture we have learned about the regular expressions, and we have seen not with example, with the sample code we have seen how we can use the regular expressions, and there are two ways we can use this regular expression with the dollar regex, this regular expression operator, and we can use without this as well. So we'll see using this dollar regex operator in this lecture, and in the next lecture we'll be seeing how we can perform the same thing without using the operator. So let's get started. So I have started the MongoDB server here, so it is up and running. Okay, so what I'll do, I'll just try to connect our Mongo cell. So type Mongo. Okay, now we have connected. So we know we are using our database class info. So I'll just type that, use class info, and then I'll type show collections. Okay, so we are using student info collection. So write a simple query to refresh our memory. So what we have with the collection, what are the documents we are having, dot find dot pretty, and okay, something wrong, student info collection. I think it's a students info collection which we are using. Yeah, so it's the other one, the students info collection. So we have this data, we will try to query this document with the regular expression in MongoDB. So first what I'll do, I'll try to search for the first name as Sunil using the regular expression. So let's get started. So what I'll do, I'll use find, and inside find what I'll do, I'll write, sorry, here I'll give name dot first name, because we have name first name inside the name. So we'll give name dot first name, and colon we'll use regex. So I'll use dollar operator, and for this I'll use Sunil. Okay, so I want to find the first name as Sunil. So what I'm using, name dot first name and then we can give directly Sunil here, but here I'm using the regular expression to find the first name, all the documents which are having matching first name as Sunil. So let's see what result we will be getting. See here we are getting, let me put in a better format. So see here it is giving us the result first name Sunil, the document which is carrying first name as Sunil. There is no other name with the Sunil. So, and okay, correct. So now what I'll do, I'll try to put this in a different way. I'll put like this. So let's see what result we'll get, then I'll explain. See, we are getting nothing because it is okay. Let me remove this. See here we are getting the same result, and what this expression means here, what I'm doing, I'm passing using the $regex. Here earlier I was giving Sunil. Here what I'm giving expression which is saying it should start with the yes. So when you use this symbol, it means symbol, and the letter which you give, it means it will search for the documents which are starting with the yes, and for the first name it will search the document which are starting with the yes. So Sunil, yes, it is starting with the yes, so it is giving us the result for the document which is carrying the first name as Sunil. What I'll do, I'll change it to A, and we see what result. See here, now we are getting the result for Alan. In the same way, we can use ending with n. So when we use this thing, the letter and then the dollar symbol, it means the first name which is ending with n. So let's see. See here we are getting so many results because we have two names, John and Alan. Both are ending with n. So it is returning us two documents. So Alan is ending with n and John is also ending with n. So this will give us this thing. So in this way we can perform the regular expressions. So we can go with the full string search like this. Sunil, you can search with the full name Sunil, or either you can start with yes like this or end with the n or whatever you want. So we can pass the pattern here with this operator. So in this way we can use the regular expressions in MongoDB. In the next lecture we will be writing the same query, but we will not be using the $regex operator. We will be doing this without using this thing. Okay, so see you in the next lecture. Hi, welcome back. So in the previous lecture, we have seen how we can use the $regex operator for pattern matching in MongoDB. So in this lecture, we are going to do the pattern matching without using this operator. So we can use this operator, and we can do the pattern matching without this as well. So let's see how we can do this. So this is the query which we have written in the last lecture. So here we are using this operator, but if you want, you can just remove this. So we can remove this regex operator, and we can do the pattern matching like this as well. So we are doing pattern matching on the first name, and we are searching with the ending with n. So let's see what result we get. See here we are getting the John and Alan as usual, what we got through the earlier in the previous lecture, the same result we are getting. So John is ending with n and the second result is Alan, which is also ending with N. In the same way, we can do for the starting with as well. So we can use the operator, and yes, so let's see here we are getting the result for Sunil. So in this way we can use the pattern matching without the $regex operator. So here regex operator is not written, but it is working in the same way. So this is the way we can use the pattern matching in MongoDB with the operator and without operator. So see you in the next lecture. Hi, welcome back. So in the previous lecture we have seen how we can do the pattern matching without regex operator. So in this lecture what we are going to do, we are going to do a pattern matching for case insensitive and case sensitive data. So suppose you are searching for something and you are searching with the small letter and it is having a capital letter and you are not getting the required result because of the case sensitivity. So how we can ignore the cases, that we are going to do in this lecture. So let's get started. So this is the statement which we are writing to query the first name which are ending with the N. So we are getting this result for John and Alan. So what we can do else, let me clear the screen. So we are using this instead of using, see here for small n we are getting the result, but if I make it capital N and I hit enter, it is not returning any data because we have the data with the small n, because capital N ending is not there. So how we can do this thing, how we can achieve this? To achieve this, we have a feature in regex. We can use the $options, and inside this we can pass I. If you pass option I, it means it will ignore the cases and it will return the data. So we have the data for documents for small n, will pass the capital N and we'll say the MongoDB that ignore the cases and return the result. So it will ignore, it will return the data for both capital and small, both ending with N first names. So let's see here now we are getting the result even though N is small, but we have passed the options I, so it is ignoring the cases. It is making this query as a case insensitive. So whether it is capital N or small n, it will return the same thing. So let's test this with the something starting with, suppose John is starting with capital J, we'll check this with the small j and we'll see whether it is returning the result for John or not. So see here we are getting the result for John even though it is small letter. We are querying for a small letter, but since we have used case insensitive options, it is returning the same result. So this is the way we can use the case insensitive option to query to match the pattern in the case insensitive way. So we can use these options. You have to remember these options. So options, it will be options and then we have to pass the I. So there are more values which we can pass to these options, but that we are not going to discuss now. Hi, welcome back. This is Sunil and we are into the doubt clarification section for the MongoDB course. So today we are going to discuss about a question raised by Vikas Pandey. He has asked a very good question of fetching last and record out of a query. So he's telling that he is having a document in a collection like this, which is having name, courses and marks. So he's telling that he is running a query like this. For the name, he is providing the regular expression 0 to 9, name start with 0 to 9, and then the courses he's telling ending with L. So and he don't want the result for the marks. So he is running this query and then he's telling he is running another query and he is limiting it by running the query with the limit function, and he want to limit with some like he want to limit the number of records. So when he is telling, when he is using the limit n, he is getting the first n documents of the collection, but he want the last n records. So that's what his doubt. So let's discuss that. So for that, what I have my MongoDB console up and running. I have connected to the Mongo shell, and I'm going to use the testDB database which we have created in the last doubt clarification lecture. So now what I do, I'll create the sample which Vikas Pandey has given. So I'll create db.studentinfo.insert. I'll insert the name and course as per the Vikas has given, and to get the n records, I'll insert some more documents. I'll insert 6 documents in this with the different entries. So let me insert this. I'll paste it here. So now we have our collection ready with the document. So let's query this studentinfo.find.pretty. Okay, so see here, now we have documents in the collection for student 01, student 02, student 03, student 04, 05, 06. 6 documents we are having. Now we see what he is asking us to do. So he is telling, he is running this query. So let's run his query to understand what he is trying to do. So see here, he is providing. Okay, let's run this and see what we are getting. See here, he is getting result for 01 student, and he is getting Java and Perl. Okay, next thing what he is doing, he is telling he is limiting the records by providing the limit n option. So let's do that also. So we'll provide it to 5. See, still we are getting 1 record. Why? Because see here he is giving, I'll remove this, okay, and what I do, see now we are getting 2 records. Okay, now we are getting Java for 01 student, we are getting Java and Perl, and 03 student we are getting Pascal and Perl. Why we are getting this? Because we are querying courses which are ending with L. See here, ending with L he has given. So we are getting this thing, ending with L Perl and ending with L Pascal. But we are not getting the result for COBOL and HTML, right? That are also ending with L, but we are not getting because we have to provide the option for that. So we case sensitive, those are in COBOL. L is capital L, that's why it is not showing. So for that, what we can use options colon I. So when we use option colon I, it will make the query case insensitive and it will result all the things. So let's run this. See here, now we are getting 4 records: Java, Perl, Pascal, C, HTML, Fortran and Python. 01, 03, 04, 06. Now we have limited it to by 5. Okay, let's limit it by 3. So see here, now I have limited it by 3 records. So I'm getting Java, Perl, Pascal, C and HTML, Fortran. See here, when we had, let me show you, when we had 4, it was showing us Java, Perl, Pascal, C and HTML, Fortran the first. So Python, COBOL was the 4th one. See here, when I'm limiting it by 3, it is showing me the first 3. That's what Vikas has asked. He is asking, when I'm limiting, I'm getting the first n records. The first 3 records are showing here, but it is not showing the last. So he wants the last n records. So for that, what we can do, we can, before limiting, we can use the sort function, and inside sort we can provide the $natural. We can sort it by reverse. Okay, So what I'm doing here, I'm first getting the result for courses ending with L. So I'll get all 4. I'll reverse the order by providing this sorting. So I'll sort it in a reverse order, so it will be coming like this, and then I'll limit by 3. So let's see what we give. So this time we should be getting the last 3 options. We should be getting Pascal, HTML, Python, these 3. We should be getting these 3, not the Java Perl. So let's run this. See here, now we are getting the last n records: Python, HTML and Pascal. We are not getting the first 3 is Java Perl. First 3 is Java Perl, HTML, Fortran. Last 3 is Python, COBOL, HTML, Pascal, C. So see here, now we are getting the last 3. Okay, so this way we can query the last n documents of a collection. I hope I have answered correctly what Vikas Pandey was asking. And Vikas, if you have any other doubt, please feel free to ask me. Thank you. Hi, this is Sunil and welcome back. In this section, we are going to discuss about a very important feature, very important functionality in MongoDB, that is MapReduce. So we are going to see how we can use the very popular MapReduce functionality in MongoDB for querying the desired data. So let's get started. So first we start with the MapReduce definition. So what is MapReduce? So there are 2 functions, map and reduce, mapper and reducer. So what mapper does and what reducer does, that's what we are going to discuss. So together we call it MapReduce in MongoDB. Okay, so what is MapReduce? So MapReduce in MongoDB is very simple fundamental stuff. Like MapReduce is a data processing paradigm for condensing large volumes of data into useful aggregated results. So this is the definition as per the MongoDB documentation. So MapReduce is a data processing paradigm for condensing large volumes of data into useful aggregated results. So suppose we have a large volume of data containing lots of information about particular user or particular employee or particular student or whatever. So what we want, what we do with the large amount of data, we can't figure out what is going on, what is there. We can't go line by line and search. So for that, we use MapReduce function to get the aggregated result as per the query we provide. So we are going to discuss this by a example. We'll be seeing an example how we can use MapReduce to get the aggregated result, useful result that we can use in our application out of the large volume of data. So for MapReduce operations, MongoDB provides MapReduce database command. So this MapReduce is the database command that we are going to use. So to use this command, database command of MapReduce function, we just need to use db.collection name.mapreduce, and inside that we will be providing the mapper and reducer functions and other queries. So suppose we have a document which is containing employee details, and employee is having certain loans, few loans employee is having. So what we want, like this document is containing employee ID, loan amount and loan status. So there will be several documents for a same employee. Like one employee can have many loans with different banks or same bank. So it is having employee ID and loan amount and loan status. So employee can have a active loan and an employee can have a expired loan. So it will have the employee ID for different employees, and it will have all the active loans and all the expired loan details with the loan ID and employee ID. So what we are going to do in this, we are going to find the per user, per employee active loans, and then what we do, first we will be using the map function to find employees and the active loans. So first map function, what we do, we will be finding the employee ID and all the active loans, so loan ID, and then with the reducer function, what we do, we'll be finding per employee total sum of the loans. So first we get all the loan ID, and then based on the loan ID, reducer will go each and every loan and it will sum it up all the loan amount. So at last we will get the employee and total loan. So total active loans. So that's what we are going to do in this example. So suppose how we write the MapReduce function. So see here, MapReduce, as I said earlier, we will be using db dot, and this loan details is the collection which is containing all the documents for the employee loan details. And then we will be using MapReduce function here, and then inside that we will be providing function, this function, and we will be using emit. Emit is another function which will give you these two, employee ID and loan amount. Okay, and then we'll be using another function that will having the key and value. Okay, and it will return an array which will be having the sum of all the values. Okay, so this will be the employee ID and this will be the loan amount, and then this array will be summing all the values here. It will go for each and every key and sum it up all the values, and then we can provide the query what we want to fetch. We want to fetch the documents which are having only loan status as active, and then we can give the output total loan. This will be the collection which will be containing the result of this MapReduce function. Okay, so this is the simple MapReduce query that we will be writing to get what we discussed. So here this function is the map function. So what it is doing, it is getting us the employee ID and loan amount, and then this one is the reducer function which will be getting the key and value, and then based on the key value it will go and sum it up all the values for each key, and then inside that we are giving how we are going to query the document. So we are going to query the document based on the loan status which is active. So it will look for all the active loan IDs, and then we will be outputting this result, employee ID and loan, total loan, in the collection which will having name total loan. So this is the query which is a document, and this output is the output which will contain all the output. Apart from this, we can also have a sort and limit. So sort will have a document which will say we want to sort the result in a particular way. We want to sort in ascending order, descending order, or whatever. So you can provide the sort functionality here, and then we can provide the limit which will be a number. So limit the number of result, which if you have a large amount of data, you are going to get thousands of results, you can limit the number of results you want, like first 100 or something. Okay, so you can use this. So this is the MapReduce function in MongoDB. This is how we are going to write. So what is map? Map is a JavaScript function that maps a value with a key and emits a key value pair, and then that key value pair will go to the reducer function, and reducer function is also a JavaScript function that reduces the groups of all document having the same key. So it will go for each key and find the value and then sum it up and return to this array, and then out is the output location for the result. So it will have a collection. Okay, and query specifies the optional selection criteria for selecting documents. So we are selecting a document based on the criteria active, and then sort specifies the optional sort criteria that you can provide with this, and limit specifies the optional maximum number of document to be returned. So this way you can use the MapReduce function. So now we have discussed the theory part. In the next lecture, we are going to do our hands-on with the same example, and I'll show you by I'll create a collection, loan details, I'll insert the data, and then I'll write the MapReduce to get the every employee active loans, total loans on the employee. So see you in the next lecture where we'll be doing our hands-on on the MapReduce. Thank you. Hi, welcome back. This is Sunil again, and in the previous lecture we have understood how MapReduce works in MongoDB. In this lecture we are going to do our hands-on on the same problem which we have discussed in the previous lecture. So what we are going to do, we are going to find sum of all the active loans for each employee. So we'll have the employee ID and the total loan on the employee which are active. So we need to find the active loans for each and every employee. So let's get started. So for this, I have created a document. I have created a collection with the name loan details, and with that I'll be writing the query. So let's get started. So for this, I have created this collection which is loan details, and I'm inserting employee ID, loan amount and loan status, active for the, and there are different loan IDs and different employee IDs, and for that each loan there is a loan status field that is having active or expired. So what I do, I'll copy this and we will be creating this document. So I'll use the database class info which we are using. I'll paste it and see here we have. So now every result is successful. Right result, insert one means successful. So let's query this collection db.loan details.find pretty. So this is simple insert query that I have written. See here, now we have the collection ready with the documents, employee ID 101, loan ID 123 and loan amount this, and loan status is active. For the same employee there is another loan with the loan ID 124, this was 123, this is 124, loan amount 6,000 and loan status active. Then there is another employee which is having employee ID 102, loan ID 1267 and loan amount and active. For the same employee 102 there is another loan which is active, and for again there is a loan for on the employee 101 with a different loan ID, and this loan is expired, and there is another loan with different loan ID which is active. For the employee 102 there is a expired loan with a different loan ID. So there are two employees 101 and 102, and both are having some active loan and some expired loan. So what we are going to do, we are going to find all the loans on employees, and we are going to then when we are going to query with the loan status active. So we'll find for 101 how many loans are there, active loans are there, and then first we with the mapper we will find the let me show you. So see here I have written the map reduce. So first what I'll do, I'll write the mapper function here, and with the mapper function what I do, I'll be giving the employee ID and loan amount. So for each employee I'll be finding the loan amount, and here I'm providing the query loan status is active. So I'll query all these documents and I'll find all the active loans for the each employee. So employee ID and active loans, and I pass to the function reducer function, and what it will do, it will have the employee ID as a key and loan amount as a values, and it will iterate each key for the values and it will sum it up. So for each key it will find all the values and then it will sum it up and provide to this array, and then we'll get the result. And we have the out here. For out I'm giving total loan, so there I'll be creating another. So this map reduce function will be creating another collection which will be named as total loan, and this result employee ID and total loans will be stored in this collection. So let's run this map reduce. So I'll just copy this and I will be pasting it here. So let me go little up. So let me paste it here and let me hit enter. So see here we are getting result like result total loan, that is the collection name, time in millisecond, count input is 5. So see here it is input 5 means there are 5 active loans. So let us find that. See here 1, 2, 3, 4 and 5. So there are 5 active loans. So it is showing 5. Okay. So and emits also 5. So employee also 5 and there are reduced 2 and output 2. So let's query the document. So db dot, this is the document name, total loan dot find. Let's see what we get the result. See here we are getting the result, employee ID 101, this ID is employee ID and value is 89,000. So let's calculate manually for 101 how much active loans. So see here active 5,000 and then 6,000 11,000 and okay 11, and this one is active. So 11 and 78,000 plus 11,000 is 89,000. See here it is coming 89,000. And for 102 let's count manually. For 102 also we have 15,000 active and then 25,000 active, 40,000 active. So and all others are expired. This is expired. So see here we are getting the correct result as 40,000 and 89,000 for each. So we can see here we are getting the what we wanted. We wanted the sum of all the active loans. So 89,000 for the employee 101 and 40,000 for employee 102. So this is how we can use the map reduce function. We can change the query to get the expired loan. You just need to change it here. You can put this as expired and change this to, if you want to find, you can use the find here and you will get the result then and there. So let's run this query and hit enter. See here now I'm getting expired loans are 78,000 because we have 2 expired, for 101 78,000 and for 102 78,000, and all other loans are active. So this way you can do, you can put the find at the end of the map reduce function to get the immediate result, or you can query the document collection which we are giving in the map reduce function. So you can query the document collection to get the result, or you can put the dot find at the end to get the result. So this is how we can use the map reduce in our MongoDB. So I'll hope you do the more hands-on by yourself, and if you face any problem, any query, write on the discussion board of this course and I'll be there to help you out. I'll try to add more hands-on, but for now I'll hope you will be doing hands-on by yourself. So see you in the next lecture. Thank you. Hello and welcome. This is Sunil, your instructor for this course, as you know already. So in this section we are going to do some project kind of thing using Node.js and MongoDB. So we are basically going to communicate with MongoDB using Node.js. So to do that we need to install Node.js on our machine. So in this lecture I'm going to teach you how to install on Windows, and I'll be adding instructions for the other operating systems as well. So let's get started. So to install Node.js we need to go to the nodejs.org website and download the latest node.js file, that is .msi file for Windows operating system, and then we need to just click on the file and follow the instructions. So let's see how we can do that. So this is the nodejs.org website, and you can see here it's already detected my operating systems and it is showing the download for Windows operating system. So here they have listed two versions, version 4.4.7 and version 6.2.2. So this is the development version for community. If you want to contribute to Node.js, you can download this, but we are going to download this stable version, that is 4.4.7, recommended for most users if you want to use it in a production environment or your development projects. So click on that, and when you click on it, you will be getting a downloaded file, that is this file that I have already downloaded. See here, node v.4.47 x64.msi file, and when it is downloaded, it's a 10 MB file. So you download it and then you click on this. So when you click on this, you will be getting a pop-up window like this. And since I have already downloaded Node.js, the latest Node.js on my system, it is taking some time. Okay, so I'll cancel it, and for you just click on next like this. Okay, click on next. See here, it is asking me to change, repair or remove. So I'm not going to do anything because it's already installed on my machine. So you just click on next. Follow the instruction. There is nothing to do. Just click on next and finish. And once you click on the finish, okay, click on finish, and it is already installed on your machine. To check whether the Node.js has been installed on our machine or not, you open your command prompt or terminal and type node space -v, node space -v or -v, and click on enter. And see here, it is showing us version 4.4.7. It means node is already installed. You can also use node -version as well, and it will give the same result, version 4.4.7. So now we have installed Node.js on our machine. We are good to go with the Node.js. So in the next lecture, we'll be seeing how we can communicate to MongoDB using Node.js. See you in the next lecture. Hello and welcome back. This is Sunil, and in the previous lecture we have seen how we can install Node.js on our system. In this lecture we are going to get more familiar with Node.js, and to start with, the best thing to learn Node.js is start with the REPL. REPL stands for read eval print loop. So we'll see what is this. First thing, let me show you something in action. So we have installed this Node.js, and when we type node, it will take us to the REPL. So this is the REPL console, REPL, read eval print and loop. So when I type 3, it will print 3. When I type 3 plus 9, it will give me 13. So what it is doing, it is evaluating. First thing, when I'm typing something, I'm entering something as a user, so it is reading the user input. Like if I enter hello, it will print hello. So first thing, it is reading, and then it is evaluating what is the user input, and then it is printing the result, and then it is keep on repeating the commands until I put Ctrl C twice. So when you put Ctrl C twice, you will be coming out of the REPL. So this is REPL console. When you type node, you are taken into the REPL console. So let me tell you more about REPL. So as we have seen, REPL is read eval print and loop. So read stands for read, R stands for read, and it is like reads user input, parse it into the JavaScript data structure, and then stores it in the memory, so that eval will take that from the memory and evaluate the data structure which is now in the memory. So that is evaluation part. Then comes the print. When the evaluation process is over, print will print the result that we can see on the console. And the next thing is loop. So when the user is in the REPL console, it will keep on printing and keep on executing the commands given by the user. So this is all about REPL. Okay, let me show you some more example of REPL in the hands-on session. So now we are into the REPL console. So one more thing we can do, we can call the REPL server by using this command constant REPL, and we can use the command require, and then in require we can pass REPL so that REPL server will be called. Okay, and hit enter. See here it is showing undefined. Now we can hit REPL and hit enter. See here it is executing something, and what is that? Let's see. See here, when we typed REPL, it is showing us built-in libraries, assert, buffer, child process, cluster, crypto, dgram, DNS, domain, event, FS, HTTP, HTTPS, net, OS. So all these are built-in libraries into the REPL. Okay. The next thing it is showing REPL server. See here, our REPL server function, REPL server super function interface super object. Okay. So it is giving you more detail about the REPL server, and see here it is showing the domain, events, event count, max listeners, members. Okay, so we can use this information for our use. Okay, and then when you go down, it will be showing you more thing like, see here, events, close, sign in, line, sign count, exit, all those things. And when you come down here, see here it is showing the commands, REPL commands, break, clear, exit, help, save. So we can use this load is to load any JavaScript file you want to load into the REPL, and you want to execute that. Then we can use the load. Then we can use save to save any command that we are typing on the REPL and want to save it to the some JavaScript file. So we can use save, and then we can use help. So we can use all these commands. Hello and welcome back. So let's see some more commands in REPL. Okay, so we can use .help to get the help from the REPL. So when you type .help, it will give you the commands that you can use when you are in trouble. So you can use break, and they are giving the description of the each command. Break, sometimes you get stuck and this gets you out. Okay, clear alias for .break, exit the REPL. So when you type exit, you will be coming out. So we need to type .exit. See here, when you type .exit, you will be coming out of the REPL. So when to go inside, we need to type node and .help to get the help, and then we can use the load and save to load the JavaScript file and to save the evaluated command in the REPL session to a file. Okay. Apart from this, we can do some more thing. We can use console.log to print something on the console. We can use hello node, and see here it will print hello node.js, hello node.js. And we can also use function. We can also declare a function. Suppose I'm declaring a function sum, and I'm using function. I'll use suppose two variable a and b, and I want to return a plus b. I'll close the function and semicolon. So now I have declared a function sum. I can call that function on the REPL by passing two variables, suppose 2 and 99, and it will give me the sum of these two numbers. 2 plus 99 is equal to 101. So we can put the numbers, we can put the string, we can put the full functions, full expressions, JavaScript expressions, and REPL will be evaluating and giving the result. Okay. Apart from this, we can also write JavaScript functions like do and while. Suppose I want to print numbers till 10 using do and while. So I'll put do and I'll put a++ and then I'll give console.log, and in console.log I'll print a is a value which I'm incrementing. Okay, and then I'll put, I need to process this till a is less than or equal to 10. Okay, and I can declare a equal to 0. See here it is giving me error because I have declared a at last. So what I need to do, I need to declare a first, a equal to 0, and then do. Now enter. See here, now it is printing the a value 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 till 11. Okay, so since I declared a here and then I have given the do and while, it is giving me the result 1 to 11. Okay, since I have given a equal to 10 till 10. Okay, so this way we can put the full expression or a single line or whatever you want, you can write it here. Okay, one more thing we can do, we can create a, see what I have done, I have created a app.js file, a simple JavaScript file with the, which is having do and while. Okay, what I can do, I can run this using Node. So what I need to do, I need to go to the, come out of this console REPL, I need to go to and here I need to type node space app.js. So to run this app.js file, which is having a simple do and while. Okay, so I can run this using Node. So node space JavaScript file name and hit enter, and see here it is giving the result 1, a is 1, 2, 3, 4, 5, 6, 10. Because we have written the logic, a is, we are incrementing a till a is becoming less than 10. Okay, so that's why we are getting the result a 1 to 10. So you can experiment more with the more commands and you can get familiar with the REPL and Node.js. Hello and welcome back. This is Sunil, and in this lecture we are going to learn about Node Package Manager. So till now we have downloaded and installed Node.js, and then we have done our hands-on with the REPL, read, eval, print and loop. So we have seen how we can use the REPL utility in Node. Now we are going to learn about npm Node Package Manager. So Node Package Manager is basically a package manager in which what we do, if you want to install and use some third-party packages or other packages other than Node, then we need Node Package Manager npm. Like if you want to use Node.js along with MongoDB, then you need the MongoDB drivers for Node, and then in that case you need to install the MongoDB drivers, and then we need npm to install the MongoDB for Node. Same way, if you want to work with AngularJS or Express and you want to install those things, then we need npm Node Package Manager. So Node Package Manager install packages for Node.js, and it also do the version management for us, and then it also do the dependency management for Node.js packages. So we are going to see all these things in coming lectures when we do our project. Okay, so this is all about Node Package Manager. So let's see, when you install Node.js in your machine, it will be already there. So to check that whether npm is there or not, you type, open the command prompt or terminal on your Mac and type npm --version, okay, and hit enter. It will give you the npm version. So what version of npm is there on your system, it will give. So it is giving 2.15.8. so now we have the node package manager in our system. So suppose you want to install something. Suppose I want to install MongoDB, so I can give npm and then install and then the package name. So here I'll give the package name MongoDB. So here npm node package manager space install to give the instruction to install the package and then the package name. So and hit enter. So what it will do, it will install the MongoDB for node. So see here it started processing and it will install all the required packages for MongoDB for node. It may take some time depending on the what utility or what package you are going to install. So wait for that, it will complete and it will give you the details of what are the packages or what are the things it has installed. Okay, so see now the MongoDB package has been installed and you can see this message node modules / MongoDB. It means MongoDB has been installed locally. So there are two things. We can install packages locally and we can install packages globally. So what is the difference between globally installed packages and locally installed packages? So I'll tell you in short, and when we do our next lectures, you will be getting this theory in use. So let me explain first. So when you install packages locally, you can use those packages by using a require function. So there is a require function. The use of require, you can import the packages and use it locally in other modules. But when you install a package globally, you cannot use it using require. That means you can't use in other packages. So why we need global and local? So globally means if you want to use Node.js on your command line, then it is recommended to use and install packages using global. And if you are going to use in a project and you are going to use the require function, going to import packages, then it is recommended to install packages locally. Okay, so when you get this message, it means this node modules has been installed for MongoDB. So when you go here, Sunil app data, okay, so you can see here it has been installed. So all the packages are here. Okay, so let me show you what is local and global. See here what I have done. I have installed npm install MongoDB. Okay, so this is locally. Okay, so when I install locally in D drive, because in C drive we can't make the difference because it's both are same. Okay, so here what I am doing, I'm in a D drive, I'm installing npm install MongoDB, and see here. So when you go to the D drive, you will see here there is a node modules folder has been created inside that MongoDB, and there is a library. Okay, and when I did npm install MongoDB -g means I want to install this MongoDB package globally. So see here, when I'm doing this, it is showing me the path as c:users Sunil /appdata/roaming/npm/node modules MongoDB. So this is the global path, okay, on which MongoDB package has been installed. So that this is the difference. Okay, so when you create a package folder and project folder, and then inside that when you install locally, you can use it by using the require. And when you want to use MongoDB Node.js as a command line, then you can install using -g, that is globally. Okay, see you in the next lecture. Hello and welcome. This is Sunil, and in this lecture we are going to create our very first Node.js project. So we are going to create Node.js project. So before we dig into the project creation, let me tell you a few things. To create a project in Node.js, we need to do three things actually. We need to create a server first so that we can run our project on that. And then we need to create a request and response, and then the third step is we need to test it. So let's get started. So what I have done, I have already written the code, and the very first line is where HTTP equal to require and HTTP. Okay, so what is this first line? First line is what I'm doing. I'm creating an instance of the HTTP server so that we can use that. So for that, what I'm using require function, and I'm telling Node that I'm going to use the HTTP package in this project or in this file or in this JavaScript file. So we are basically using require to call this or import this HTTP package into our project. So basically we are creating an instance of the HTTP server, and then once we have this instance, what we do, we'll be using this HTTP to create a server. So for that we are using http.createServer, and this create server will take a function with the request and response as an argument. So for that, what we are doing, we are using response.writehead, and we are giving 200 is status code for OK, and then we are giving the content type as a text plain. So okay, so this is we are writing in the response, and then we are giving the response dot end is hello and welcome to the first Node.js project. So here you can write your message whatever you want, hello world or hello universe or whatever you want, you can write. So I have written a simple message, hello and welcome to the first Node.js project. And then what we do, when we create this server and we will post the request and response, we need to ask the servers to listen, and by that, by using the listen, we are telling that we are binding this response to request to this port 8081, so that it will be listening to this port and we will be getting the output. Okay, so this is the simple thing. We are creating the server, and then we are creating an instance, and then with that we are creating the server, and we are passing the request and response, and here we are giving the response as content type, status message as OK, status as HTTP status as 200 OK, and content type is text and plain, and response is hello and welcome to the Node.js, and we are binding this response to the 8081 port so that server will be listening, and we are simply writing a console message, console.log, so that we'll be seeing the message on the console that server has started, so that we can test it on a browser. So let me go to this. So I have saved this file into the D drive. I have given the name first node.js. So let me show you. See here is the file first node.js. Okay, so let me run this. So to run this, we need to type node, and then we need to give the file name first node.js and hit enter. Node space file name first node.js. You can give it any name like app.js, which is recommended, and most of the people will be using app.js as the entry point into the Node application or Node project. So here I have given first node. Okay, so let me correct it, first node.js, and then hit enter. See, when you hit enter, the file will be processed by the node, and see here it is asking for the access. So allow access. Okay, see here now it is giving us the message server started at http://127.0.0.1 and it is giving the port number 8081. So let me type it here, and when you type this URL on the browser, you will see the message, hello and welcome to the first Node.js project. So this is how we create a simple hello world kind of project into Node.js. Hello and welcome back. This is Sunil, and in this lecture we are going to create a project structure using Node.js, and then we will be installing the MongoDB native drivers for Node.js. Okay, we need native MongoDB drivers to work with Node.js. Okay, or you can say to work or to access MongoDB using Node.js, we need MongoDB drivers for Node.js. So that's what we are going to do in this project. And in the previous lectures, we have learned about the Node.js. So we have the pretty good understanding of Node.js. Not much, but it is enough to continue with this project. Okay, so let's get started. So first thing, we need to open the command prompt or terminal on your Mac. Okay, so first thing, you decide where you want to create your project. So I want to create my project in D drive, and there I'll create a directory to store my project files, and I give it a name, my node project. Okay, and then I'll go to that directory by typing the directory name, my node project. Okay, so now we have created a directory, created a folder to keep our project files. So next thing is we need to start the npm node package manager that we have seen in the previous lecture. So we need to start the npm. So to start npm, we need to type npm space init. npm space init will start the project creation process. Okay, so we need to create the structure for the project, so we need to initiate the npm. Okay, so npm space init, and it will initiate the process. So hit enter and it will start creating the project. Okay, see here it is saying this utility will walk you through creating a package.json file. So what is package.json file? Package.json file will have the entries for all the details for our project and all the modules which we are going to use. Okay, and then it is saying use npm space install space package name space -- save afterward to install a package and save it as a dependency in the package.json file. So what it is saying, once we are done with the project creation, we need to use the npm install, and whatever package we want to install, that we can do. Okay, so here we need to give the project name. So let me give my project name as first node. Okay, let it be first node or first node project. Okay, and hit enter. No capital. Okay, so first node project, hit enter. See here it is saying version 1.1.0. okay, and then hit enter and give the description for your project. First MongoDB Node.js project. Okay, and then hit enter. So it will ask for the entry point. You leave it as a index.js, or if you want to give your file name, you can give. So here I'll give first node.js. okay, I'm giving a file name first node.js. It's completely optional. You can give it or you can leave it. Okay, so I'm giving first Node.js, and then it is asking for test command. You leave it or put anything. Okay, and then it will ask for the git repository, so you just leave it for now. Then keywords, leave it. Author, you can put your name. Okay, and then hit enter. License, hit enter, and see here now it is giving us the project description. Project name is first node project, version 1.0.0. description, main entry point first node.js, script for testing is test it, author this, and license is this. Okay, and you need to type here yes to save the entry. Okay, type yes and hit enter. So now it is saved. So let's go to the D drive. See here D drive, we have this my node project, this one my node, and see here now we have a package.json file. Let's see what is there inside this. See here it is having the same thing what we have entered: name of the project, version, description, entry point, script, author name, and licensing. Okay, so this is the project.json. So next thing what we need to do, we need to install MongoDB drivers. For that what we need to do, we need to type npm install MongoDB. So npm install MongoDB will install the MongoDB drivers, and then we need to give the -- save to save it, the details into the package.json files. So hit enter, and MongoDB drivers for this project will be installed on our project directory. So let's see, it may take some time as usual. Okay, so see now MongoDB drivers has been installed. See here node modules / MongoDB. Okay, and the version details and all it has given. Let's see here. See here now we have a node modules folder here, MongoDB, libraries and all, everything is there. Okay, so let's see the package.json file. Whoa. See here now it is having another entry for dependencies, and it is saying dependency MongoDB and driver version 2.2.0. So now our package.json is updated. Okay, so now we are ready to connect to the MongoDB using node.js. So let's start the MongoDB server. So we know when we install MongoDB latest version 3.2.7, it will be installed on the server program file MongoDB server 3.2 bin, and here we need to run the command MongoD --db for space data/db folder path. So hit enter to start the MongoDB server. So now the MongoDB server is started and it is waiting for the connection. So let's go to the node, and what we need to do here, we need to create a file. Okay, so let's create a .json file, .js file, and we will give it a name first node. Okay, so copy this and save this file as first node.js, and okay, save it. And in this file we are going to write the code to connect to the MongoDB server. So first thing we need to use is Mongo client. So Mongo client is an interface to connect to the MongoDB, and for this what we need to import the package. And what package? That package is MongoDB. So we have installed the MongoDB, and then we need to .mongo client, comma, we need to call the assert equal to require, and we need to have assert. So assert is basically for internal testing by Node.js. So it is not meant for testing, proper testing. It is just for internal thing. Okay, so we will be using assertion here. So next thing is we need to connect to the DB. We need to use the connection URL. So we need to provide the connection URL here. Okay, so for that we need to create a variable URL, and for that we need to give the URL for MongoDB. So we know MongoDB URL is MongoDB //localhost:27017 and then your DB name. So I'll give DB as a my project DB. Okay, and then put semicolon. The next is now we have the MongoDB drivers imported and we have the connection URL here. The next thing is we need to use the connect method to connect to the MongoDB. So for that we need to use the Mongo client dot connect. So there is a connect method in the Mongo client interface that we need to use, and here we need to pass the arguments. So let me close this first, and here we need to pass the URL for MongoDB, and then we need to function which will be, it's an anonymous function which will take error and DB. So when we get error it will return error, and when we get connected it will return the DB. Okay, so now we will call the assert, and assert dot equal, and when it is error it will return null or error. Okay, it will be either null or error. Okay, and then let's put a console.log. If it is connected successfully we will be getting a message, and that message will be connected to MongoDB server, connected to MongoDB server, and then we need to close the MongoDB connection, DB connection. So now we have written this simple first node.js where we are calling the Mongo client interface, and then we are importing the MongoDB packages, and then we are creating a connection here by taking this URL to the mongo.connect function, and then we are putting the console. It's a simple, if it is connected to the MongoDB server it will put us this message, otherwise it will give us the error. So let's see, save this and go to node. Our MongoDB server is running, so here we need to do the node and first node.js. So to run this first node.js we need to give the node space first node.js and hit enter. See here we have some problem here. Okay, see here I have done a silly mistake. I have given this function spelling wrongly, so let me go and correct this. This happens. Okay, now I saved it. Let's run it again. Let me scroll up and hit enter. Again it is showing error in the line number 11. Let's see what is that. Okay, I need to close this. Sorry. So when we do mistakes we learn more, so never worry about that. It's a silly mistakes. See here now it is showing a message connected to MongoDB server, and let's see the MongoDB server. See here it is showing one connection now open. It means we are connected to the MongoDB server. Okay, so now what I do, I'll be shutting down the MongoDB server, and what I do, I'll try to run this. Let's see what will happen. assert will be giving us the error. See here, we are getting this assertion error, which is saying null equal to Mongo error failed to connect to the server localhost on first connect, failed to connect. So this is the advantage of using assert, because when we get error, it will give us the full detail. So this is not for testing, this is for internal usage. So this way we can connect to the MongoDB server. See here, now if I run it again, it will be showing us the message connected to MongoDB server. Okay, see here, now one connection was open and now it is 0 connection because we are using db.close, so db connection will be closed immediately. Okay, so now we are connected to the MongoDB server successfully. In the next lecture onward, we'll be seeing how we can insert data into the MongoDB, how we can update, delete, all those CRUD operations we are going to see in the next lectures. So see you in the next lecture. Welcome back. This is Sunil, your instructor. So let's get started. So in the previous lecture, what we have seen how we can connect to MongoDB using Node.js. So we have seen how we have installed the MongoDB driver for the Node.js using npm, that is Node Package Manager, and we have successfully connected to the MongoDB server. So see here, our MongoDB server is still running, and in this lecture we are going to create a collection and we are going to insert documents into that. So let's get started. So to save time, what I have done, I have written the script already, and I'll show you, I'll explain each and every step, and then we will run that script using Node, and then we'll see the result. So let's go to the code. So this is the file which we have written in the last lecture, that is first node.js, and we know this, we have created a Mongo client interface, and we imported the MongoDB module into this file, and then we have imported the assert, and then we have created a URL that is pointing to the MongoDB database or MongoDB server. So this is the place where our MongoDB local server is running, and this is my project DB is the database name which we are going to create. Okay, and then we connected to the MongoDB server using Mongo client interface connect function. So we call the connect function, we have passed the URL, and then we have called this anonymous function that will return error RDB. So then we have this assert.equal null or error, and then we have printed a simple console that we are connected to the MongoDB server. Now till here we have done in the previous lecture. Okay, in this lecture what I am going to do, I am going to create a collection. So we'll create a collection variable with the help of db.collection, and we will be giving here the student as a collection name. So with this line where collection equal to db.collection student, we are creating a collection with the name student into this database myprojectdb. So now we have this collection ready. Next step is we need to create documents so that we can insert those documents into the student collection. So here we are creating a student document to be inserted into the collection. So for that, what I'm creating a variables for student data. So student1, and then here I'm giving in the JSON format. Obviously we can insert documents. So name John, standard 10, subject is the array here, physics, chemistry and maths. In the same way we have created a second student, that is name Suresh, standard 11 and subject biology, chemistry, and student 3 name Johnny, standard 12, subject. Okay, so we can add more students. You can just copy this and add more student if you want. So now we have these student objects here, student 1, 2 and 3. Now we can insert this document into the collection using collection.insert method. Okay, collection.insert function will allow us to insert this document into the collection. So now we are inserting the document student 1, student 2 and student 3, and then function, error and result. So if we get error, it will return error, and if successful, it will return us the result. And then here we are doing a simple check. If error, then we are printing that error into the console, and if else, if it is successful, we are printing the success message into the console, document inserted, and then here we are printing the result.length and result. So it will give us the collection or documents which are inserted into the MongoDB database and the length of the collection. Okay, and then we are obviously closing the DB connection and closing the parenthesis and bracket carefully. So now we are ready with this code. We can run this using the node. So see here, we need to start our MongoDB server, which is already start, and if it is not started, you can run the command MongoD -db path, and then you can give the data/db path, and then MongoDB server will be started. So now we are into our project file, and here we can run a simple command node space first node.js to run this script, run this code. Okay, run this JavaScript file using node. So we can run node space first node.js and hit enter. So as soon as you hit enter, see here it is printing a message connected to MongoDB server and document inserted, result OK1, and number of documents is 3. So see here, name John, standard and subject. Okay, Suresh, and see here it is not printing the subject because it is an object. So let's go to the Mongo and see here. Now we'll see so DBs, so DBs. See here, now our database has been created in the MongoDB. So I'll give use my project DB. We know if you want to use this database my project DB, we need to use space and the database name. Hit enter. So switch to this DB. Now type so collection to see how many collections are there. See here, we have created the student collection, so it is there. Now we can check whether this data which we have created here, documents are there or not. Okay, I'm talking about these 3 documents. Okay, so let's see db dot document name, collection name students dot find, and to get in a better format we can write pretty and hit enter. See here, now we are getting a result here. ID, this is the object ID for MongoDB which is created automatically by MongoDB, which is a unique ID, and name, standard and subject. See physics, chemistry, maths for John, and for Suresh it's biology, chemistry subject standard 11, and in the same way for Johnny standard 12 and subject statics, commerce and math. So in this way we can use Node.js to connect to the MongoDB server. We can create a collection and insert document in this way. In the next lecture we are going to update this document and delete. So we are going to see update and delete in the next lecture, and we'll also see how we can find data or query data or query collections using Node.js in the next lecture. See you in the next lecture. Thank you. Hi guys, welcome back. This is Sunil again, and I hope you people are enjoying with this course. And let me tell you one thing. In this lecture, we are going to update. That's what I wanted to say. Okay, no problem. So let's update a document. So to update a document, we need to call the collection.update, and then we can find a document which we want to update, and then we can set that value. Okay, it's a simple query that we have written already into the MongoDB. It's the same kind of thing, only we need to write into this JavaScript file. Okay, for that what I do, I'll be commenting all these things, okay, so that we can write our new code. So sorry, I'll block comment, and I'll comment this as well, Control-Shift-Q. Okay, so now we have a collection, db.collection. We have the collection name as a student, and we have already inserted this. And let me query. See here, now we have this document here. Now what we want to do, we want to update the, suppose I want to update the John standard from 10 to 15, how I can do. So this is what, or suppose I want to add some more subject, I want to delete one subject, so how we can do that. So let's see. So what I have done, I have just written the code and I'll explain. Okay, so let me tell you. So we have the URL Mongo client interface, and we have this connect collection. Okay, so now what we can do, collection.update will update a document into our collection. Okay, so here I want to update the John's record. Okay, so for that we need to give the, inside the update method, we need to give name John. So it will look for the collection and it will search for the name with John, and if it is finds, it will look for this, and if it finds, then it will come to this set, means it will try to update that with this. I want to update the subject with the science and history. Okay, and then if it is error, it will print error, and if it is updated successfully, it will print this message. Okay, so let me remove this for now. Okay, so let me run this first. Let's see. So it's done, and see here, now John's subject is physics, chemistry and math, and we are updating with science and history. Okay, let's see whether it has been updated or not. See here, now the subject is showing as science and history. So this way we can update. Okay, suppose I want to update the standard, how can we do? Let me do that as well. So here, instead of subject, I'll give name as standard, and it's not an array, so it will be, suppose I want to update to 12. So earlier it is 10, now I want to make it 12. Okay, so let's run the node. Okay, let me okay, so now it's done. Let's check. See here, now standard is 12. Okay, suppose I want to update the John name itself. So what we can do, here we can write a name, and here we can update the name with, suppose I want to put my name now. So my name should also be there, right? Okay, no problem. So let's go to the node and run the node space JavaScript file name, and it's done successfully. Come here and run the command student.find.pretty, and see here, see now instead of John, name is showing as Sunil. So in this way we can easily update a document or collection using Node. So it's a simple MongoDB kind of update, right, that we have seen in the earlier sections when we are seeing only MongoDB. So it's the same native query kind of thing. MongoDB update and name set. The same thing we have seen in the CRUD section, right? Name and then set to update a document. It's the same thing, only we are calling collection.update. Okay. So in the next lecture, we are going to see how we can delete and find the document. So we'll see how we can query, and we'll also see how we can delete a document. See you in the next lecture. Hi guys, welcome back. So in this lecture, we are going to quickly look at the how we can query a document. So I have commented all other things like creation and updation code. I have commented, and I have written the querying document code here. So it's simple. Collection.find. We can use this find method to query a document with a given query like name Johnny. So it will search the collection and it will look for the name with a Johnny, and it will show that into the result. Okay. So simple thing. Same thing which we have written if error else if. Okay. So and we are assigning it the result to the array so that we can see the result. Okay. So let's save this and let's run this through Node. So Node space first node.js, and see here now we are seeing the result found and name Johnny, standard 12 and subject. So it is showing us the result here. So if you query the MongoDB database, see here for Johnny this is the result. Okay. So same thing we are getting there as well. So let me query for subjects, and here I'll put chemistry, and let's run this. Okay. So see here now we are getting two results. For subject chemistry we are having two documents. One is for Sunil and other is for Suresh. Okay. So both are having chemistry as a common subject. So we are getting the two results here. So this way we can query a document. Okay. In the same way we can remove or delete a document. So let me copy this and let me write here deleting documents, and here we can use remove and else we'll write console.log deleted. Okay. So here what I'm going to do, I'm going to delete entry with name Sunil. Okay. So let's see our database first. So we have a document here with the name Sunil. So this name Sunil document I'm going to delete. Okay. So okay. So let's run this. Hope we don't get any error. Okay, see here first it is running the querying command. So it is saying found Sunil, and then it's saying delete. So let's see the database whether it has been deleted or not. So see here now we have only two records, two documents, one for Suresh and one for Johnny. The Sunil is not there. So if we run this again, so this result which is saying found, it should not be coming. Okay. See here, it is showing only the Suresh record for querying. See here, only for Suresh because Sunil is deleted, and here it was showing the two records for querying. Okay, and then delete it. So okay, so this way we can quickly query using the find method and remove using a remove method, remove function of the collection. Okay, so this is pretty simple. So I hope you people are following this tutorials and course and enjoying it. If you have any doubt, you can put your questions on the discussion board, and if you have any doubt, you please ask. Okay, and if you are happy with this course, you can go ahead and write a review for this course, and I'll be happy to see your feedback. Thank you. Hello and welcome back. This is Sunil and I'm here with the update to this course. So in this section, I'm going to discuss some of the important MongoDB interview questions that I have covered already in this course, and if not, I'm going to discuss that also. So if I have left out some of the concepts, some of the topics in MongoDB, that also I'm going to cover in this interview section. So not to worry if I have missed out some of the concept, we are going to discuss those as well. So let's get started. So very first question that we may be asked in interview is, what is namespace in MongoDB? So as usual, namespace in MongoDB is combination of database name and collection. So when we say collection and database is a combination of namespace. So if you want to refer to some document, we can refer to the namespace using database and collection. So that's why whenever we want to use a collection or query a collection and insert document inside collection, we are using use database name. So we are going to the particular database and there we are seeing the what are the collections available. So here database name and collection. So this user db.users is the namespace here in this case. Okay, so this is the namespace, database name dot collection name, and with this collection we will have all the documents inserted in this. So this way, this is how the namespace is in MongoDB. So one more important question is, list the most important features of MongoDB. So we already know what are the features. Just to revise, I'll tell you that these are the most important features of MongoDB. First thing is, it's a NoSQL database which is having a dynamic query language. It's not a structured query language, it's a dynamic query language. Then the second one is, it's faster than the RDBMS traditional databases like MySQL or Oracle, and it supports agile, and this database MongoDB is highly scalable. And the next thing is, it's very flexible data model because we are using documents, so there is no fixed schema that we are using. It's a schema list database, so that way it is very flexible data modeling. So it's a flexible data model, it's a faster than traditional database, expressive or dynamic query language, and it supports agile, and it is highly scalable. Okay, it also supports big data. So these are the few important features of MongoDB. Another important question in MongoDB interview is, how to achieve primary key foreign key relationship in MongoDB. So the answer is, by default in MongoDB, which is a NoSQL database, it does not support the primary key foreign key kind of relationship, but we can do this thing by embedding the document inside a document. So suppose we have a document, suppose users document. Inside that we can embed a address document. So we can use the embedding of documents to achieve the primary and foreign key relationship. So users document will have the address document embedded in that. In this way we can achieve. So this is the way around to achieve the primary and foreign key relationship in MongoDB. Another important concept is object ID, and in interview we may get one question on this, like what is object ID or what is structure of object ID. So object ID is being generated by MongoDB. It is like a unique identifier for the document we are inserting, and it is getting generated for each document we insert in a collection. So MongoDB will generate automatically for us. Okay, and it is a 12-byte JSON. So it is of JSON type and it is of 12 byte, and it will consist of seconds or the time stamp on which it is being created. So it will have the 4 byte of representing the time, and it will also contain the 2 byte of process ID with which that document is being created or inserted into the collection. It will also contain the 3 byte of counter, and it will also contain the machine identifier on from which machine or from which node it is being created. So it will be the combination of these 4 things of time, process ID, machine ID and counter. So, and that's why it is so unique. Okay. Hello and welcome back. So in this lecture I'm going to discuss 2 important MongoDB interview question. Those are very simple but we should be knowing. So the first one is, does MongoDB need a lot of RAM, or we need a lot of RAM to run MongoDB server? The answer is no, not at all. MongoDB can be running on a very small amount of RAM, and it also dynamically allocates and deallocates the RAM based on the processes it is running. Okay, so if there is heavy processing going on, it can take RAM required, and it will release the RAM when the processing is done. So it is being done automatically by the MongoDB server. And the next question is, why it is always recommended to deploy MongoDB on 64-bit machines rather than on 32-bit machine? So the reason is because if you go with the 32-bit machine, if you deploy MongoDB server on the 32-bit machine, you will have to restrict your data usage or storage size by 2 gigabytes. You cannot go beyond 2 gigabyte of data size or storage. But if you go with the 64-bit machine, if you deploy your MongoDB server on the 64-bit machine, there is no limit of data usage or storage size. So you can use any number of storage size for your MongoDB data or MongoDB server. Okay, so this is the only reason. See you in the next lecture. Hello and welcome back. So let's discuss 2 more important questions. The first one is, why are MongoDB data files are so large in size? And the second one is, when should we embed one document within another document in MongoDB? So let's discuss the first one first. Why are MongoDB data files large in size? So MongoDB reserves the space, and it is what it does, it pre-allocates the data files. So it pre-allocates the data files to reserve the space, and that's why the data file size are large in most of the cases. And why it does that? To avoid the file system fragmentation when you set up the server. So it pre-assumes that you need not to do the fragmentation of your file system when you start setting up your MongoDB, and that's the reason it pre-allocates the data files in with the extra space, a reserved space, so that you can accommodate more data. Okay, so that's the reason. And the second question is, when should we embed one document within another document in MongoDB, or why should we embed the documents in MongoDB? So the answer is, the first one is, we should do this to achieve the relationship between the entities, like primary key and foreign key relationships. And the second one is, we need to achieve the one-to-many relationship, or one-to-many relationship. So when we want to achieve one-to-many relationship, we need to embed the documents with each other. And the one more important reason for this embedding documents is performance reason. So when we embed the documents within, we achieve more performance. We do the performance, we do the transaction, we do the operations more rapidly, and it is highly advisable to embed the documents. So there are three reasons. When we want to achieve the relationship between the entities, we want to achieve the one-to-many relationship, and the most important reason is performance. Okay. Hello and welcome back. This is Sunil, your instructor for this course. And in this lecture, we are going to learn about MongoDB 3.6, which is the latest release from MongoDB. So MongoDB 3.6 support will be provided in this course. So you need not to worry whenever new MongoDB release is coming up. This course will be updated as per the new releases coming from MongoDB. So latest one is MongoDB 3.6. So in this lecture, we will discuss what are the key changes and what are the key benefits we are going to have with MongoDB 3.6. You can see here on the website mongodb.com, where you can see it is saying that move at the speed of your data, go faster with MongoDB 3.6. So the main purpose of MongoDB 3.6 release is faster speed. The speed you retrieve the data, the speed on which you store the data, and at the speed on which you analyze the data. So with this 3.6, they have tried to enhance all these three aspects of speed. So with the MongoDB 3.6, you will have the better and more performance from the MongoDB database. So let's see what are the main changes we can see in MongoDB 3.6. In the latter lectures, we will also see how to install MongoDB 3.6 as well. We already have lectures on how to install 3.4 or 3.0 versions of MongoDB. We will also add lectures on how to install MongoDB 3.6 if you want. So let's see what are the benefits and changes we have in MongoDB 3.6. So I have taken these changes, taken these points from the MongoDB website itself. So what are the key changes we have in MongoDB 3.6? The first one is change in streams to build reactive and real-time applications. We will see in detail each changes, how it is going to affect we as a developer or a database administrators, or as an enterprise if we are going to have the MongoDB as our database infrastructure. So the way we used to build the application, it is going to change with the new MongoDB. We'll see how. And the second change is retriable writes. Means suppose you are trying to write something and it failed. You can retry the same write with the same query and it will be written. And it means we can retry the writes if it failed. That means it is always on write availability. Means your data will be always available to be written. Okay, so we will see how this is possible as well. The third change is schema validation with JSON schema for new data governance control. We'll also see how it is going to accommodate the JSON schema which is coming newly in the technology, JSON technology. We'll also see how we can validate those JSON schema. The fourth change is fully expressive array updates to perform complex array manipulations in single atomic update operation. It means suppose we have an array of data and we want to update whole array, how we can do that with a single query, with a single update command, how we can do that. So that thing is also added, that functionality or that schema, that query or that way is also updated in MongoDB 3.6, where we need not to go and update each and every array elements individually. We can perform a single atomic update operation and all the array will be updated. We will see this also in detail. The next change is Compass community providing a new GUI alternative to MongoShell. So it will be also supporting the Compass community to perform the new GUI. We'll see how we can do this also if possible. And then there is also enhancement for richer lookup. So how we perform the join operations and all, that is also been improving in each MongoDB updates. 3.4 also was having some updates on the richer lookup, or how we can look up the data for join operations, and 3.6 is having more updates. We have new security controls as well. We have end-to-end compression to create efficient and distributed architecture in a much larger enterprises where we have much distributed systems, and how we can efficiently control and create the data, how we can compress the data end-to-end for a better security controls. We have the R drivers, recommended R drivers for data scientists and statisticians for better data analysis and all. If you are having a MongoDB as your database infrastructure, so it will support R in a better way now with the MongoDB 3.6. It is also having the enhancement to operations managers like BI connector or MongoDB Atlas managed database services. That is also, I'm going to add a new section on the MongoDB Atlas managed database services very soon. So stay with this course. Next thing is key benefits of this MongoDB 3.6 update. There are three key benefits that MongoDB listed on their website. That is speed to develop, how we can speedily develop applications based on MongoDB. That is how we can change the streams, retrieval rights, enable consistency. Our Compass community helped developers to move faster, and how we can update the expressivity, how we can express the whatever we want to do in a better query language. So that is the greater query and update expressivity that it provides, and in that way we can move to speed to develop. We can speed up the development process with the MongoDB 3.6. Next thing is speed to scale. Scalability is one of the key controls in MongoDB, one of the key benefit of MongoDB, because we can scale up the database, we can scale up the infrastructure with MongoDB with ease, and that's what MongoDB 3.6 will take to the next level. The next one is speed to insight. As earlier we discussed about, it will provide the recommended R drivers for data scientists and statisticians. So it will provide more driver and more community support to the R scientists, so that they can do more analysis and they can get better insight from the data with a better enhanced speed. So the speed of development, speed of scalability, and speed of insight is the key benefit of MongoDB 3.6 updates. So I hope you like this video and you have the better understanding why MongoDB 3.6 update is good and why it has been implemented. In the next lecture, we will see how we can download 3.6 and how we can install it on our system. So see you inside the next lecture. Thank you for watching. Hello and welcome back. I'm your instructor Sunil, and in this lecture we are going to learn about the latest release, that is MongoDB 3.4.1. So we are going to see what are the changes, enhancement and deprecations came along with the new release 3.4.1. So many of my students from this course MongoDB from scratch were asking about what are the features that come along this release. So this is the lecture that I'm going to tell about all these things, and in this lecture I'll be telling the changes or enhancement or deprecation that came along with the new release, and in the separate lectures I'll be discussing in detail each one of them. So let's get started. So let's see, the first thing that I want to tell that came along with this release is the linearizable read concern. So what is this read concern? This linearizable read concern is a read concern level. So with this, when you query, when you read the data from MongoDB database, it will reflect all successful writes issued with the majority and acknowledged prior to start the read operation. So when you write the read command with the linearizable concern, it will give you all the data and it will wait for the acknowledgement, all the acknowledged write concern, all the data that has been acknowledged by MongoDB, that will come for this read operation. So we will see how it works in detail, and for this we use the milliseconds for this. So I'll tell you when I discuss in detail. The next one is we use the max time ms for this linearizable read concern. Okay, so next one is improved initial sync. So MongoDB 3.4.1 improves the performance of initial syncs by having an initial sync build index as the document are copied. So when you try to copy or write a document, what it will do, it will start building the indexes when documents are being copied. So in that way it will improve the initial sync. So it will start building the indexes as the documents are being copied. So we'll discuss this in detail as well. The next change that has come along with this MongoDB 3.4.1, that is decimal type data. So MongoDB has introduced a new data type, that is decimal type. So with this we can have a decimal of 128 format support, that is 34 decimal digits. Okay, that is significant digits I'm talking about, and the exponent range from the -61432 to +6144. Okay, so we will see how we can do that. So when we want to have the decimal or like 9.98 or point digits, we can have this number decimal, and we can have those decimal numbers in our document. So we'll see how we can do that in a lecture, separate lecture. It is similar to the double data type. Okay, and then the next thing is, in aggregation framework there are a lot of changes has been introduced in this release 3.4.1. So let's see one by one what are those aggregation changes. The first one is new aggregation stage for recursive search. So MongoDB has introduced the recursive search. So when you perform search, it will be like a recursive search on a collection. So it will do the search recursively, and for that they have introduced a stage, that is $graph lookup. So we can use this function graph lookup for this. So we'll see in detail. The next one is new aggregation stage for faceted search. For faceted search also allows for categorization of the documents into classification. So this will have the classification of the documents. Okay, so for this they have introduced the stage like bucket auto, facet, and sort by count. So these are the stages came with this. The next one is, we'll see all these stages in detail when we discuss this thing, new aggregation stage for faceted search. Okay, so don't worry, I'll tell you each and everything in detail in the coming lectures. The next one is new aggregation stages for facilitate reshaping documents. So what is this reshaping documents? In this reshaping document, we can add fields and we can replace the fields. We can modify and replace. So this has been added in the aggregation stage for facilitate reshaping document. Reshaping means adding new fields and modifying the existing field with the new one. Okay. For this they have a stage like add fields and replace root. Okay. The next one is new aggregation stage to count, and this will have the $count. This is simple. So it will count of number of documents into the stage. Okay, so it will give you the number of count. The next one is new aggregation for array operation. So it will have the in operation, array index of array, range, reverse array, reduce, and zip. We'll see in detail when we discuss. Okay, for now it is like reverse array, and the zip and reduce has been added to this functionality. The next one is new aggregation for string operators. So what is this string operators? Like index of bytes, index of OFCP, split, string length bytes, string length CP, substring byte, substring CP, all this has been added. We'll see each of these operations in detail when we discuss this new aggregation string operators. Okay, so for now you should know that these are the changes that came along with the 3.4.1. The next one is new aggregation flow control flow expression, that is switch case. So switch case is also there in the new aggregation control flow expression that we'll see. Okay, and we'll see all this with the example. Okay, the next one is new date aggregation operator. So now for date there are so many functions stages came, that is ISO date of week, day of week, ISO week, year, and these functions will give you the day of week, is of week, and which week of the year. So we'll see in detail with an example when we discuss in detail in the separate lecture. The next one is new monitoring aggregation source, that is called star. What it will do, call stat, it will return statics for collection or a view. For collection it will give you the statistics like how many of read operation, write operation, all those details we can get. So we will see in detail when we discuss. The next one is new type operator came. So this $type stage has been introduced. This will return a string which specify the BSON type of the argument. So it will give you the BSON type of argument. So when you use $type, it will give you the type of the argument which has been used. The next is additional changes. So this $project stage adds support for field exclusion in the output document. So earlier when we were like querying or projecting a collection, we were getting all the things. We can only exclude the _ID field in the stage, but now we can exclusion of a field or fields. We can have many fields excluded from the search results. Okay, so this is the new thing that we'll see in detail with an example. The next one is collation and case sensitive indexes. So to allow for language specific rules for string comparison, MongoDB 3.4.1 introduces the collation for language query and indexes. Collation, what is collation? Collation allows users to specify language specific rules for string comparison, such as rules for letter case and accent mark. So this thing we will see in detail when we discuss. For this collation and case insensitive indexes, we can have the command like create, and create will have the create collection and create view, and like we can have the create indexes or aggregate like db.collection.aggregate. We can have the find and modify. We can have the map, reduce, delete. We'll see all these things, how we can achieve these case insensitive indexes in our MongoDB querying and all those things in detail when we discuss in detail this thing. The next thing is view. So now MongoDB 3.4.1 have the support for creating read-only views from existing collections and other views. So if you have a view or a collection, you can create a read-only views from the existing collections and the views. That is a good thing. So we can run the command and we can create the view. We will see how we can do that. We can do this by using the db.run command, and then inside that we can give create colon view, and then we can give the view on the particular source, like which collection you want to create a view, and we can specify other things as well. So we'll see how we can create the view. The next thing is the security enhancement. Now MongoDB has moved to transition to authentication or transition to auth. So now MongoDB supports for rolling transition to internal authentication for replica sets and sharded clusters. So we'll see this when we see the replica sets and sharded clusters, which we have not touched in this course yet. I'm planning to do lectures on that. So when we do, we will see this also in detail. The next thing is MongoDB tools. MongoDB has introduced a new tool, that is MongoReplay. So what is MongoReplay? MongoReplay, a workload capture and analysis tool that replaces MongoSleep. So they have introduced MongoReplay, but they have replaces MongoSleep with the MongoReplay. So now MongoReplay is there and MongoSleep is removed. So now we can use the MongoReplay to inspect and record commands sent to a Mongo instance. So we'll see how we can use the MongoReplay as well. And the next thing is one of my student in this course, he asked about, he informed me actually that auto index ID has been deprecated from this 3.4.1 version. So that is true. And now auto index ID has been, sorry for this, now auto index ID has been removed from, sorry, not removed, it has been deprecated since 3.2 versions. So now it is deprecated. Auto index ID is deprecated from the 3.4.1 versions onward. And earlier this auto index ID, the D was in capitals, now it is in small. So now it is auto index ID with D small, and it is also deprecated. Okay, so this is the enhancement and changes and deprecations came along with the latest MongoDB stable release, that is 3.4.1, and I'm going to give individual lectures for each of these changes and deprecations, and we'll understand how these things like aggregation and this linearizable read concern, initial sync, decimal type, how all these changes works in 3.4.1. So stay tuned to this course and I will update with the new lectures soon. So thanks for watching, and if you have any question, you can ask in the question inside the course, and I'll be happy to answer all your questions and queries. Thank you.
Hello guys, how are you? And I hope you guys are doing great and learning a lot of things in your life and enjoying your life. And this is Sunil, your instructor for this course, and I'm also good and doing good. And today I'm here to update this course with replication, which many people were asking to update. So it was pending from many months and I was not getting time to update this replication. So in this section we are going to discuss all about replication in MongoDB. So firstly we will start with discussing what is replication. So we will start with the first lecture, that is the next lecture. In that we will discuss what is replication and what is advantage and disadvantages of the replication and how we can do that. Okay, so it is a pretty theory kind of thing. Okay, and then in the next lecture we will see what is replica set. So we will see how replica set can be used to achieve the replication. Okay, and then we will see the replication architecture in MongoDB. Okay, so we will see the replication architecture in the next lecture, that is the third one, and then we will move to the hands-on. So we will do the hands-on by creating replica set, and we will see how we can do the replication, and this can be 2 or 3 lectures. So this can be in the part of 2-3 lectures where we can create many hands-on videos. So there will be 5 to 6 lectures in this section, and we will see all about the replication. So see you in the next lecture where we will be discussing about replication. Hi guys, welcome back. So in this lecture we are going to discuss about replication. So we have seen what are the things we are going to discuss in this section. So now the first thing we need to discuss is replication. So I'm going to discuss about replication. So first thing, just think about what is replication. Replication is simply creating the same thing, replicating the what is available. So in this case we deal with the data. So we have a data here, and what we want to do, we want to create a replica of the same data. So what I will do, I'll create the replica sets. So now I have the same data and we call it secondary data. Okay, so these are secondary data, and this primary data and secondary data both will have the same set of records, they will have the same data. So what we are doing here, we are creating replica, we are creating replicas, we are creating replica 1, replica 2, replica 3, replica 4. So now these are secondary data, which is the replica of the primary data, is known as replica set. So these are known as replica set. Okay, and the process of creating replica of the primary data, this is the primary data. Okay, so primary data is known as replication. So creating the process of creating a replica set is known as replication. So in simple words, creating same or putting the same data on the different servers is known as creating replica set or creating replica, and the process is known as replication. So this is very simple thing. So next thing we will see why we need replication. Why replication? So this is also we can deal with each, because the first thing is we need replication to deal with the data availability. So suppose I have this data D1 here on one server called server 1. Okay, and for some reason server 1 is going down. So from where I'll get this data? From nowhere. So in this case I may lose the data. So to deal with this situation, what we do, we will replicate this to 2 different servers or 2 or more servers. So I'll create the replica 1 of D1 and replica 2 of D1. So in this case, even though this server 1 is going down, I can get the data from this server 3 and server 4. So for this region we create replica, because it can make our data available even though our primary data source is going down. So it makes the data available. The second thing is it creates the redundancy, data redundancy. So we will have some unused data. We may not be using this replicated data here all the time. We may be doing all sort of things with the D1, but we can keep the data for some emergency regions like server is going down or any disaster kind of thing happening. So it will create the redundancy and data availability. The next thing is we use this replication for disaster recovery. So suppose any kind of physical damage happened to the server or the location where we keep our data, we can get the data in those situations if we have the replication of the same data in somewhere else. So for this we can also keep the data for reporting purpose. So suppose if you want to keep your reporting data safe or getting data from different servers and you want to keep them safe, you can use the replication. We can also use this for backup. Suppose I want to back my data, suppose I want to keep my data safe, so I can use replication to make the data safe. So I can use the replications, like if this is going somewhere, I can get the data from replication 1 and replication 2. So for backup also, and some advantages are there for replication. So advantages, if I want to count, it will be the first thing we have already discussed, availability, update data availability, and what it will do, it will create the data locality. We will discuss this locality in detail. For now it's enough to know that because we are creating a data replicas on the different servers, so in the distributed environment, what it will do, it will increase the data locality in the distributed applications, because client can read data from here as well if they want. But ideally client do all the read operation from the primary data source. So in the distributed application, it can increase the data locality, and it also increase the read frequency. So if you want to read the data from in the distributed environment, you can read it faster, and it will also give you fault tolerance. We have already discussed this. In case anything is going wrong, our secondary data nodes can become the primary and our application will be available all the times. So these are the main advantages of replication, and that's why we go for the replication. So I hope you got the better understanding of replication. If you have any doubt and if you want me to put some more effort or giving more clear thing, you can put that into the question and I can reply. Okay, so in the next lecture we'll see how replication works in MongoDB and what is the architecture of it. See you in the next lecture.
Hello guys, welcome back. How are you? I hope you guys are doing great. And in this section of replication, we are going to understand replication architecture in detail now. So we will understand how replication is designed in MongoDB and how it works. So let me tell you one thing. Suppose this is the primary node. So we know by now that this will contain all the data. Primary data node. So this will have all the data. Okay, so suppose we have a client here and he wants to perform some read or write operation on this. Then what it will do, it will perform all the read and write with primary node,
and suppose I have replicated this to two secondary data nodes, suppose this one and this one. So this secondary data nodes, secondaries we call in MongoDB replication secondary data nodes, and we call this process as replication. So we have replicated to two data nodes. So now we know that this primary data node and these secondary data nodes will have the same data, right? So even though these secondaries will have all the same data as primary and they are replicated with the same data, client will not directly, it will not communicate with secondary data nodes. No, this is not going to happen ever. Okay, so client is not going to communicate with secondary data nodes. Client is going to communicate to only primary data node. All the read write operations will happen with the primary data node, and what primary data node will do, it will maintain a operation log and it will enter all the details in the operation log. So when read and write operations are done, what these secondary nodes will do, they will get the data from these operation nodes and they will write on the secondary data nodes. So they will get the details from the operation log and they will write the data on it. So at some point of time, these primary data nodes and secondary data node will have the same data, and this is how the data is being replicated over time. So primary data node will replicate or write the operation log whenever read or write operation is being confirmed by the primary data node, and these secondary data nodes will communicate to the operation log. They will get the detail from the operation log for all the read and write operations and they will update their data sets. So this is how these replica sets secondaries are being updated. So I hope you got the understanding how this is working, and these secondary data nodes will also be communicating with each other with the heartbeat. So we will understand what is this heartbeat in next lecture. Okay, so see you in the next lecture where we will be trying to understand this more and try to analyze this for now, and I'll be coming with the next lecture.
Hello guys, welcome back. So in this lecture we are going to understand about what is arbiter and what is heartbeat. So we will see arbiter and heartbeat in this, and profile election we'll see in the next lecture. Okay, so let me tell you what is this arbiter. So we know this diagram by now. So we have this primary, right, and then we have, suppose we have two secondaries in a replica set. This whole set will be replica sets. Okay, so this process of setting up secondaries is known as, sorry, this is not secondary replica, this will be secondaries, right, secondaries, and this will also a secondary. So now we have replicated, we have done this replication, we know this diagram. So I'm drawing it again to make you understand better. So now we have this replica set. So now when we talk about how these secondary nodes will communicate, or how these replica sets nodes or secondaries will communicate with each other, they will communicate with each other by using heartbeat. So they will send communications, pull request, all those things through heartbeat. So these nodes in the replica set will be sending communication through heartbeat. They will be sending heartbeat so that they will be knowing that okay, they are alive and still running. Okay, so this is what heartbeat is. Next thing is, what is arbiter? So arbiter, I'll say arbiter is a MongoDB process. Okay, so arbiter is a MongoDB instance. Okay, like we have this primary and secondary nodes, same way arbiter is also a MongoDB instance. Okay, it is also a MongoDB instance, but it will not have anything
without any data. So we can set up a arbiter here. Arbiter, we'll call it arbiter. Okay, but what it will do, it will also communicate with secondaries through heartbeat. Okay, but what it will do, it will not have any data with it. So arbiter will not have any data. So arbiters are it's like a replication but without any data. So we can replicate a primary node like secondaries, and if we make it arbiter, it will not replicate the data, it will not have any data. So why we need arbiter? We need arbiter in case of, suppose we have two secondary nodes here, right? Now in case of this primary is wanting to go down and become secondary, so in this case this eligible secondary will call for the election. So it will call for the election. In this case, what will happen? They have one vote. So all these three, this arbiter is not there, suppose. So 1, 2, 3. Now 3 votes are there, and this secondary will win the vote because this primary will support and it will give vote to itself, right? So it will become the primary in this case because there are odd number of nodes. Suppose if we have another replica set where we have, okay, suppose we have even number of, here 1, 2, 3 nodes were there. Now this primary and this secondaries. Okay, so we have 3 secondaries. So now in this case, if this primary is wanting to go down, this primary is going down and it want to become secondary, and this eligible secondary is asking for poll, then what will happen? Suppose this primary is giving its vote to this secondary, this is also giving this one. So now it will have 1, 2 and 3 votes, and it will win the poll and become the primary. But suppose in another situation when this secondary is not giving its vote to this, it is not giving, only it is having votes for itself and this one. So it is having 2 votes here and these 2 votes in opposite. So 2 votes in favor and 2 votes in opposite. So in this case, what is there? There is a tie, right? Suppose this is also eligible node and it wants to become primary. So this will vote this and its own vote. So it will become 2 votes for here and 2 votes here. So it will become tie. In this situation, what we need to do? We need to add a arbiter. So we will add a arbiter and it will function as a quorum. So what it will do? Arbiter will have 1 vote, exactly 1 vote for itself. So this arbiter, what it will do, when it will get the communication from the eligible secondary nodes that it wants to go for a poll for a primary, then it will give its vote to this or any one of them, and then this will become 3. So now this secondary will have 3 votes, and it will become the primary votes. So in case of election, we add arbitrary. So arbiter will have a say in the election. So it will work in the case of election to provide the odd number of nodes, odd numbers of codes, right? So now in this case there are 1, 2, 3, 4 and 5. So 5 votes are there. So whoever gets the 3 votes, it will become the primary node. So arbiter will play a major role in time of poll for election. We will see in the next lecture what is poll for election and how a primary node can go down and become a secondary, and eligible secondary can become a primary node. So see in the next lecture where we will be discussing about poll for primary.
Hello and welcome. And in this lecture, I'm going to discuss about election for primary. So we have discussed what is replica set and how it works. So in this lecture, we are going to discuss about this very important concept, that is election for primary, or you can say replica set election. So why we need election? So what is the need for election and why it happened? So election happened for to choose a new primary. Choose a new primary. So why do we need to choose a new primary? Because suppose we have a replica set, and in that replica set the primary is not available, or something happened to the primary, it is down and it is not accessible to any of the secondary. Suppose we have some secondaries here, and they are not able to access the primary, or primary is down. In this case, eligible secondary can call for the election. It can call for an election, and it can claim that it can become a new primary. So whenever primary is down or primary is not accessible, eligible secondary can call for election, and in that election all eligible members will vote for the new primary. So since primary is the only member in the replica set, primary is the only member which can accept the write operations, right? Write operations can happen only for the primary. So if the primary is down, the whole replica set cannot accept any write operations. You cannot perform any write operations on the data. So in that case, it is very important to hold an election and choose a new primary, so that our whole data can resume the write operation. But if the election is also started, it can take some time. It can take 1 or 2 minutes or 10 minutes, whatever. Okay. So by that time also you cannot write anything, but all the secondary, they can perform as usual for the read operations. So you can perform the read operations or other queries on the secondaries as usual during the election, but no write operation. So while the election, you cannot do the write operation. So this is the reason for the election for primary. So whenever primary is down or something happened to the primary, then we need to go for the new primary, and the process of selecting or electing a new primary is known as election for primary. So this is the brief overview of why the election is needed. In the next lecture, we will be discussing in more detail how this election is happening and what are the eligible members for the primary and what are their priorities. So see you in the next lecture. Hello and welcome back. So in the previous lecture, we have seen what is election for primary and how election happens in brief. In this lecture, we are going to see election for primary factors and conditions. So what are the factors that are going to affect the election for primary, and what are the conditions in which and primary can go for secondary, and eligible secondary can become primary. So we'll see the factors and conditions that affect the election in replica set. So first thing, we must be knowing by now that like this is our primary node, and we have, suppose we have 2 secondaries. This is a 3 node replica set where 2 secondaries and 1 primary. So what will happen, these nodes, they will keep on sending the heartbeat to each other every 2 seconds. So they will be sending the heartbeat with each other for here also heartbeat, okay, and here also heartbeat. So they will keep on sending the heartbeat for every 2 seconds. So every 2 seconds they will be sending heartbeat to each other to know that they are available. So if they won't get the reply for the heartbeat for more than 10 seconds, then they will mark that as a unavailable. In the same way, if primary, suppose this is a primary node and it is not getting the heartbeat from the secondaries for more than 10 seconds, then what it will think, it is not in the connection, it is not in touch with the rest of the secondaries, and then it will think that it has lost its connection with other nodes, and it will step down as from the primary and it will try to become a secondary because it has lost the connection. So this is one factor that will tell the primary to step down and become a secondary. Okay, so in this case, an eligible secondary will ask for the election, and election will happen, and after the election, this replica set, this secondary can become primary. Okay, and primary will become the secondary. So this is one scenario which will ask for the election. Okay, so in same way, there are some other things that will also affect the election. So we will see that as well. So the first thing is, there is also one important concept that is called replication election protocol. Replication. Okay, so this is the protocol replica set follow for the election. So after the MongoDB version 3.2, MongoDB 3.2, a new protocol came into the existence. So now MongoDB election is following the protocol version 1. So earlier it was protocol version 0, but now it is protocol version 1 we are following. In the before 3.2 it was protocol version 0. So this thing also we have to keep in mind. Okay, next thing is member priority. So member priority is also very important factor, because if a member is not having the priority to participate in the election, it cannot vote, and the priority should be 1 to participate into the election. So this is also very important. So what will happen when replica set will have a stable primary? So what it will do, it will follow an algorithm, election algorithm, to make a best effort to get a secondary, which in case if primary is going down can become a primary. Okay, so it will follow an algorithm to find the best available, best priority secondary, so that it can become a primary in case of anything, any mishap happening with the primary. Okay, so this member priority is going to affect the election and the outcome as well, because the member, secondary member with the highest priority will call an election, can call an election. Okay, so it's not that only the member with the highest priority can call the election, even the lower priority secondaries can also call for an election, but that probability is very low and their win chances is also very low. So only secondaries with the highest priority can call for election more often, and their winning probability will be more. Okay, so and one more thing, if the priority is 0, the member cannot participate into the election. So you cannot, this member cannot seek for election, neither can vote for the election also. Okay, so this is one another factor for this thing. Next factor is, if suppose we have a primary or a replica set, whole replica set on a data center. Suppose we have a data center somewhere, and this whole data center is having some problem, and the primary is not available and all the secondary will become the read only. In this case, since the data center has gone down or data center is lost, in this case this primary on this data center can go down, and the eligible replica set secondary can become the primary. So in this case what will happen, we need to have the ability to make the remaining members in the other data center or data centers to elect primary. So this data center has gone down, so we can have multiple data center, right? So we have to make the data nodes available in the data center 2, so that this data center 2 can select a primary. Data center 2 can select a new primary from their replica. Okay, so if this data center is going down, the data center 1 is going down, data center 2 can take over and select a new primary. And this can happen in the distributed environment, distributed replica set, where the replica set is being distributed on the one or more data center. I hope it is clear. If you have any doubt, you can ask in the course question answer area and I'll be happy to answer. So there is one more factor for this election for primary is network partition. Okay, suppose we have a replica set with a stable primary, and suppose we have done with the replication network partition, and on the partition where the primary is there, it is having very less secondaries, and primary is not able to contact the other secondary. In this case, what will happen, this primary with the less data nodes, it can step down and become secondary, and then a secondary with in touch with the more data nodes can become the primary. So another secondary, eligible secondary, will become the primary. So this is another thing. Suppose we have 5 set replica, 5 nodes replica set, and we have done the network partition, and one primary and one secondary is on one network partition, and suppose 4 secondaries are there here. So this primary is only able to connect with this secondary and not with these many. So what will happen, this will step down, and from these secondaries any eligible secondary will become primary. Okay, so this is another scenario where the election for primary can occur. So there are some more concepts that I'm going to discuss in the next lecture. So there we'll be discussing about the vetoes in the election and what are the other things that is going to affect the election and the election outcome. And we will also be discussing about the election. In the case of election, what are the members can participate in the election. So we will also see the voting member and non-voting members. So see you in the next lecture where we'll be covering this. Hello and welcome back. This is Sunil, and in this lecture we are going to discuss about voting and non-voting members. So we'll discuss about the members who can vote in the election and the members who can not vote in the election. Okay, so we have discussed about the voting or elections for primary in the previous lectures. So in this lecture we'll discuss about the voting members. So let me tell you, there are 2 types of members. One is called voting members, who are the members who can vote, and the other type of members are non-voting members. So what is the difference between voting members? And these members can vote and these members cannot vote for the election. Okay, and there can be maximum 7 voting members in a replica set, right? And this and non-voting can be anything up to 43, I guess. Okay, so because why I'm telling 43 here, because I forgot to tell you, a replica set can have maximum 50. Okay, it can have 50 members, right? So out of 50, 7 members can be voting members and 43 can be non-voting. So these non-voting members enable replica set to have up to 50 members, okay, and 7 members can have the voting rights. Okay, that's one thing. Next thing is how we configure this. So when we go for configuration in the replication configuration file, there we can set these members votes and state, okay, to 0 or 1. So if we set like members of n denotes the number of the numbering of the member dot votes. With this we can set the, so this we need to set to 1 to make it eligible for voting, right? The other thing is, this was before the 3.2, before MongoDB 3.2, MongoDB 3.2, before, okay, before MongoDB 3.2. So after MongoDB 3.2, what we need to do? After MongoDB 3.2, we need to set the priority of a member, to 1 to make it eligible for voting. Okay, so this thing you have to remember, okay, this priority 1, and before 3.2 we need to put the members of n voting equal to 1 to make it eligible for voting. Okay, so this is one thing, and then we have to put one more thing. So I hope this is clear. We need to give the priority 1 to make a member eligible for voting, and if we set the priority 1, we cannot set the votes 0. Okay, so it have to greater than 0, right? Because it can vote, so at least it should have a 1 vote, right? So this is the thing. For non-voting members, you can set it to 0, priority 0. Okay, so next thing what I want to tell the state. So first thing we need to set the priority that we have, I told you, priority to 1. Next thing is state. So we need to set the state also, state of the member. So state of the member should be to take part in the voting or election. The state should be any of these things which I am going to tell you. First thing is it should be primary. The next one is it should be a secondary, it should be recovering, or it should be a rollback, and it should be in the arbiter. So to be eligible for voting, a member should have the priority 1, and then it should be in the any of these state. Either it should be primary, secondary, recovering, rollback, or arbiter. If it is not in this state with priority 1, it cannot vote. It has to be in this state. So keep in mind. Okay, then non-voting members, as I told you, the non-voting members cannot vote, but they make the replica set eligible to have 50 members, right? 50 members, because it can have only 7 voting members, and rest of the things we can have as a non-voting, right? So that's important thing for the replica set if you want to have more members. And these can have the read-only privileges, so you can read the data from the replica set of non-voting members. So That's one thing. So this is all about voting members and non-voting members. So suppose we have a replica set. Suppose we have a replica set which is having one primary node and secondary. Suppose key 5 and then suppose 6, 7. So 7, then 8, then 9, then 10. So this is the primary. It will have one vote, secondary one vote. All these are voting members, right? So 3, 4, 5, 6, 7. So 3, 3, 7. Now rest of these members will be non-voting members, and all this together will form a replica set. So it will have the primary and 6 other voting members, and it can have 4 non-voting members. So this is important thing. Okay, in the next lecture I'll tell you how we can write a configuration for making a member to priority 0 and 1 so that it can take part in the election. So see you in the next lecture. Hello and welcome back. So in this lecture we are going to see how we can write a configuration for voting and non-voting member. So I hope you got a better understanding of replica set and how we do the things, how replica set works and how the election in replica set works. So to take part in the election we need to configure members as a voting member and non-voting member. So that is very important step. So in the next lecture we'll see in more detail by how to write a document. Here I'll just show you the configuration how we do. So first we need to write a document and we need to provide the ID. ID will be of number type. Okay, so this ID, document ID, it will automatically come from the MongoDB. Then we need to give the host. We need to write the host with the port number that we know, right? So here we need to give the host name with a port on which MongoDB is running. Okay, so this thing we need to give. Then we have another attribute that is arbiter only. So if you want to configure a replica set member as arbiter only so that it can act as an arbiter, so you can write here true. Since I'm configuring a non-voting member, so I'm giving it here false. You can give it true here in case you want to make it a arbiter. Okay, so true if arbiter. Okay, so always remember this thing. Next thing is we have another attribute that is called build index that you can write true. So we need to write build index and that will be true. If you want to build index you can give true, otherwise you can give it false. It should be indexes. Okay, next one is hidden. So if you want this member to be hidden you can write true, otherwise it will be a false. Now comes the priority. So this priority is important in making a member as non-voting or voting. If it is set as 0 it will be a non-voting member, or if you can set it 1. So if it is 0 it's a non-voting member, and if it is 1 it is a voting member. This is not voting, non-voting. Okay, and 1 means the voting member. Okay, so this priority is very important. Next thing is, the next one is tags. You can give the tags if you want, otherwise leave it. And the next one is we need to close this And next is we need to give the number of votes it can have. So here if it is non-voting, you can give 0 because it will not have any votes to give. And if it is, sorry, this I close for tags. Okay, so if you can give tags here, and this one we close here. Okay, so 0 or 1, or how many votes you want to give, that you can give. Always give 1, okay, in most of the cases. So for non-voting members, priority and votes both will be equal to 0, and for voting member it should be, both should be 1. So this way we can write the configuration file to make a member voting and non-voting. Okay, I hope you got a idea of how to write this file. In the next lecture I'll show you how to write the members, particular members priority and votes in a configuration file. So see you in the next lecture. Hello and welcome back. So this is Sunil again, and in this lecture I'm going to tell you a very important thing. So we will write the configuration for the members as well, but before that let me tell you a very important thing, that is you should not be increasing the number of votes. So in the last lecture we have seen we can write the votes, right, for a particular member, voting or non-voting. So this votes value you should not increase. Okay, you have to give 0 or 1. You should not be writing it like a 3, 4 or to select a primary. So you should not be doing this, right? So if you do that, what will happen in case of undeserving secondary or something will become primary. So it will affect the election for primary in a bad way. So never do that. Instead, if you want to do that, this is recommended. You can increase the number of votes from 1, 2, 3 or 4 in case if you want to have more than 7 members, more than 7 voting members. Okay, so in this case only you can increase, otherwise never do this. Okay, so this is one important thing I wanted to let you know. So let's see how we can do the configuration for a particular member. So we know that non-voting member must have priority 0. So if it is a non-voting member, its priority should be 0, right? Priority should be 0 and votes also should be 0, right? If you do these things, it will become a non-voting. If you put 1 and 1, it will become a voting member, right? So how we do when we have a Mongo shell open, Mongo shell, while writing the configuration. So inside Mongo shell, how we write this configuration? So for that we can use a cfg equal to rs result set dot conf. So you can use this configuration method to write the configuration file. Okay, so this will give you the document that contains the members field with their votes and priority. There you can write. So when you open this document, you can go ahead and write the configuration for members. So we can use this cfg dot members, and then in bracket you can give the members like 2, 3, whatever. Okay, and then dot votes to define how many votes it can have. So you can put 0 for non-voting and 1 for voting. Okay, so this way. So in the similar way we can put cfg dot members. This denotes the third member, right? This 3 means third member, and similarly for third we can write the priority also 0 if it is non-voting. For voting you can give 1. Okay, so in the same way we can write the configuration for others as well. You can write cfg.members. Okay, here it should be yes. For suppose you want to write the configuration for fifth member, so fifth dot votes equal to, suppose it's a voting, then put 1, and cfg dot members 5, and priority also you can write 1 or 0 depending on what you want to configure. So this way cfg.members and the indexing of the member, number of the members, and then votes and dot priority, we can write the configuration for the particular member, right? Now the question comes, suppose we have configured this with this rs.config, right? So we have used this rs.config function to configure. So this is for configuring, right? Suppose I have configured and I want to reconfigure. For reconfiguring we can use rs.reconfig. So we have another function, another method, that is reconfig, and we can pass this cfg here. So you can write this like this. So rs.reconfig is another method to reconfigure the priorities and votes for our members. Okay, so now when we use this rs.reconfiguration, it can force the existing primary to step down, right? So when we reconfigure things to elect a new primary, so it will ask the current primary to step down, and then the election will happen. So when election will happen, what it will be doing, it will stop all the operations. So primary is down, you cannot write the things on the members, you cannot you cannot do the write operations, you cannot do the read operations as well, because everything will be down. So in that case, what we need to do, we need to do this configuration and reconfiguration only at the time of downtime. When you are doing your maintenance work, then only you do, because while election will happen, you cannot write or read the things on the replica set member. So it is always recommended to do this reconfiguration and configuration while doing the maintenance work, so that when the system is up and running, your users will be able to read and write things on the replica set data. So this is the things I wanted to let you know. See you in the next lecture, where we will be discussing some more concepts. Hello and welcome back. So in this first section of replica set setup, we are going to learn about replica set setup. So what we will do, we will first start with the single node replica set, and then when we are good with the replica set with a single node, we will go ahead and try to create multiple node replica set. So this thing I'm going to do on a single machine, because I'm using only one laptop. So what we will do, we will use a single machine. On a single machine or single laptop we will use, and what we will do, we will run the MongoDB instance on different port, MongoDB instances on ports, different ports, and then each ports we will try to make them as a replica set member. So we will be doing this on the single machine, and then we will run the MongoDB instances on a different ports on the same machine, and then we'll try to add them into the replica set. So we will start with the single node first. So in the next lecture I'll show you how to set up a single node replica set, and in the following lectures we will start with the multiple node. So we will cover everything. So we will see also multiple node replica set as well in the following lectures. So the thing is, first we'll on the single machine multiple instances of the MongoDB. First we'll see the single node and then the multiple node. So this is the agenda of this section, and we will also be covering some more things, some commands, some help things on the replica set. So we are going to learn all those things for replica set as well. So if you have any doubt, you can ask in the question answer area of this course, and I will be happy to answer that. So I'm parallelly doing the sharding as well in the next section, in the sharding section, so you can go ahead and see those also, because replication and sharding was the long pending topics to be covered in this section. So I'm covering all this week. So I hope I'll complete by this week replication setup and sharding as well. So see you in the next lecture where I'll be doing the single node replica set setup. Hello and welcome back. So in this lecture I'm going to set up a single node replica set. So for this we need to know two things. We need to know the one configuration, that is REPL set. So whenever we want to start a replica set, or we want to configure replica set, or we want to set up a replica set, we need to use this REPL set while starting the MongoDB server. So we are going to use this REPL set, and rest of the thing is same. First we need to start the MongoDB server by using REPL set, and then we need to use MongoDB space -- REPL set, and then here we need to give the replica set name. So here I am giving replica Sunil. So here you can give any name to your replica set. So here I am giving simple name replica set Sunil. So you can give anything, any name that you want. Okay, so for simplicity I am giving replica Sunil. Okay, and then we need to use the simple db path which we use, and then we need to give the path for the db data/db. Okay, so here I am using data/db1. okay, so I've created a new folder db1, and there I'm going to start the MongoDB server. So MongoDB space -- REPL set REPL set REPL set, and then the replica set name. This will be the replica set name, and then the db path. Okay, so hit on enter and our server will be started, and so it will be started for replica set, and then we can go and start a Mongo. We can connect to a Mongo cell, and we can configure a primary for this replica set. So start, hit on enter, and the MongoDB server will be started. So let's see the detail here. See here it is showing waiting for connection from port 2707. So this is the default port we know, and in the next lecture when we do the multi-node replica set, then we will use the different ports for different nodes. Okay, so here it's saying replica set configuration document. It did not find the replica set because we have not given any configuration yet. So it has started for replica set, but there is no configuration, so it has not given anything. So see here it is showing replication options, replication. Let me highlight. See here it is showing options, replication, a REPL set, and here the replica set name replica Sunil that we have given, and it is also showing the storage db path d colon MongoDB /data /db1. So now we have the MongoDB server up and running. So let's connect to the Mongo. So here I'll connect with the Mongo. So I'll just put Mongo and it will be connected to this. So see here it is saying connection accepted from this host 127.0.0.1:50937. So one connection is open now. So now we are connected to this server through Mongo shell. So now we'll see whether this Mongo instance is connected, is a replica set or not. Okay, so we have not done anything, but let's check. So rs.status will give you the replica set status. See here it is saying that run rs.initiate if not yet done for the set, no replica set config has been received. Okay, so we need to run the rs.initiate. What rs.initiate will be doing, it will initiate the replica set for this instance. Okay, so let's run this. So we will use rs.initiate to initiate the replica set. So hit enter, and see here as soon as we hit enter there was some thing going on the server and it is saying primary completed. Let me show you what has happened on the server. See here transition to primary complete means earlier that node, that Mongo instance was just like a normal instance, but now it is transited to the primary. So now that is the primary node. So transition to primary, assuming primary role in term 1, conducting to dry run, if we could elect it, could be elected, transition to secondary. So see here now transition to startup 2, transition, so something has gone, and here it is saying that primary complete, database rights are now permitted on this. So let's see the instance. See here it is showing replica Sunil. So now it is showing the replica set name Sunil and it's showing other. So now we will run the rs.status to see the status of the node, and see here it is giving all the information about the replica set. It is saying the set name is replica Sunil, date is this, my state is 1, term is 1, heartbeat interval millisecond is 2000, and members are id 0, and this is the port and the computer name. Okay, and here status is primary, state string is primary, it means this is the primary node, and uptime is 253, uptime is this one, and could not find the member to sync from. So this is single node, so there is no other member. Okay, so now we have configured a replica set with a primary member. That means we have a replica set with one member, and that is primary. Obviously that will be a primary because primary is important. Primary, one primary member should be there. So since we have only one member in this replica set, and that is primary, so this way we can configure a single node replica set where there will be only one member and that will be primary. So what we need to do, we need to follow these two steps. First we need to start the server with a configuration MongoDB space hyphen REPL set, and then we need to give the replica set name, and then other things will be same. Okay, DB path we need to give, and once server is started we need to connect to the Mongo instance, and then we need to check the status, and if it is not yet configured as the replica set, then we need to use the rs.initiate to initiate the replication. And once the replication is initiated, this node on which we are running, it will be converted to the primary data node for this replica set. And here you can see the with rs.status, you can see the status of the node, and you can know that whether it's a primary node or not. And here you can see all the details for that. So this way we can set up a single node replica set. So in the next lecture, we will try to configure multi-node replica set or multiple node replica set, where we can have multiple nodes as a member. So one primary and 2 or 3 secondary members will be there in the multi-node replica sets that we are going to set up in the next lecture. So see you inside the next lecture. And if you have any doubt, any question, do ask in the question and answer area of this course, and I will be answering all of your questions as soon as possible. So see you inside the next lecture, where we will be configuring the multi-node replica set. Hello and welcome back. So in the previous lecture, we have seen how we can start a replica set with a single node, where there will be only one node and that node will be primary node. So in this lecture, what we will do, we will try to set up a replica set which will be having one primary node and 2 secondary nodes. So this will be a 3-node replica set, something like this, what we have understood in the lecture understanding replica architecture, replication architecture. So primary node and 2 secondary node, that is what we are going to do in this lecture. So to do that, what we need to do, we have only one system. So unlike in the production environment, there will be multiple hosts running the replica sets, but we have the limitation, we have only one laptop. So what I do, I will be initiating a different MongoDB instances on the same laptop with a different ports. So I'll start 3 MongoDB instances on 3 different ports. So one will be default 27017, that will be the default port, and then I'll be using 27018 and 27019. So these 3 ports I will be using to start my MongoDB instances, and then we will try to configure the replica set with these 3 nodes. Okay, so let's get started. So to do that, we need to do a simple things first. We need to inside the data/db path, we need to create 2 more folders. One is db that we already have, so we will create one more with db1 and db2. So here one MongoDB instance will be initiating, here another one, and db2 will be containing the third MongoDB instance. So now we have created these empty folders. So now let's start the MongoDB instances. So open the command prompt, and the same process you can follow on the Mac OS or Linux, whatever you are using, the commands will be same. Okay, so I'm using Windows 10, so I'll be doing here. So first thing, we need to write the same command which we have written in the previous lecture, that is MongoD --repl set, and replica set name I'm giving the same as replica Sunil. You can give any name that you want to give to your replica set, and then space, then db path --db path, and here I am starting the first server on default port 27017. So I'm giving the data/db, and I'll hit enter. So when you hit enter, the MongoDB will be starting. The server is started and it is showing 27017, which is the default port for MongoDB. So our server has started. So let me connect to Mongo cell, so I'll use Mongo and it will be connected to this. See here, now the one connection is now open. So next thing is I will check whether the first let me check the status of the replica set, whether replica set has initiated or not. So see here, now not initiated. Okay, before initiating, let me start another instance of MongoDB. So I'll use the same thing. Let me copy to save time. Let me go here and I will copy the command and I will try to start another, and I'll give here db1 and I'll give port 27018. okay, so so here what I'm doing, I'm starting another MongoDB instance and I'm giving a different DB path, db1 here, and I'm giving port 27018 because 27017 is already running. So hit enter. So see here, now it is started. Let me connect another Mongo cell with this. So to connect Mongo with a defined port, so I'll give port here 27018. So this Mongo cell will be connecting to our second Mongo instance. So let me hit enter. So see here, this is also connected. Let me check the status here as well. See here also no. So let me start the third one as well. So go to the MongoDB bin and then let me copy the command again from here. I'll just copy. Okay. I'll copy paste here and I'll change this to 27019 and this will be db2. So I'm starting the third MongoDB instance, MongoDB server. So this is also running. Let me start another. I'll go to bin and I'll connect to this with the port specification 27019 and I'll check the RS status here as well. So see here, now we have three servers, one server here on 27017. It is running on 27017 and we have another server running on the 27018 and we have another MongoDB instance running on the 27019 and we have connected three Mongo cells here. So now if you want to know the host name, okay, let me first initiate the RS. Let me initiate the replica set so that we can configure. So let me initiate. We have used this command in the previous lecture. To initiate the replica set, we need to use rs.initiate and hit enter. Okay, so let me check the rs.status and see here it is showing me the host name 27017 Meenakshi. Meenakshi is the computer name, my computer name, and it is showing Meenakshi : 27017 is the host name and it is showing this is the primary node. Okay, so now we have initiated the MongoDB and this node has become the primary node and it is showing the replica set name replica Sunil and it is showing as primary. So let me check the status of the other two. So let me check here. See here, still nothing. Okay, and here. Okay, so now what I do, now this the primary will have the privilege to add another instances to the replica set. So we can use rs.add. We can use this command rs.add to add the other running node to the replica set. And here inside the add, we need to provide the host name. So let me find the host name of the second one. To find the host name, we need to use the db dot so db.hostname we can type and we will get the host name. So here host name is the same as what we had in the primary node, but only the port number is changing. Okay, so 27018 is the host name for this. So we will go back to the primary and here we will add this. Okay, so I'll simply paste. Okay, so now hit enter. See, the status is okay. So now run the command rs.status, and now you can see here, earlier it was showing only the id 0 for primary. Now it is showing id 1 Meenakshi colon 27018 and status is secondary. So we have one secondary node added. So let's check here. Let me scroll up rs.status and see here it is showing the, now it is showing the secondary. So now it is showing the secondary. So this node has become secondary now because we have added from the primary, and here also it is showing all the replica set information. Primary is Meenakshi 27017 and secondary is 27018. In the same way, I'll add the third node as well. So I'll use 0 rs.add. Let me scroll up. rs.add 27019. So this is the third one. So hit enter. So now okay. Now check the status and see here. Now we have the three entries in the list: id 0, id 1 and id 2. id 2 is the 27019 and it is showing startup. Still this configuration will be going on in the backend. It will take some time. So let me check again rs.status, and now it has changed. Now it is showing the secondary. See here, it is showing secondary. So now we have added this as also as secondary. See here, the status is showing secondary 27019 secondary, and in the same way 27018 also as secondary, and 27017 is primary. So let me show you this inside the third instance Mongo shell. So here I'll use rs.status and hit enter. And see here it is showing the same information what we have seen in the primary. So now 27019 is secondary, and here also it's showing replica secondary. So this way we can add hosts to the replica set. We can add the MongoDB instances to the replica set by using rs.add. So we have seen how we can start the MongoDB replica set, and we can initiate the replica set by using rs.initiate, and we can find the host name by using db.hostinfo, and then we can add the members to the replica set by using rs.add by providing the host name inside the add function. So this way we can configure the multi-node or 3-node replica set. So I hope you guys understood this. If you have any question or doubt, you can ask inside the question and answer area of the course, and I will be happy to answer. And we will see some more more things about the replica set in the next lectures. So keep watching the course, and see you inside the next lecture. Hello and welcome back. So in this lecture we are going to learn about sharding. So MongoDB sharding is what we are going to cover in this lecture, and in this section we will cover all about sharding in MongoDB. But in this particular lecture we are going to discuss about what is sharding and why it is needed. So let me first give you definition of sharding. So as per the definition, sharding is a method for distributing data across multiple machines. So this is the definition. Sharding is a method for distributing data across multiple machines. So now you must be thinking why we should distribute data across multiple machines. So the answer why we need sharding is hidden inside this across multiple machines sentence. So why do we need MongoDB, or why do we need sharding in the first place? So let me tell you, we use sharding to support the deployment. We use sharding to support the deployment with large data sets. Okay, so it is a method for distributing data across multiple machines which support deployments with large data sets and with very high throughput. Okay, so when we are having a very large data set and very high throughput operations, then we have to go for the sharding. So let me put some more light on this. So let me tell you, suppose we have a data set. Let me scroll down. Suppose we have a very large data set. Suppose this is a large data set, and we are doing very high throughput operations for read, write, all those things, delete, all those operations are going on this data set, and we want to keep this entire data set on a single server. So what will happen when this data set will keep on increasing and it will become very large data set over days, over time? Then it will be difficult to manage this high throughput data by this single server, because this data set is increasing but this single server capacity is not increasing. So to handle all these data set with the high throughput operations, we need to increase the capacity of this single server as well, right? And this can be done by adding more RAMs, more hard disk, all those things, right? CPU capacity and all, if we add, we can increase the IO capacity and all. But this increasing the RAM and hard disk and to CPU and all, it is very costly, because the server which we were using earlier, we need to replace this with another server, another very high efficient server, which will be very costly, right? And when we remove this server, we will replace it with another server. So this server, we have to throw it out or we have to use it in some other way, but anyway we are going to invest a lot of money and resources in deploying a new server. And this kind of thing, increasing the RAM, hard disk for a single server, even the adding the RAM also will cost you more, right? This is known as vertical scaling. So we are scaling the server vertically, right? We are increasing the capacity of the server vertically. But MongoDB, what it does, it supports the horizontal scaling. So what is this horizontal scaling? Horizontal scaling means we have this data set. Suppose currently it is being distributed over a server 1, right? And when we need more RAM, more CPU, then what we do? We will add one more server 2, and we will distribute the data set over 2 servers. So vertical scaling involves increasing the capacity of a single server, whereas the horizontal scaling involves dividing the system data set, this data set, and load over multiple servers. So now we are dividing this data set, we are distributing this data set over the one or more servers. Okay, so this is known as horizontal scaling, and this is what MongoDB supports. So now the workload of this high throughput large data set is being handled by these 2 servers. If over time we need one more capacity, we can add one more server here, server 3, and this data set will be distributed over 3. So in this way we can add more scalability to the server by adding one or more machines, and each machines will be very low configured machines, but they can handle the small data set of this large data set, right? So they are not going to handle this entire data set. If you put entire data set on a single server, it will collapse. But when we distribute this data set over 1 or 2 machines, different servers, they can handle it well. So this is what known as horizontal scaling. So horizontal scaling involves dividing the system data set and load over multiple servers, adding additional servers to increase capacity as required. While the overall speed and capacity of a single machine may not be high, so what does it mean? This server 1 capacity is not as high as required to handle all this data set, but it is quite lower, but it will work with server 2 and server 3. So all these 3 together can handle the data set pretty well. Each machine handles a subset of overall workload, potentially providing better efficiency than a single high-speed, high-capacity server. So these 3 together can perform much better than the single high-speed and high-capacity server. So this is why we go for the horizontal scaling, which is very less in cost and it is very easy to configure and deploy. And that's what horizontal scaling is all about, and MongoDB supports this horizontal scaling through the sharding. So horizontal scaling through sharding. So sharding is somewhat horizontal scaling of the servers to handle the large data set with high throughput operations. So we will see in the next lecture what is sharded cluster in MongoDB, and I hope you understood why we are going with the single server to multiple server horizontal scaling, because single server can be very costly to upgrade, but when we go with the multiple servers, it is easy to add one more server here, server 4, and thus it is very easy to and low cost to maintain also and add more servers over the time. So see you in the next lecture where we'll be discussing about the sharding clusters and all. Hello and welcome back. So in this lecture we are going to learn about sharded clusters, and we will also see how the sharding architecture look like in MongoDB. So we will see about sharded cluster in this lecture. Okay, so this is what we are going to see in this lecture. So let me tell you. So this sharded cluster is going to be in 2 or more lectures. So and I'm not going to cover in one lecture. I'll split into 1 or more lectures so that we can understand better. So in this I will simply tell you what are the components of the sharded cluster and how it looks, and in the next lecture we will see in more detail. So sharded cluster has 3 main components. So the first component is known as shard. So shard. Okay, so the first component is shard. The next component is MongoDB. So MongoDB you must have seen in while installing the MongoDB in binaries. When you unzip it, you must be seeing the MongoDB, Mongo, and in that you must have seen MongoDB also. So it comes with the MongoDB installation. So you could have seen this, right? So MongoDB, and the next is config servers. So these 3 are the main 3 component of the sharded cluster. So what is shard? Shard is actually it's a subset of the data. So we know that we are splitting the data. We are splitting the data set over multiple machines. So each shard will contain the subset of data. So it is actually a subset of data, subset of the data set, sharded data, right? Data, subset of data. Okay, and actually each shard is like a replica set. So replica set. So I will tell you in the next lecture how actually it is a replica set, but for now it is okay to know that each shard is a set of replica sets. So replica set will contain multiple hosts, like host 1, host 2, like that, right? So whatever data we are sharding, the subset of data, it will be splitted over the multiple hosts, multiple machines, and that's why it's a replica set. Okay, so each shard will contain a replica set, okay, or host of machines. So shard is actually a subset of data that we are splitting over the multiple machines. So one sharded cluster can contain multiple shards. Okay, so next thing is MongoDB. So what is MongoDB? MongoDB actually it's a router, it's a query router for this cluster. Sorry, extremely sorry. It's a query router. It's a query router. So what happens in the sharded cluster, we will have the different shards. Suppose one shard here, one shard here, one shard here. So suppose this shard 1, shard 2, shard 3. So we'll see in detail in the next lecture, but here just to understand. So what I said in this shard is actually a replica set. Okay, and this is also one replica set, and this is also one replica set containing different documents and all, and if on the different host. So now suppose we have a app server here, application running here, and I want to access this data or shards. I cannot directly access this. To access this, what I need to go through the MongoDB. So MongoDB will be here in between the app server and the shards, and whatever I want to query, whatever I want to know, I have to go through the MongoDB, and MongoDB will be fetching the data and giving it back to the app server. So all the query and all, it should be routed through the MongoDB in app cluster. So this is one important thing to know. Okay, so this is what the MongoDB, it's a interface between the client application, this app server client application, and the sharded cluster. So it will provide the interface between these two, this and this. Okay, so I hope you understood. In the next lecture we'll see in detail. And next is config server. So what is config server? Config server actually stores the metadata. So it is actually a metadata for our sharded clusters and all the shards and the replica sets inside the shards. So it will actually have the metadata and also the configuration detail. So configuration, config settings and all for the servers will be here. So, and this will also be a replica sets. Okay, so this shard is replica set, and the this MongoDB is the interface between the application client and the sharding cluster, and this config server is actually a metadata and configuration setting, and it will be hosted on a replica set. Understood? So it is also a it must be, this config servers must be deployed on the replica server. Okay, replica set, deployed as a replica set. So this is shard, MongoDB and config server. These three are the main component of the sharded cluster. In the next lecture, I'll show you how the architecture of the sharded cluster looks like and how we can understand in a much better way. But for now, it is enough to know that shard, MongoDB and config servers are the three main components of the sharded cluster. So see you inside the next lecture where I'll show you the architecture of the sharded cluster and much more. So in the previous lecture we have seen what is sharding and what are the components of the sharding. So we know that there are three components of the sharding, that is shard, config server and the router, that is MongoDB. So in this I'll show you how in picture they look like, or the architecture, or the how they communicate with each other. Okay, so suppose we have an app server running here, the app or the client here, and we have shards here. So shards are the data sets that we have split it over the multiple machines. Suppose we have shard 1, shard 2, shard 3 and shard 4. We also know that all these shards are replica sets, right? So this replica set will contain three different hosts or 3 or 4 hosts. So this is the replica set. Similarly, shard 2, shard 3 and shard 4. And when we want to communicate to the shards or the data or the documents which we are keeping on these shards or on this replica set, what we can do, we cannot directly communicate to the shards or the data stored on the shards. What we need to do, we need to go through the router. We need to go through the MongoDB. So MongoDB is a router through which we can communicate to the app. So app will communicate to the MongoDB and MongoDB will be communicating to the different shards. So this MongoDB will have some of the things, some of the configuration that it can communicate to the different shards and can get back the what is requested by the app server or application.
So here we can have multiple shards. We can have multiple app routers. We can have one or more routers. So we can have one more MongoDB here, not a problem. So depending on the requirement, we can have the multiple MongoDB. Okay, and they can communicate to the shards and they can get the data. And in between these apps and the MongoDB, the thing, we have the config servers, right? So config servers will be somewhere here, and this will be in between these two. So this config server will be like MongoDB will be, it can go to the router and it can go to the different shards as well. So it can have all the configuration inside the config server. So app server will go to the MongoDB, MongoDB will go to the config servers and get the details, and then it will communicate to the this thing. Or we can place it in a much better way to understand. Let me remove this. So we can, like, it can be in between the, like this, and to all the servers like this. Okay, so it will have the configuration for all these shards and the MongoDB, the router. So how this MongoDB will be knowing about the data or documents stored here, and this is done through the collection level. So what MongoDB does, for each shard or each document or each collection in MongoDB, what it will do, it will use the partition of the collection using shard key. So whenever app data will communicate to this will, MongoDB will look for the shard keys, and then it will go to the shard and it will fetch the detail. So shard key will see what is that. It will consist of the field. Suppose we have a field called student ID. So this student ID, we can make it as a shard key, but the condition is it should be there in all the collections, then only it can become a shard key. So with this shard key, we can, MongoDB, the router, can go and get the details for the collection. We'll see how this shard key is defined in the next lecture, but for now it is good to know that we have the collections here. The collection will be split into the chunk of data, and these chunks will be stored with the shard key, and this shard key, with this shard key, MongoDB will get the details. So this is how the MongoDB shard cluster works. So we have the shards here and the shards and the app. The app will request to the MongoDB, and MongoDB with the help of shard key can get the data from the different shards, and different shards are actually a replica set, and this config server is also a replica set. It should be deployed as a replica set. So sharding and replica set will go hand in hand, because all the machines which we are deploying on the shards, actually they are the replica set, the host of machines where we have distributed our data. So I hope you guys understood this, and if you have any doubt, please do ask. I can repeat this concept again. If it is not clear, you can comment your thoughts in the comment section of the course, and I can revisit this lecture if it is not understood well. So do let me know if it is clear or not. Hello and welcome. So in this lecture we will learn more about shard key and how it is created, and how we can distribute the collection on the
shards. So let's see. So we know that we have this shards, suppose shard 1, shard 2, shard 3 and shard 4 here. We have MongoDB here and we have the app here, right? We have MongoDB here, so we'll communicate to MongoDB. MongoDB will be communicating to the shards, correct? This way you understood, right? And these shards are actually a replica sets, right? That we know. So now we will try to understand how, suppose we have a collection here and that collection we are distributing over this shards. So what MongoDB actually does, suppose we have a collection, it will partition that collection into chunks. So it will create chunks from the collection, chunks of data, and these chunks, what it will do, it will split over the shards. So this chunks of data, chunks of the collection will be splitted over the shards. So how it is done? Actually, it is done based on the shard key. So shard key is actually created from the collection. Suppose this collection is having one like student ID. So this student ID will declare as a shard key and it should be there in all the documents, this student ID. Whatever field you are going to make as a shard key, it should be immutable. It should not be changing and it should be available in all the documents of the collection. Then only it can eligible for the shard key. So suppose student ID, we made it like a shard key and this is shard key is range based. Okay. So it is actually range based. So what we will do, we will divide this collection into chunks. So these chunks will have this shard key student ID. So this student ID, based on the student ID, it will be divided. So now this collection is divided into the partition into the chunks, and these chunks will be, suppose one chunk will be here, 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 and all the data documents will inside the collection is now divided into the chunks with the help of shard key student ID. So now how this application will be knowing, or MongoDB or MongoDB will be knowing that where the actual data is. Suppose I want to query for the student ID equal to 10. So suppose I want to query this. So when application will query for student ID 10, what MongoDB will be doing, it will have the access to the all the shards and the chunks. So what it will do, it will immediately look for this student ID 10 belongs to which chunk. So it will look for the chunk on which this student ID 10 is there, and then it will go and fetch the detail from, suppose student ID 10 is in this chunk. So it will communicate to the shard 1. If it is on shard 3, it will communicate to the shard 3 and it will immediately fetch the data and give it back to you. So actually this is range based. So suppose 10 to 20 student ID is on one chunk. So suppose that 10 to 20 belongs to chunk 1 and chunk 2, and it is on shard 1 and shard 2. So it will only communicate, it will only scan or search inside this shard 1 and shard 2 for the student ID 10. It will not look for chunk shard 3 and shard 4. So this is what this is how the shard key and the chunks are created. So application to MongoDB will look for the student ID 10, and then it will look for which this student ID shard key 10 belongs to which chunk. Then it will find the chunk, then it will look for the which chunk is on which shard. So all these details will be there in the MongoDB through the config server and all. It will have all the metadata and everything. So it will have all the details about the which chunks belong to which shard and which student ID sard key belongs to which chunk. So based on that, it will fetch the data. Suppose if we are not following the sard key while fetching the or creating the sards, then what will happen when you search for the student ID 10, the MongoDB will scan all these 4 sards and it will take a lot of time. So that's why they have created this sard key, which is range based sard key. So it will look for the student ID 10 and it will first look for which chunk it belongs to, then it will look for that chunk is on which sard, and then it will fetch the data, fetch the related data or related query from that chunk, from that source, from that replica set. So this way it is very easy to query. It is very efficient and it is very time saving thing. So that's why it is based on the sard key. I hope you guys understood this. If you have any doubt and if still have some confusion, you can ask in the question answer area of the course dashboard and I will be happy to answer, and I am ready to repeat this if you guys want me to do so. So please do ask your questions in the Q&A area of the course and I will answer your questions. So see you inside the next lecture.
Hello and welcome to the section Accessing MongoDB with Java. So before we start creating our first project using Java J2E, let's have some hands-on session with Java by connecting to MongoDB using Java. So in the previous lecture we have connected to MongoDB using Mongo Shell. So now we'll do hands-on with the Java. So for that, what we do, we will start with installing a IDE. So for Java we need an IDE. It is always recommended to use IDE. So we'll download the STS and we'll start using that. Then we create a maven project and add dependency for MongoDB Java driver, and then once that is done, we'll create a class and we'll try to connect to the MongoDB with the help of Java, and then we will start creating a database using Java, then collection, and then we try to insert document using Java. We'll also do some CRUD operations with Java into the MongoDB. So let's get started with this section. Hello and welcome back. This is Sunil again, and in this section we are going to connect to MongoDB with Java. So the very first thing, we need to have an IDE to start developing into the Java. So for that, I'm going to download and install STS. STS means Spring Tool Suite. So Spring Tool Suite is a very good option to start with Java or Java J2E or Spring framework. So I use STS and I recommend everyone to use STS. So it is STS is a Eclipse based IDE and it is ready-made for using for building anything with Java or Spring. Okay, so we are going to use the Spring Tool Suite, and if you come down on this website spring.io, that is the Spring official website, and if you scroll down you can find the Spring Tool Suite option here. When you click on the learn more about STS, it will take you to this page. Here you can read more about Spring Tool Suite, which is saying that it is an Eclipse based development environment that is customized for developing Spring applications. It provides ready to use environment to implement, debug, run, deploy your Spring applications, including integration of Pivotal TC server. This is very important. You need not to go and install your Apache server or Tomcat server separately into your Eclipse. It is already plugged in. So Pivotal TC server is already plugged in into the Spring Tool Suite, and that is a very good option. So this is already integrated. Server is already integrated. So once you download and install the Spring Tool Suite, you are ready to go with the Java J2E application development. Okay, and it is also supported for Git, Maven, AspectJ, and comes on the top of the latest Eclipse releases. So you need not to worry about the Eclipse releases. If you are downloading the latest STS, it will be
on the top of the latest Eclipse release. So you'll find the UI or user interface similar to what you see in the Eclipse releases. So here you can click on the see all versions, and when you click on that, it will take you to the download Spring Toolset page, and here you can find all the options for Windows, like for Windows 32-bit and 64-bit option. For Mac also there is a 64-bit option. For Linux there is a 32-bit and 64-bit options are there. So based on your operating system, you download the zip file and unzip it and start using the STS. So for Windows I'm using 64-bit. I'll click on this. So click on that. When you click on that, the download will start here. It is around 463 MB of file. It will take some time to get it download based on your internet connection. So I'm already having the Spring Toolsuite installed in my computer, so I'm not downloading. That's why I cancelled it. Okay, so you complete the downloading process, and once you complete the download, you can find the STS zip into your download folder. You can find the STS zip file. You just right click on that and unzip. When you unzip, you will find this folder similar to this folder, or it will be STS bundle or STS Spring Toolsuite bundle kind of thing. You click on that. You can see the legal, pivotal TC server and STS version here. Okay, so click on this link folder, and here you can find the sts.exe. So sts.exe is the file where you need to click. If you are on Windows, click on it and it will open. There is no need of installation. You just download the zip file, unzip it and find this sts.exe and click on that. Select the workspace location wherever you want your drive and click on OK. So when you click on OK, STS will start configuring your workbench and workspace, and it will take a minute of time and it will be ready to using. See here, now STS is started. See, the first time you can see the dashboard. The same website will be loaded here, spring.io, and you can find all the options here related to STS and Spring. Okay, so here you can find the server, pivotal TC server. Okay, and here you can start creating the projects, classes in Java and all. So from next onwards, we are going to start creating project and connecting to the MongoDB database. See you in the next lecture.
So let's get started with creating a MERN project in STS. So this is the Spring Toolsuite which we have downloaded in the last lecture. So you can find here there is a file option. There you can find new, open file. If it is existing, you can open it. New, inside new you can find all the options for creating Spring Starter project or importing a project, and then Spring project, Java project, static web project, dynamic web project, MERN project, a simple project, and packages, class, interface. All the options are here. So from here we can go and create a project, and you can find other options like edit, source, refactor, navigation, search, project, run, Windows, help and all. Okay, so we'll see while going through the project, or this course will explore all the options possible. Okay, so let's create a MERN project. So we need to go to the file, new, and here you can find the option for creating a MERN project. So click on that and pop-up will open, and inside this pop-up you can see new MERN project is written. So no need to do anything here. Click on next and click on next, and here you can give the group ID. Suppose I'll give group ID com.age your success, and then here you can give the artifact ID. Artifact ID is like your project name. So MongoDB project. Okay, suppose we'll give it a name MongoDB project. Okay, so see the package name will become com.isyoursuccess.mongodb project. Okay, so click on finish and Maven project will be created. See here now the MongoDB project has been created here, and here you can find the source folder. Inside that main, then Java com is your success Mongo project. See here, and there is a app.java file is already created. Okay, so this is the simple way of creating a Maven project in Eclipse or in Spring Tool Suite. So now what we do, we need to add some dependency inside the pom.xml file. Pom.xml file is the configuration file for Maven. So here if you click on the pom.xml, you will find all the dependency will be specified in that file. So click on pom.xml here, source, and see here the project information, the version, packaging is jar, the project name is MongoDB project, and here the properties, then here dependencies. So see here JUnit dependency is added by default here. So why we need to add the dependency? If you go with the normal Java project creation, you need to add the jar files if you want to use some external things like JUnit or MongoDB. So to access the MongoDB jar files or MongoDB specifications, we need to have the MongoDB jar. So for that we need to add the MongoDB jar manually. But if you are using a Maven project, or if you have created a Maven project, or you are using Maven, you need not to add the dependency manually. Only thing we need to do, we need to modify the pom.xml file and we need to add a dependency description here. So we need to create a dependency. Okay, inside the dependency we need to add the information so that Maven will go and install all the required jars to be used in the project for that particular thing. Like for here JUnit, we are going to add the dependency for MongoDB. Okay, so we need to add the group ID, and group ID will be org.mongodb, and close the group ID tag. And then the next is we need to specify the artifact ID. So artifact ID will be Mongo Java driver. Since we need MongoDB driver for Java, we need the Mongo Java driver. So this artifact will install the MongoDB drivers for Java. Okay, and then we need to specify which version we need. So for version, here we'll need 3.2.2 for MongoDB jar files. So we'll specify 3.2.2. So it's simple. Dependency, inside dependency we need to add the group ID, that is org.mongodb, and then we need to specify the artifact ID, that is Mongo Java driver, and then the version. And as soon as you will add this, Maven will be knowing that okay, for this project we need MongoDB drivers for Java, and it will go and download the jar for us. So to do that, we need to right click on the project, go to the run as, and here you can find the Maven build, Maven clean, Maven install, Maven test. So you need to click on the Maven install so that Maven will go and install all the dependency for us. So click on that and see, it will start building the project. See here, console, it is building the MongoDB project snapshot, and see here, it is saying tests. Okay, see here it is saying MongoDB build success. It means has built the project successfully. And if you can see the Maven dependency, now you can see JUnit jar was there by default because it was already there when we created the project. Now we have added the MongoDB dependencies. So see here MongoDB -java -jar -3.2.jar, all the jars and class files are added by Maven. We need not to manually configure the build path and add the jar files. So this is the advantage of using Maven. We need not to download and add the jars files. We just need to specify the dependency and it will automatically added by Maven. So in the next lecture we are going to create a class file, and with that we will try to connect to the MongoDB server. See you in the next lecture. Hello and welcome back. So in this lecture we are going to connect to MongoDB and we will also create a collection and we'll try to insert a document into the collection. So let's get started. So we have already added the dependency for MongoDB using Maven. So now we have all the jar files in our project. So we can start using those MongoDB classes and start connecting to the MongoDB server. So I'll right click on the project, right click on the package, and I'll create a Java class. So click on the class and I'll give it a name, connect MongoDB, and I'll click on the main method we need. So I'll click on that and click on finish. So this class has been created. So now I'll write the code to connect to the MongoDB server. The very first thing is to connect to MongoDB, we need to call the Mongo client. Mongo client is a class that we need to connect to the MongoDB server. So we create an object for this. Okay. So now it will ask us to import. So we'll import the necessary imports. So com.mongodb.mongo client. So now the error has gone. Now this Mongo client will take two parameters. The first one is it will ask for the localhost, the address on which our MongoDB server is running. So in our case it's a localhost, and it will also ask for the port number on which MongoDB server is running. So in this case it is 27017. So check with the MongoDB server is running or not. So here MongoDB server has stopped. So let me start the MongoDB server. So see here the MongoDB server is started and it is waiting for the connection on port 27017. So now the server has started. So now the next thing is we need to create a database. So for that we need to use a Mongo database class. So Mongo database class will give us the options to create database and collections and inserting document inside those collections. So we need to create an object for this as well. So we'll create an object and we give it a name MDB, and then we use this Mongo client object to get the methods for creating database. So see here there is a method get database name and get DB. We'll use get database, and get database will ask for the database name. So we'll give the database name as myusers DB. Okay. So now with this we are creating a database should be my users DB. Okay, we need to import. So let me import. Okay. So now here we are giving the database name. If this database is already existing, it will get the details from this database, and if it is not existing, it will
create the new database for us. So let's connect to the Mongo and check whether this database is there or not. We'll use so db. See here, local and blog, only two databases are there. So this database is not there in our MongoDB. So it will create a new one for us. The next thing is here we'll give the simple message that database is created. Okay. Next thing is, we know until unless we not insert any collection or document, our database will not be created. For that reason, we need to insert the document inside a collection. So first we need to create a collection. So we'll use the database object, Mongo database object mdb dot, and we'll use get collection. See here, there is a method called get collection. So we'll use that get collection. So get collection works in the same way. If the collection is existing, it will get the details from the collection, and if it is not existing, it will create one. So we'll use user details collection. Okay, and then with this we know we need to insert the documents. For that there is an option, there is a method insert. There is option insert many and insert one. We'll use the insert one for now. And so it is asking to insert the document. So now inside the insert one method, we need to insert the document. For that we need to call the document. So new document will create an object of document, and with that we will start appending. So now what I do, I'll append documents or the key value pairs. So here what I do, I'll give name, comma, Sunil. So I have appended the name Sunil, and then I will append another thing. Suppose I'll append city, comma, Bangalore. Okay, so for now this is enough. Okay, and then here it is asking to import. So we'll import the org.json. So now see here, so there is no error. So we are simply creating a database MyUserDB and creating a collection user details, and then we are creating a document, and the document we are inserting two values, name and city. So let's run this and see how it is going. So we'll run this as a Java application. See here it is showing us message database created. So let's see on the server. See on the server it's saying two connections are now open. So one we have opened through Mongo and another because of our. So let's see. So DBS. See now MyUserDB is there. This MyUserDB we have given here. So this database has been created from our Java class. Okay, and then we'll see whether the collection is there or not. So we'll use MyUserDB and we'll see. So collections, sorry, I have typed wrongly. U should be on capital letter, and then we use so collection. See here, user details collection is there that we have given in our code. User details here, and then we'll see whether name Sunil and city Bangalore is inserted or not. So let's check with the db.userdetails.find. See here, we have the ID that has been created by the MongoDB object ID, and then we have the name Sunil and city
Bangalore. So this is the simple way of connecting to MongoDB using Java. In the project section, which is the next section, we will start exploring more about MongoDB and we'll try to create a project which will having the user management system. So see you in the project section. Hello and welcome back. So till now we have learned about NoSQL databases, we have seen basics of MongoDB, and we have also seen how we can connect to MongoDB using Java. So using Java we have connected to the MongoDB server, and then we have created a database, we have created a collection, and we have inserted a document also. So we have seen how can we connect to MongoDB using MongoShell and Java. So now in this section we are going to create and develop a project using MongoDB as a backend and Java JSP as a programming. Okay, so with JSP we'll develop the front end and Java will use for the backend programming, and we'll also use JSTL, JSP tag libraries, and a little bit of servlet. So you need to know the basics of JSP, tag libraries, servlet, and Java. So if you are familiar with these things, it will be easy for you to follow. And if you are not familiar, not to worry, you can revise, and I'll also explain the things, and if possible I'll try to add the basics of JSP and JSTL to this course. So as soon as possible I'll try to add the basics of JSP and JSTL. So we are going to develop this project user management systems using MongoDB Java JSP. So here we can add user, suppose Ramesh, and email ID. You can keep on adding more fields. I'm simply using 3 fields: name, email ID, and password. If you want to increase the forms text field or any other field, you can keep on adding. I'll tell you how to do that as well. And we can add some password here, and when click on add, see here it will show you all the other user along with the user we have inserted. So see here Ramesh and Ramesh. Okay, so in this way here, from here we can edit as well. So see here Ramesh, and here you can put Ramesh T and edit user, it will be updated. See here now it is Ramesh T, and we can delete also. Click delete and it will be deleted. So this is the simple application we are going to develop with the MongoDB and Java, JSP, JSTL, all other things. Okay, so see you in the next lecture where we'll start developing this from scratch. So we are going to write all these Java files for like adding user, delete user, edit user logic, the user converter for converting the DB object to the Java object and Java object to the DB object, then Mongo listener for connecting to the MongoDB, and then the DO class, then the Pojo class for user, and all these things. So let's see, then we'll write the JSP files as well, and then we'll see how we can format the page using CSS. All those things we are going to see from the next lecture onwards. So I'll start from very basics and from scratch, so not to worry, just follow along and you will be mastering the MongoDB and Java. Okay, so see you in the next lecture. Hello and welcome back. This is Sunil, and let's get started with the project right away. So to start with the project creation, we need to create a project. So in this I'm going to create a dynamic web project. Okay, so let's click on the dynamic web project. So to come here you need to go to file, new, and then dynamic web project, and then here we need to give a name for the project. So let me give it a name, MongoDB Java project. Okay, and then click on next, and click on finish. No need to do anything else. Okay, click on generate web.xml deployment descriptor because we need the web.xml. Okay, so and then click on finish. So this will create a, click no for now. This will create our project, dynamic web project, which will have this folder structure, source folder. Here we'll create all the packages and Java classes. Then we have the JRE systems library. It will have all the Java related jar files. And then we have the server, pivotal TC server that we are going to use in this course. And then we have the web content, which will have meta inf and web inf. Web inf will have web.xml file, and then here we'll also add the JSP files. Okay, so JSP, CSS, all those files will be in the web content folder. Okay, so now we have, let me close the earlier project. So right click, close all files, and this is the project, which Java project that we did in the previous section. So let me close this. We no need of this project now. So now we have this project, but in this course I'm going to use Maven for building the project. So to build we need more Maven, so I need to convert this dynamic web project to Maven project. Okay, so go to the right click on the project and go to the configure, and here you can see convert to JPA, convert to plugin, convert to Maven, and convert to aspect-J. So I want to convert to the Maven project, so I'll click on that option, and here no need to do anything. Okay, click on finish. So this will convert our project to the Maven project. So what it will do, it will just add a pom.xml file here. Okay, so see here there is a pom.xml file that we need to define to add the dependencies, to add the jar files. So instead of adding manually, we need to add the jar files through Maven. That's why I have converted this dynamic web project to Maven project. So see you in the next lecture where we'll be configuring our project. Hello and welcome back. This is Sunil again, and in this lecture we are going to discuss about web.xml. Web.xml is a deployment descriptor for our web project or web application. So everything about your application will be stored in the web.xml. So let me tell you a little bit about web.xml. Web.xml you can find in a dynamic web project inside the web content and then web inf folder. So inside the web content, then web inf, you can find the web.xml file, which is a XML file, and it is known as web application deployment descriptor for your application. And we can define everything about our application that server needs to know when it is loading our application. Okay, so this is all about the application deployment descriptor, that is web.xml. So let me tell you one more thing. We can define few things like servlet and other components like filters, listeners, initialization, parameters, container managed security constraints, resources, and welcome pages in the web.xml. So you can see here there is already a display name for our project. There is a web app and then display name, and then the welcome file list is there. So it is already given the default index.html, htm, JSP. Okay, so these are the, if you want to define your own page, you can define it here. Okay, so we can define the welcome pages, resources, constraint, all those things inside the web.xml. So we are going to use web.xml to define two things. We are going to write the web.xml for welcome file. Okay, so for this I'll be using a JSP file, and we can name it like index.jsp, or here I'm going to give users.jsp. okay, so you can select a name for your welcome page. So I'm going to use users.jsp. so I'm going to use this welcome file list. So when my web page will be loaded or application will be loaded on the server, it will display me this users.jsp page. So we will write the JSP page in the coming lectures, but now I'm only describing it here. Okay, so next thing I'm going to use is I'm going to use one more feature of web.xml, that is context param. So there are two things, there is a init param and there is a context param. These are the two static parameters which we can store in web.xml. So what is init param? Init-param we use to define the static parameter that is not going to change frequently, but if we use init-param to define a parameter which is not going to change, it is going to constrain till the servlet scope. So if we are defining it a parameter inside this init param, it will be applicable only for a particular servlet scope. It will not be applicable for whole application. And for this reason, in this project I'm going to use context param. So what is context param? So context param is same static parameter that is not going to change in whole application, but context param will be applicable for whole application. So it is not going to restrict to a one servlet scope, it will be common for whole application. Okay, so we are going to use the context param. We can also use the set attribute, but we are going to use the context param here. Okay, so we are going to use context param. So let me define this. So we will be using two parameters here. So one I'm going to use is context, inside that we need to give the parameter name as param-name, and here the parameter name will be mongo underscore host. So we are going to define a parameter, static parameter, that is mongo host, because we know we are going to use MongoDB and the server runs on the local host, so that is not going to change. So we'll be using this param value to define the local host. Use param name. Okay, so local host. So now we have defined one parameter, one static parameter that is going to be common throughout the application. The next thing is we need to define one more thing, and that will be Mongo port. So next thing is we will be using Mongo port. Okay, and here the port will be 27017 as usual, because we are going to use MongoDB. So these are the three things we need to define in the web.xml, that is deployment descriptor, the Mongo host that is not going to change, that is local host. So name is Mongo host, value is local host, name is Mongo port, value is 27017. So instead of writing this local host and 27017 all the time, we are going to fetch these values from the web.xml when our application loads, and we are going to display users.jsp. So we are going to define this user.jsp in the coming lectures. But for now, this is all about the configuration in the web.xml. See you in the next lecture where we are going to configure pom.xml. So we are going to write something in the pom.xml for JSTL and Maven. So see you in the next lecture. Hello and welcome back. So in the previous lecture we have learned and we have written our web.xml file. In this lecture we are going to learn about Maven. So in this project I'm going to use Apache Maven for building our project. So let me introduce you with the Apache Maven. I'll give you a short intro so that you will be aware of what is Apache Maven and how we are going to get benefited with this. So we are going to modify this file. This file you can find in the base directory of the project, that is pom.xml. This pom.xml is the center point of the Apache Maven. So everything we want to do with Apache Maven we have to write inside this pom.xml file. So what is Apache Maven? Apache Maven is a software project management and comprehension tool. So based on the concept, it is actually based on the concept of project object model, that is POM, and that's why its name is pom.xml. Okay, so it is based on the concept of project object model, and Maven can manage a project's build, reporting, documentation, distribution, mailing list, configuration management, dependency, all these things along with build from a center point of information, that is pom.xml file. Okay, so Maven provides various ways for developer to manage a project, and they can manage the builds, reporting, documentation, dependencies, configuration management, releases, distribution and mailing list with Maven with very simple steps and with utmost ease. So what Maven does, it just simplifies and standardizes the project build process. So instead of doing the manual process for team collaboration and building and collaborating with the different teams and different developers, we can use Apache Maven to automate the process. Okay, so project object model, that is POM, is an XML file that we can find in the base directory of a application, okay, or a project. So pom.xml contains all the information about your project, like project, and here you can see this is model number for Apache Maven, and then here you can find the group ID. Group ID is actually the, like, you can give it in a different way. We can give like a com dot your, like, suppose is your success, okay, dot MongoDB. So it will say that this group ID means this project belongs to this company is your success, and it will contain all the projects related to MongoDB. Okay, so this way we can understand what is group ID. Then artifact ID is like a project name, so we can give the project name inside the artifact ID, and then the version is the version number for your project. Okay, and then here packaging you can give like var or jar, whatever you want, and then here the source directory is src, which is here. So we'll start writing the Java files inside that. And then comes the plugins. Plugins are like what are the plugins you are going to use for your project, that we are going to define inside the plugins. So inside plugins we can define the plugins inside the plugin. Okay, and here artifact ID, version, source, target, all those things we can define. Okay, and then here we have another configuration for web directory, so web content. Okay, so we are going to write this file for our project. So let's get started. So very first thing, we need to add the MongoDB dependency. We have already added in the Java section of this course, where we were connecting to the MongoDB using Java. So we know how to do that. So let me do it one more time. So what we'll do, we'll add a dependencies, and inside the dependencies we will add all the dependency. So for that, we'll add use dependency, and inside the dependency we need to add the group ID. So sorry, first we need to add the group ID and then artifact ID. Okay, so here I'm adding the group ID for MongoDB, that will be org.mongodb, and then artifact ID will be mongo-java-driver. Okay, so this is the artifact ID and this is the group ID, and then the next is version. So we need to define the version. Version is 3.2.2. Okay, okay, so now we have defined the dependency for MongoDB. So let me align it. Okay, so next thing is now, okay, it is building the workspace. Okay, so next thing is we need to add the dependency for JSTL as well, because we are going to use the tag libraries as well. So we'll add that as well. So for that we need to use the group ID. For JSTL, group ID will be javax.servlet. Okay, so this is the group ID. Artifact ID will be JSTL and version will be 1.2 we are going to use. Okay, so see, so now we have added the dependency for JSTL and MongoDB. Sorry, here I've written something wrongly, it should be Mongo. Okay, so now we are done with the adding dependency for MongoDB and JSTL. Next thing is we need to add a plugin. So we'll go at last and we'll hit enter, and here we need to add the plugin for MERN compiler. Okay, so for that we need to add the artifact ID. First thing we need to specify plugin, and inside plugin we need to give the unit artifact ID, and for this MERN compiler plugin artifact ID will be MERN-compiler-plugin. Okay, next thing is we need to give the version. So for this plugin we are going to use version 3.1. It should be version, and then we need to give the configuration. So let's give the configuration. For this configuration we are going to give two things. One will be fork, and that will define as true, and then the next will be executables. Executable will be here executable will give for Java compiler, that is JDK bin. Okay, so that it will compile all the Java files. So see, you give the path for your Java compiler, that is JDK. So program files /java /JDK. I'm going to use 1.7.0_45 version /bin/javac.exe. So javac.exe, we all know it's a Java compiler. So we are going to tell Maven that we need to use this Java compiler to execute the Java files. Okay, that's it. We need to define this much only. And okay, let me align it. Okay, now it is looking perfectly fine. So this is the configuration we need to write in the Maven pom.xml file. First one is for MongoDB dependency, and then for servlet dependency, and then we need to define the plugin for Java compiler. Okay, plugin for Java compiler. Okay, and once we have done this, we can build this project. Okay, so right click on the project, go to the run as, and click on Maven build or Maven install. Okay, so it will install all the required dependency and the plugins. So see here, it is starting. See here, it is saying build success. It means our build is successful. We can go ahead and run the program. So see you in the next lecture. Hello and welcome back. This is Sunil again, and in this lecture we are going to create the project structure. I'm going to create few folders for our project so that we can keep the respective files in that. Like we want some CSS file, we want some JavaScript file, and we want some images to be used in our project. So for that we are going to create folders. So first thing, we need to create all the front-end related things in the web content, like JSP pages or CSS that has been used in creating a page. We need to keep that in the web content. So web content means we are going to use what are the things we are going to represent on the page that is visible as a web page, or a front end that we are going to use in web content. So I'll right click on the web content and go to new, and I'll create a folder. So go to folder, and here you give the folder name. The first folder name I'll give as CSS. Okay, and then I'll create one more folder. I'll create a JavaScript folder. There we'll keep all the JavaScript files. So JS, and then I'll create one more for keeping all the images like logo and other things. Okay, so I'll create images folder. You can keep img also, not a problem. I'm giving full name images. Click on OK. Okay, so now we have CSS, JavaScript and images folder here, so that we can keep the respective files in that. We need our entry page that we have defined in the web.xml, that is users.jsp. So that will create in the web content. So right click, go to the others, and here just type JSP, and see here
you will find two options, JSP and JSP tab. We are going to create a JSP file. So click on JSP file and give it a name. So we want to give the name users.jsp and click on finish. Okay, so see here our basic structure for JSP is created, like doc type, HTML, head, meta tag, title, head, body and closing body and closing of HTML. So this is the basic structure of a HTML page or JSP page. If you use this scriptlet, it will be a JSP. Okay, and now we have the CSS, images and JavaScript as well. So from the next lecture onward, we are going to create the web page, the front end of our application. So see you in the next lecture. Hello and welcome back. So let's start writing the JSP file. So first thing I'll change is title. So here we can give the title of our project, that is user management system. Okay, and then the another thing we need to add, the very first line we need to change it to, not change, we need to add inside the scriptlet. We need to add here we need to tell the JSP that we are going to use tag library. So we use scriptlet @taglib and then we give the URI for tag library. So in this case we are going to use http:// and here we'll use java.sun.com/jsp/jstl/core. So this is the URI for tag library, and then we need to specify one more thing, that is prefix. We'll see what is this prefix and how we are going to use this. Okay, for now we'll be using prefix as C. Okay, so this line will enable us to use the tag libraries in our JSP page. So now we have the tag libraries and user title. Next thing is we need to see here doc type is there. Next thing is we need to add the JavaScript file and CSS file. Okay, so for that what I do, I'll go to the web content and CSS, and here I'll create a CSS file that I'm going to use in my project. Okay, so go to other and type CSS, and you can see here CSS file and give the name for the file. So here I'll give the usual name, that is style.css, and click on finish. So see here now I have a CSS file, style.css. In the same way I'll create a JavaScript file. Go to other, type JavaScript source file, give it a name like script.js and click on finish. So now we have the CSS file and JavaScript file here. We'll write the content later. For now what I do, I'll add into the JSP file. So for that, to add a external CSS file, we can use the link. Okay, and for link we can add the relative, and here we can give style sheet because we are going to use the CSS, and here we can give the reference for the file. The reference for the file will be the path for the CSS file. It will be css/style.css, and here we'll close the link. Okay, so now here we are telling our JSP that we are going to use this style.css, which is under the CSS folder, for our purpose, for our styling our web page. Okay, the next thing is we need to attach the JavaScript file. So for JavaScript file we can use the script. Okay, script type text JavaScript, and here we can give the source for the JavaScript file, and it will be js/script.js. Okay, sorry, it should be src. Okay, so now we have the JavaScript file and CSS file. For reference, we'll write the script in that. Okay, and from here, from the body tag, we'll start writing the actual web page that we are going to display. Okay, so from the next lecture onward, we'll start writing the navigation part and the CSS part of this project. Okay, see you in the next lecture. Hello and welcome back. This is Sunil again, and in this lecture we are going to add a social link on top right corner of our website or home page of the application, and a navigation to add the link for our home page, about us, all those things. If you want, I'll tell you how to add that, and then we'll add the logo. Okay, so these three things we are going to do. The first thing what I do, we are going to use some images. So I have all those images here. I'll just copy and paste these images on my image folder of the project. So right click on the images and click on paste. So now we have the images here to be used in our project. Okay, so let's start writing the code. So first thing, we need to use the div tag. Okay, and here I'm going to use a class, and since I'm going to add the social links on the top right corner of the website, I'll use a class and I'll give it a name social. Okay, so now we have a div to add the social links. Okay, so here now we can give the links for our social websites. So here you can give the link for your website or social media profile, and then you can add a image reference so that it will be shown as a image. So for that we'll use image src, and here we need to give the image link. So here image link will be images slash, suppose I want to use the social icon for Twitter. So here we have the name for that, social icons Twitter dot png. So this file we are going to use, okay, for showing the Twitter as a link. Okay, okay, so this will show as a picture and this will be the link. Suppose you can give here twitter.com, okay, slash whatever your name, Sunil, or whatever your Twitter ID that you can give. Likewise you can give for the other social sites. Okay, just copy this link and paste here. You can give YouTube, and here for YouTube we have the picture name is social YouTube.png. okay, so for now let it be these two. You can add more if you want. Okay, so now we have this link. For image we can give the height and width as well, and style also. So here we want to restrict the image size to 21 pixel. Okay, so next thing is we want to add the navigation. So for navigation I'll create one more div, and this div I'll use a class that I'll define later in our CSS file. I'll give it a name navigation. Okay, and we want to align our
navigation to the center. Okay, so next thing is inside this navigation div I'll create one more div, and this div I'll use a class called, and I'll give it a name navbar, okay, or nav. Okay, and inside this, sorry, this should not be a div, it should be list. Okay, so create a list here, and inside this list we'll create a li tag, and for li we'll use all the navigations which we want to give. So here to do, I'll create a href, and here you can give the link, and here you can give the name of your link or navigation. Suppose I'll give home. Okay, same way, sorry, copy and paste and give like about us, contact us. Okay, so this way we can give the link. Okay, so next thing is, now we have the social link and we have the navigation bar. We want to add our logo to our website, so let's add. So for logo we'll use the header. Okay, for header we'll close this. Okay, and here we'll use the href, and here you can give the link for your logo. If you want to attach it to something like to your home page or something, you can give the link here, and then we'll use a image. So we'll use the image for our logo, so we can attach here the logo image. So for that, the logo image will be images / logo.jpg. Okay, fine. So let's run our, so let's try to run our application. Run on server and see how our users.js page is looking. Okay, so see the server is starting. It should show the users.jsp. See here. So now this is how our page is looking. This is the logo, this is the social icon, and this is the navigation which we have given. So it is so unstructured. We have it's so scattered. So for this only we need to write the CSS file so that it will be showing in an arranged way. So in the next lecture we'll write the CSS to arrange our website links. See you in the next lecture.
Hello and welcome back. This is Sunil. So I'm back with the update, and in this lecture we are going to write our CSS file. So we are going to organize this page. See here, it is not coming in a proper way, so we are going to arrange it in a proper way. So let's get started. To arrange HTML page in a required or desired manner, we need to write the CSS. Okay, cascading style sheets. Okay, so .css file, we already added this link here. Okay, css/style.css. So whatever we write here, it will be reflected in the JSP page, and in that way when we run our application, we'll see that change in our page. So let's write the CSS. So first thing, we see what are the div classes we have written in our JSP file. So we have the first div class we have written is social. So we need to define this social in our style so that this social div will be displayed in a proper manner. So for that, let me write the div dot social. So div dot social will give us the option to arrange the div social. Okay, so for this what I write, I'll write few things like margin hyphen left. So I want to align it towards left, from left 90%. Okay, so let's see what this change is reflecting or not. So let me run this and see here. Now our social icon is from here, it came to here, from this point, from this left end to 90% towards right. So that's what we have written here. Margin left 19%, 90% means it will be marginalized towards left, from left to right. Okay, and then the next thing is I'll give the font family. Okay, leave it, font family is not required as we are using the images there. So next thing I'll give border, and here I'll give 0 pixel solid, and here you can give a color code. So here I'm giving color code as 0F799E, anything you can give. Okay, so next thing is I'm going to give the margin from bottom. So margin from bottom I'm going to give 10% for now, and same way margin from top I'm going to give 0 or 0%. Okay, so let's see how it is coming. So okay, so it is coming like this. The next thing is, now we have the social icon we have arranged. Next thing is we need to arrange the navigation. So for navigation, what we have used, for navigation we have used nav class. Okay, so for that we need to write the navigation nav class here in CSS. So for CSS nav we can use dot nav, and inside that we can write our navigation. Okay, so here I'll give margin 0px, I'll give padding also 0. Okay, and then I'll give list style I'll give none. Okay, and then we give nav space list, and for list we'll give float for right. So I want the list to be floated towards right. Then give width as I'll give 160 pixel. We'll see how it is coming, then we can change it. Okay, the next thing is I'll give margin hyphen top, and margin top I'll give 0 pixel, and then I'll give position I'll give relative. Okay, so now we have given the margin for navigation and nav list we have given. So let's run and see how it is coming. So see here, now it is coming like this. Okay, contact us, about us, home. Okay, so next thing is, now it is coming in a bit arranged way. The next thing is we need to add one more thing, dot nav a for anchor tag. Okay, and here we have to write the background. So background color we can give. So here I'll give something 2E 4F something you can give, whatever color you want you can give here. And then The next thing we need to give the color of the text. So here I'll give okay, and then we can give a display style. I'll give it a block style. Okay, next thing is we need to give the padding. I'll give 7px, 28px. Okay, next thing we'll give text decoration. So text decoration I'll give none for now. Should be decoration. Okay, the next thing is I'll give border top. I'll give 4 pixel, and style I'll give solid, and color I'll give red. So let's see how it is coming. I'll explain. First let us see how it is coming. See here, now it is coming like this. Okay, so now we have a border list here. Okay, so now when we are hovering here, we need to change the color of the link. So that we are going to do with the simple CSS change that we can do through .nav list space hover. So when we hover over the link, it will change. So for that I'll give the color, and I'll ask it to change for white. So let's refresh and see here, now it is changing to white. Let me show it to some bright color that we can easily see. Put it green and refresh it, and see when I'm hovering it is changing to green. Okay, so now we have this thing, but one problem is there. There is a too much space here. So for that, how we can change that? Let me see what I have done wrong. So I have given here the display wrongly, that's why it was coming. Let me show you what was the error. So let me refresh it. So this here, it is not coming properly. There is a gap in between. So this is coming because I have given the display spelling wrong. So it should be only 1p display. And now if I refresh it, it will come properly. See here. Okay. So now we need to see why this space is coming. So let me investigate that. See here, this space is coming because we have written here wrongly. It should be button. Okay, and now if I refresh, it will come correctly. So see here, now it is coming correctly. Okay, so now we have arranged this navigation and social thing. Next thing is we need to change the background color of this page. So for that we need to, let me write on the top, it should be body. So we are going to change the color of the page, and here we can give the background hyphen color RGBA, and here we can give the RGBA coordinates. So I'll give suppose 178, 255, 188, 0.6786. Okay, and let me refresh this. So see here, now it is coming this way. So now we have a better web page to see. So we keep on adding the CSS when we add a form here. So for that part of CSS we'll see when we add. Okay, when we add the HTML, we'll modify the CSS as well. For now, this web page is looking good. Okay, see you in the next lecture. Hello and welcome back. This is Sunil, So in this lecture we are going to write our first Java class for this project. So now we are switching from front end to backend programming, like we are going to write the Java program. So the very first program I want to write is I want to write a listener. Since we are going to use Java servlet in this project, I'm going to write a listener. I'm going to write a Mongo listener class. So I'll give class name as a MongoDB listener.java. So to create, I'll tell you more about what is listener and how we can use that and why we are using that. First, let me create a class. So we'll click on class and package name will give class.each your success dot mongodb dot listener. Okay, so this will be the package, and inside this package we'll be creating a class MongoDB listener. Okay, click on finish. So now we have this class MongoDB listener. Okay, so this class we have created. Now I want this class to act as a listener class in this project. So let me tell you first thing, what is listener? Listener is part of Java servlet and it is basically a predefined interfaces that are available for developers in the application lifecycle to achieve some task. So basically it's a predefined interfaces and it is readily available for the developers to use and to achieve some task. Some predefined task or some task which you want to do before your application server is started. Something like that. Okay. So what does this listener do? It saves a lot of time because you need not to go and do the same thing again and again. It's one you do and it will be available for throughout your application. Okay, so in that way it saves a lot of time and it also makes the application more maintainable because it reduces the complexity of your application, because the task which you are going to use at many times you are going to do only at once by writing a listener class. So it reduces the complexity and it in that way it is more maintainable. Okay, so actually listeners in Java servlet are basically two types. The first one is servlet context listener and the other one is HTTP session listener. So there are basic difference between these two. We are not going to in deep detail about these two things. We are going to just have an overview that is enough for this project. Okay, so servlet context listener will be executed only once your web application is deployed in your web app server. So it will be executed only once. Okay, it will be executed once your application is deployed onto your application server. And why we need and why I'm going to use in this project, I'll tell you. If you have a requirements that need to be executed before the application is started, then servlet context listener is the best place for you. Okay, so we are, as I told earlier, listeners are two types: servlet context listener and HTTP session listener. But I'm going to use servlet context listener because it is good for our project. Okay, why? Because we need a listener before the application is started. So we want to connect to MongoDB, and for that we need to execute some task before the application server is started. Okay, for that reason I'm going to use the servlet context listener. Okay, so it will be executed before the application is started. Okay, so when we run our application, the very first thing it will do, it will run the listener and it will execute the task which will be we will be defining inside this listener class. Okay, so understood? And HTTP session listeners will be available for only the session. So once you create a session, it will be available for that particular session only. But when you use servlet context listener, it will be available for the whole context of the application. And because of that only, we are going to use the servlet context listener. So to make this listener, we need to do one thing. It must implement the servlet context listener. So for that, we'll write the servlet context listener. Okay, so now we are implementing servlet context listener. So it will ask us to import. Okay, so import the servlet context listener javax dot. Okay, and now it will ask us to add the unimplemented method, so do that. Okay, so now we have two methods in this servlet context listener, that is context destroyed and context initialized. Okay, and it will take some parameters. So in the next lecture, we are going to write this MongoDB listener that is implementing the servlet context listener. Okay, and here we are going to use add web listener. Okay, and it will ask us to import annotation. Okay, so we are going to use annotation. So now this will make this as a web listener. Okay, so see you in the next lecture where we will be writing these two methods. Okay, see you in the next lecture. So let's start writing these two methods, context initialized and context destroyed. So first thing, I'll change this arg0 to SCE. It is servlet context event. Okay, so let's rename this to something useful and something that we can easily identify that it is the object of the context event. Okay, so now why I'm going to use this servlet context event or servlet context listener or web listener, because we have defined this thing in web.xml. What is that? That is Mongo host and Mongo port. Okay, these two we need to connect to the MongoDB server. So for that, what I do when I initialize my server or when I start my server, first thing I want to do, I want to take these two Mongo host and Mongo port, local host and Mongo port. Okay, this Mongo host and Mongo port variables, and I want to set it to the attribute, set it to the context attribute. For that only we are using this listener. Okay, so that we can use these attributes whenever we need to connect to the MongoDB. Okay, so first thing what I do, I'll write the context initialized method. Okay, so for this I'll create an object for servlet context. Okay, and I'll give the name ctx. Okay, and with the help of this C object, I'll get the context. So I'll use get servlet context. Okay, so here we need to import javax.servlet, so it will get imported here. Okay, so next thing is we need Mongo client. We need to call the Mongo client and assign these two variables, Mongo host and Mongo port, to Mongo client. Okay, so for that I'll use Mongo client. Mongo client is a client that we use to connect to the MongoDB. Okay, I'll create an object for this and call it Mongo, new Mongo client. Okay, Now it will ask us to import Mongo client. Okay, so we'll import com.mongodb.mongo client. Okay, so it is imported here. Now this Mongo client will take two parameters. The first one will pass the Mongo host that we take from the context, and the other one is Mongo port. Okay, so for this I'll use the context object, servlet context object, to get the initialize parameter that we have initialized inside the web.xml. Okay, and here we'll give the name for that. So what was the name? It was we have given Mongo underscore host. For local host we have given the variable name as parameter name as Mongo host. Okay, next thing is we need to pass the Mongo port, on the port on which MongoDB server will be running. Okay, so we'll use ctx.get init parameter, and here we'll give the name of the Mongo underscore port that we have given inside this web.xml. Let me show you one more time. Mongo port and Mongo host. Okay, this we are getting the value through context. Okay, now we are getting an error. Let's see what is this error. So it is saying the string undefined, because this is the string but this Mongo port is integer. So for that we need to pass this to integer. For that we'll use integer dot parseInt. Okay, and we'll pass this to, let me full screen this. Okay, we'll close this. So now the error has gone. So now we have this Mongo object will be having two values, Mongo host and Mongo port, that we can use whenever we need during our programming. Okay, next thing is we got the attribute from the web.xml. Next thing is we need to set it to the context. For that what we do, we'll take the servlet context event object, and with that we will use the get servlet context, and with this, so first with this object we'll get the get servlet context method, and with this we'll use set attribute. So we'll use this set attribute. Okay, and here we'll give the name for the attribute. So here I'll give it a name, Mongo underscore client. Okay, and here we'll pass this Mongo object. Okay, so let me Mongo, sorry. Okay, so now we have written this context initialize, where we are getting the parameters Mongo host and Mongo port and setting it to the Mongo client, and then we are setting it to the servlet context by using set attribute method, and here we are passing this object Mongo to the Mongo client. Okay, so next thing is we need to, when we initialize our server or when we start our server or start our application, this will get initialized and it will be set, the value will be set to the servlet context, and when we close our application, then the server will automatically detect that our application is getting closed, so it will destroy the context. So it will destroy the values or parameter that we have set to the context attribute. Okay, so for that reason we need to write the context destroyed. So for this what we do, we'll take the Mongo client again. Okay, and we'll create a Mongo, and then with this servlet context event, what we do, we'll get the get servlet context dot get attribute, and we'll pass the attribute name, that is here Mongo client, Okay, so here we have error. It is saying that we need to cast to the Mongo client. Okay, so that's a simple thing, the casting issue, and then we'll use this object Mongo to close the connection. Okay, so Mongo dot close will use, and in this way we can close the MongoDB connection and destroy this attribute that we have set it to the servlet context. So this is pretty simple. Okay, so now we have the attribute Mongo host and Mongo port ready to be used, and in the next lecture onwards we'll try to write our main logic to connect to the MongoDB and start writing the logic for user management system, where we'll create user, we'll edit user details, and then we'll delete the user details through Java, and backend will be the MongoDB. So see you in the next lecture. So we have written the MongoDB listener.java class, which is a listener class. Okay, so let me correct one mistake which I did here, otherwise we will get error when we run this. Here the name of the parameter is Mongo port. I have written MongoDB port, it should be Mongo port. Okay, so now we have this Mongo listener ready. Next thing, we need to write a form where we can enter the data that we want to insert into MongoDB. Okay, so here in the users.jsp I will create a form, simple form in JSP, and then we will add the JSTL and Java codes later. Okay, first thing we will create a simple form. So for that we need to use the HTML form. Okay, and here we need to define the action. Okay, so action we will add later. Okay, for now let it be blank, and for every action we need to define the method. So here I'll be using method as post method. Okay, so this is the simple form, and here next thing is we need to define the number of fields, like fields, what are the fields we want in the form. The first thing I want a name, so I'll give that name, and then we'll define the input type. So it should be input type equal to, it is text. Okay, and name equal to, should be name. Okay, and we'll close this, use a br tag to break the line. Next thing is we'll use the email ID field, and here input type will be again text, and name will be email. Okay, so this name we will use while we write our Java code to take the value from the JSP page. Okay, and again we'll use the br tag to break the line, and then the next is I'll use only 3 fields: name, email, and password. Okay, so if you want you can add more fields, but to make the things not too complicated I'll use only 3 fields, and type will be password. Okay, and name will be password. Okay, close and break. Next is, now we have these 3 fields. Next thing is we need to add a button or a action that we can click so that it will call the post method. So for that I'll use input type, I'll use submit. So on the submit action it will call the post method, and value I'll give as a since we are adding user, so value I'll give add user. Okay, so this will be displaying on this button. Okay, so now we are ready with the form. So okay, so let me run this to see how it is looking. Run on server and click on finish to see the changes on the web page. So server is starting. Okay, so see here, this is the form which we have created: name, email ID and password. So when you can add name, you can add a email ID, and you can add a password. Okay, so email ID you can add anything. Okay, and password, and when you click on add, it should go to the MongoDB. Okay, that logic will write, but this form is not looking good. For this, what we need to do, we need to write the CSS. So for that, I have already written the CSS, and that I'll explain. But basically I have written actually one div as container, and I have given the width, height, margin, font family, position, and I have written another div that is main. Okay, so these two basically I'm going to use, and then for the input type and password I have written this thing. Okay, so it's a simple thing. Okay, so let me use these two div to show our web page better. Okay, so for that, first thing what I do, I'll use a h2 tag and I'll align it to the center, and then I'll give the name for this form user management system. Okay, and then I'll create a div, and class I'll use as a container. Okay, so one div I've created, container, and I'll close after the form, and then I'll create one more div, and here I'll use the class main. Okay, and I'll align it to center. So let me write this, and I'll close this after the form. Okay, so now we have written this container and this main div. So let's see how it is looking. So I'll just refresh this page. See here, now it is looking much better. So what I have done, I have added this h2 tag, and I have added a div, this white one, and then I have added one more div so that it will be displaying like this. Okay, so let me show you this logic or CSS. See here, I have written the div container that is having a width of 760px, so that will be the this div, the white one, and then I have created one more div as main that is 620px. Okay, the inside one, and rest of the things are pretty simple. It is like float to left, margin, font family, background color, all those things. Okay, and then for register I have written some logic that you can go through, and it is pretty simple. I'm not going to spend much time explaining those simple things. So now we have this form ready. Now we can start adding the Java code too, so that we can start adding the these field values what user is entering to the MongoDB. So you must have seen we got some error here while we have ran our project. What is this? Let me show you. It is showing that exception in monitor thread while connecting to the local host. See here, this error we are getting because we have ran our project, and when we run our project, it will run this class as well, listener, and it will look for the MongoDB which is running on the Mongo host, that is local host, and when it is not finding the anything running on the local host on this port 2701, it is throwing the error. So in the next lecture we will start the MongoDB server and we will run this project again, and we'll start writing our model class that will be the user.java class, and then we try to add the servlet for this action which we will perform while submitting this user detail. So see you in the next lecture where we'll be writing the model class. Okay, so now we have this form ready. Let's write the model class. So for that I'll create a class. I'll go to the new and then I'll go to the class, and here I'll change the package. I'll create a new package and I'll give it a name model. So inside the model package I'm going to create a model class that is user, and I'll click on finish. Okay, so now we have this model class user. So in this we are going to define these three fields: name, email and password. Okay, so along with the ID which will be generated by the MongoDB when we try to insert the data. So for that we'll create a private fields, okay, private members, and here I'll give a type as string and it will be ID, then other one will be private string name, then the next one is private string email, and the next one is private string password. Okay, so these three fields, name, email and password, will get from the user entered value, and this ID will be generated by the MongoDB. Okay, so now we have defined these private members in this class user. Let's create a getter setter method so that we can get and set the values. So for that you need to right click on this here, and you need to go to the source, and when you go to the source you can see the here option generate getters and setters. Click on that. Okay, and select all the fields: email, ID, name and password. Okay, see here I have given wrongly, it should be email, I have given email. Okay, let me correct that. So it should be email. Okay, then go to source and generate getter setters and select. Okay, and then click on, from here you can deselect and select all as well. Okay, and click on OK. So see here now we have the string get ID, set ID, get name, set name, get email and set email, and get password and set password. Okay, let me copy this to top. Okay, let me increase the font size. Go to window, preferences and text font and click here edit, and here you can choose the size as 12. Okay, click on apply, click on OK. So now it is coming in a better way. Okay, so now we have written the model class. In the next lecture we are going to add the post method, and we are going to add the action here, and then we'll write the servlet for the corresponding action. So see you in the next lecture.
Hello and welcome back. This is Sunil, your instructor, and I hope you guys are having great time with this course and you are doing good. I hope you are learning from this course. And if you have any doubt, any question or any suggestion to improve this course, please do write inside the course question and answer area, and I will be happy to answer all your questions, and I would be very much happy to work on any suggestions to improve this course experience. So let's get started with this lecture. In this lecture, I'm going to write a few JSTL code in our JSP file for this form. So when I clicking on the add user, it is not taking us to anywhere. So what usually we do when we enter some data here and click on add user, it should go to the database. For that, I want to write some logic. So when I am using add user here, it should take these values which user has entered and it should forward these values to the some servlet where I can set these values through a model class object, and then from model class I can take it to the DAO class, and from DAO I can take that to the database. So this is the normal procedure. From here it should call a servlet. From the servlet I can set these values to the request scope and set the values to the some model class object, and then from there we can call a database access class, and then we can submit to the database. So for that, the first thing I want to add a URL here so that when I click it will take us to the servlet. Okay, for that switch to the JSP, and inside this here we have written the form action. So here only we need to give the URL variable. Okay, so for this I will use c:\out and I'll give the value, and value will give inside the dollar braces, and I'll give the variable name add user URL. Okay, so this is the variable I'm setting here. So now I have this variable here. Next thing is okay, so now we have added this add user URL. So when I click on add user, it will take us to this variable. Now this variable I need to define inside the map to the servlet URL. Okay, for that we have c:\URL. With that we can map to a servlet. Okay, so for that I'll give a value, and value will be here. I'll give the URL add user, and variable will be this value which we have defined here. Okay, add user URL. Okay, so now when we click on add user, it will set the value to this add user URL, and this add user URL I'll map to a servlet URL, that is add user. This we are going to write inside the servlet. Okay, so now let me refresh this, or let me rebuild the project. Now see here, when I'm clicking on add user, it will take us to the URL, that is add user, right? So this add user, you can see here on the top, this is coming from this here. Okay, so now when we click on add user here, it will take these values to the servlet. So in the next lecture we will write the servlet for this add user URL. See you in the next lecture. So let's write the add user servlet. So to create a servlet, we need to go to our source package, source folder, and we need to, you can go with creating a class, or if you want a easy way, go to other and type here servlet, and here you can see the inside web, you can see a servlet. Select that, click on next, and here you need to give the Java package where you want to create your servlet class. Okay, so servlet is just actually a Java class only. Okay, so com dot is your success dot MongoDB dot, I'll give it a name, operations. Okay, or whatever name you want to give to your package you can give, and the class name I'll give add user. You can give add user servlet or something, but I'm giving add user.java, or it will be okay, and then click on finish. It will create a servlet. I'll tell you what will be the difference between when you create a Java class and when you create a servlet. Here, when you create a servlet, it will automatically add this web servlet annotation, add web servlets annotation, and it will add this URL, add user. Okay, and the next thing, it will automatically extend to the HTTP servlet. Okay, and then it will also give you the methods like do get and do post that we are going to use. Okay, so if you are new to servlet, I will give a brief introduction to servlet in the coming lectures. Okay, before we go ahead by writing more codes, I'll give you brief introduction about servlet, okay, and its life cycle. So don't worry about that. So here what I'm going to do, I'll change this URL to small a, add user, because in the JSP page I have given a small a, add user. Okay, so that would be fine. So now when I click on the add user on my UI, it should come to this servlet. So for that, to test, what I do, I'll give a simple, inside the do post method, I'll give a simple system.out.println to see whether we are calling this servlet or not. Okay, so I'll simply print a message inside add user servlet. Okay, so now from this JSP, when I click on this add user submit button, it will come to this add user URL, and then it will call this servlet. Okay, so let's run this project and see the flow. Run server, click on finish. It will start the server, and then it will build and run our project. So see here, now we are here. So now if I click on this add user, it should show us a message on our console. Okay, so click on add user and see here, it is showing us the message inside add user servlet. Sorry, I have given the wrongly inside, it is inside. Okay, so not a problem, that a spelling mistake. So we are seeing this message here on our console. That means we are rightly calling our servlet. So in the next lecture, we will continue with the servlet, and I'll also give a brief information and introduction about servlet. So see you in the next lecture. Hello and welcome back. So in the previous lecture, we have created a servlet, that is add user servlet, that is a HTTP servlet. So I told you that in this lecture, I'll give you brief introduction to servlet so that it will be easy for you to understand and follow this course going forward. So let's have a basic understanding of servlet. So what is servlet? I'll tell you in a simplest way. Servlet is actually an interface in Java. Okay, so it's a interface that we need to implement if we want to create a servlet. So if you go by a definition, servlet is a small Java program that runs within the web server. So this is the definition given by the Oracle. So this is the basic definition of servlet. A servlet is a small Java program that runs within the web server. Okay, so
I'll tell you, servlet is used to create web applications. So when we use JSP here, if we go and start writing everything inside this JSP, the Java code and all, it will become very vague. It won't look good. And at last JSP is going to convert into the servlet. So it is better to write a Java code. So that's why servlet is there. Okay. So servlet receives and responds to the request that it gets from the web clients. So when we added here, when we ran our program or application, when we are writing something like name, email ID and password here and clicking on add user, we are sending a request to the web server. So here this is the client, and when we are clicking on add user, we need to take this information from this client to the server. So that is client and server interaction that we are doing here. So we need to take this form information and submit it to the server, and from server it will go to the database. Okay. So servlet receives and responds to the request from web client, usually over the HTTP protocol, that is hypertext transfer protocol that we do over the internet. Okay. So to implement this interface, you can write a generic servlet. There are two types of servlet. One is generic servlet that extends javax.servlet.generic servlet. Okay. And there is another servlet that is HTTP servlet that we are going to use in this project. So see here, our servlet add user is using HTTP servlet. So it is extending the HTTP servlet. Okay. So that is the case. Okay. And this interface defines methods to initialize a servlet, to service a request that we are getting from the client, and once the request is fulfilled by sending a response back to the client, it also contains the method to remove the servlet from the server. So it is basically when we create and initialize a servlet, it will load the servlet, then it will initialize the servlet, and then it will service that servlet requests, and then it will destroy the servlet. So this is the life cycle of a servlet, that is load, initialize, service and destroy. So once everything done, destroy the servlet from the web server. So this is the life cycle of a servlet. Okay. And I'll tell you one more thing, the client server request with this thing. This is the client, this is the server, and we are sending a request, and when the request is going to the server, response is getting generated at runtime, and this runtime response is being sent back to the client, and this is the client server interaction. Okay, so this is a little bit about the servlet. Okay, so we are going to use this do get and do post in our project. So there are many other methods that will see whether we can use in this project or not, but for now we are going to use do post and do get. So do post and do get methods we are going to use. Okay, so this will serve the request that is coming from the HTTP, that is of type post, and this will serve for the get. So I'll tell you what is do post and do get. See here, when we are submitting this value, so we are using for form action, we are using method as post. So we can use the post and get. Okay, there are two methods. So when you use post, it will be served by this do post method, and when you use get, it will be served by the do get. So now we have the fair information about servlet. We are going to write the real code for this project in the next lecture. So see you in the next lecture. And if you have any doubt, any question, any suggestion, any feedback, please do write inside the question and answer section of this course. See you in the next lecture. Hello and welcome back. I hope you are learning from this course. And if you have any question, doubt or suggestion, feedback, please do ask your question. Okay, so let's get started with this lecture. So in this lecture we are going to learn about field validation, how we can do field validations using JSTL, JSP and servlet. Okay, so that's what we are going to. Let me tell you what we are going to do. When user is, suppose user need to fill these three fields, name, email ID and password. What user is doing, he is not entering the name, he is just entering the email ID and password, and he is clicking on add user. So what will happen? It should ask the user to please enter the required field, or please enter all the mandatory fields. Okay, so that's what called field validation, and that's what we are going to do. So let's do it through Java. Okay, so in this project I'm going to use post method, so I'll remove this. Okay, to get, okay, so remove unnecessary code. So now we have this only do post method here. Okay, so let me remove this as well. So we are going to do a field validation. Let me go to the JSP and let you know what we did earlier. So here we are taking input as text for name, email and password. Okay, and this we are passing to this URL, add user URL, through this post method, and thus this add user URL is mapped to this servlet URL, that is add user. And in this way, from now, since I'm using the post method, I can use the servlet context to get these values inside a servlet, inside this servlet. Okay, so now inside this add user I can get these values through request.get parameter, because those values are getting attached to the request or the context, so we can get those values from the request. Okay, so I'll create a variable here, string name, and I'll use request dot get parameter, and here the parameter name which we have given inside the JSP, it was name. Okay, so I'll use name, and in the same way what I do, I'll copy paste, and here the second one is email, so I'll use email, and here I'll give the name email. Okay, and the next is password, so here I'll give variable name as password, and here also it is password. So this name, email and password should be the same as we have given in JSP here. So name, email and password. So if you are giving something like email ID here, you have to give the email ID same name in the add user dot java. Okay, so you have to give the email ID same thing. Okay, so I'll remove the ID, I'll make it ID in both the places. Sorry, the project is getting built. Okay, so now we are getting these three values through request. Request.get parameter will give the values which user has entered through that form. Okay, so let me put a sys out here, and I'll print this value. Okay, so name, I'll put name. Okay, then I'll print email, So what I'm doing, whatever the values we are entering through the form, I'm getting here and I'm printing to the console. Okay, so let me run for these two value. Okay, so let me enter Sunil, email ID also sunil@sunil.com something, and password something. Okay, so click on add user and see here we are getting the name as Sunil, email ID as sunil@sunil.com, and okay, so we have not printed the password, so it is not showing. This means we are getting the values from the request correctly. Okay, so let me go back to the servlet. So now we are getting the value. Next thing, we need to put a validation. So what we do, I'll write a if condition here, and what this if condition will do, I will check. I'll write else as well. Okay, so what I write inside the if, I'll simply check a condition if name is equal to null. So if name is null, if user is not entering the name, it is null, or name dot equals empty. Okay, so since it is a string, we need to check the both null and empty string. Okay, so that's why I'm checking name equal to null or name dot equals empty string. So here basically I'm checking whether user has entered some value or not. If user is keeping the field as empty, it will be null. Okay, and then similarly I'll check for email. So I'll check email equal to null or email dot equals empty string, or I'll check for password as well. Okay, password equal to null or password dot equals empty. So now we are checking if name is null, if email ID is null, if password is null. If it is null, what we need to do? We need to call the request and we need to set the attribute. So request dot set attribute, and here what attribute name I'll give error, because if it is null, we need to show user that you are doing something wrong, some error message we need to show. So I'll set the attribute as error and I'll give the message all fields are required. Okay, so this is the simple message I want to show when user is not filling fields. Okay, so now once this is done, we are setting this error attribute to the request. Next thing we need to do, we need to tell the request that it need to dispatch this to some page. So I want to be on the same page. So what I do, I will remain on the same page. For that we need to use the request dispatcher. Okay, through request dispatcher we can dispatch the request to some page. Okay, so I'll create a object for this, and with get servlet context I will get the get request dispatcher. Okay, and inside this I'll keep the page name where I want to send this request. Okay, so here I'll give users.jsp. I want to remain on the same page. We need to import. Next thing is we need to use this object to pass the request and response. Sorry, we need to forward it to request and response. Okay, so we are basically forwarding this request dispatcher object through this request and response that we are getting here. Okay, so let me test this. So let me go back, let me refresh the application, and here let me click on add user. So see here, now we are getting the name and email as empty here since we have not entered anything. So now we are not getting any message on the UI because we have written everything inside the servlet. So now we need to show this error, this message on the UI. How we can do that? That's what we are going to do in the next lecture inside this JSP page. Okay, so see you in the next lecture where we'll be writing this JSP to show the error message on the UI. So see you in the next lecture.
So we have written the servlet part of the validation logic. Let's write the same thing to show the validation message on the JSP. So for that, what I do, I'll write some code here inside this main div. Okay, so what I do, I'll use C:, if test, and for test what we are going to use, dollar bracket, we'll use request scope because we have set the value here to the through the set attribute to the request scope, that is error. So this value we are going to take inside the JSP and will be showing this message, right? So request scope dot error if it is not equal to null. If request scope dot error is not equal to null, we need to show a message to the user that something is wrong. So let me close this. So this is the if statement in JSTL. So C:, if test, and here this is the value we are getting from the request scope for error. So that is coming from here. So if name, email and password, any of these three values is null, this error will be set to this message, and this message we will be showing in the JSP through this. Okay, so now we have this. If it is null, we need to show this. So I'll use a strong, I'll use style. I'm using strong and style to show message in a color. If it is success, I'll show in a green, and if it is error, we'll be showing in the red. Okay, we'll show the message in red. I'll close the strong, and inside this we'll be using C:, out, and here we'll be showing the value of the error. So that also we get from the request scope dot error, and we'll close this, and we close the C out. So here we are checking if request scope dot error is not equal to null. That means if it is null, we'll show this message. So let us test this. So for that we need to run the application. So run on server, click on finish, restart the server. So server is getting started. Okay, so now if I don't put anything and click on add user, it should show us the error message. So see here, now it is showing all fields are required. So this is the message we have set inside this servlet, and from this servlet we are passing this message to this error, and this error we are getting through the request scope here and checking its value. If it is not null, then we are showing the value through cout. Okay, so this, from here we are showing the
message. Okay, so see here, now we are getting the message all fields are required. And what if we set the value correctly? For that, what I do, I'll just copy this and I'll paste it here and I'll make it success, and I'll put this red to green and here error to success. So now this message, success message, will be shown when we will be adding all the fields. So for that we need to write the else here. Okay, so for this what I do, I'll just copy this. Okay, so instead of error I'll put this success and also users added or user added. Okay, for now. Okay, we'll change the message later. Now we are just showing the message, and I'll copy this to forward the page to the users.jsp. Okay, so now let's run this. So if I run now, it will show us. So let it build correctly. Now what I do, I'll add all the fields. Okay, and I'll add password. So now all three fields I'm adding, and I'm clicking on add user. See here, it is showing us the message in green, user added. So this is the advantage of using JSTL. We can show the error message on the same form. See here, all fields are required because I have not adding here. Suppose I'm not adding email, it will show. Suppose I'll add all the fields, it will show us the users added. Okay, and if I miss, it will show us all fields are required. So it is so nice to see at the error message on the same page without page being reloaded. Okay, so this we are doing through this simple JSTL logic that we are testing here, and through this servlet where we are setting the value for error and success. Okay, so in the next lecture what we do, we will be here in the else part. When we are adding all the fields through the form, then it will come to the else part. What we do, we'll take all these values, name, email and password, and we'll try to convert that to a DB object, and we will save that into the MongoDB. So see you in the next lecture where we will be writing the DAO class.
Hello and welcome back. So in this lecture I'm going to write a DAO class, and I'm also going to write the else part where we will get all the data, that is name, email and password, from the JSP form and try to forward that data to store inside the MongoDB database. So let's create a class with the name user.dao. So I'll create a class, and the package I'll give com.hyoursuccess.mongodb.dao. So all the DAO classes I'll store inside the DAO package. Okay, and here I'll keep the class name as user.dao, data access object class. Okay, and I click on finish. So this is our class inside the package DAO. So now what this DAO class will do, it will connect to the MongoDB and it will try to convert the whatever user data we are getting from the model class, that is user.java. So here in the add user.java we are getting the values from the JSP, and then what we do, we'll set these values through this model class to this user.java user object, and then with this we will forward it to user.dao. Okay, so let us first write the else part here. So for else part, what I do, I'll create a user object. I'll get it a name u and new user. Okay, so I'll create an user object for the model class. So
So it will ask us to import. So import the, so now we have the user object here. Now what I do, I'll use u dot set name. So we have this set methods for use email ID, name and password. So for that I'll use set name and I'll pass this string value that we are getting from the JSP. Okay, in the same way I'll use dot set email, and for email I'll use the email this value, and in the same way I'll use u dot set password, and for password I'll use password. Okay, so now we have all these three values assigned to this user object. Next thing is we need to pass this user object to the DO class. Okay, so for that what I do, I'll use the user DO. I'll create an object for user DO and can pass it like this. Okay, import it. Okay, so we can do like this, but here what I do, because we are getting this will be the an Java object. Okay, but to store the value in the MongoDB, we need to convert this to a database object. Okay, so for that what I need to do, I need to convert that to the DB object. Okay, for that we'll do, but let me do one more thing. To connect to the MongoDB, we need to have the Mongo client in place. So I'll create a Mongo object for Mongo client and I'll use request dot get servlet context, and with this I'll use get attribute. So with get attribute what we need to give, we need to give the Mongo underscore client. Okay, so this will get from the request. So now it will ask us to import. So let's import, and then it will ask us to cast. Okay, so I'll cast it to Mongo client. So now this Mongo object is there. This is required to connect to the MongoDB. I'll pass this to user DO. Okay, and so that whenever we'll initialize the user DO class, it will get initialized and MongoDB connection will be established. So I'll come to user DO, and here what I do, I will I'll create the constructor for the user DO, and inside the constructor I'll pass this Mongo. Okay, import it. Okay, so now I'm taking the value for user DO inside the constructor. Okay, and to connect to MongoDB we need another class, that is I'll create an property for the DB collection. I'll create an object for this DB collection.call. Okay, let me import this. So DB collection, this is required to connect to the MongoDB database. Now what I do, I'll use this call to connect to the MongoDB. So I'll use this Mongo that we are getting from the add user. So Mongo dot get DB, there is a method called get DB, and here we can give the users DB database name which you want to give. Okay, dot collection name which you want to give, and collection name will give users. Okay, so with this DB collection we will connect to the users DB, and this database, if it is already there, it will insert this collection inside this database, and if it is not there, it will create this database and then this user collection inside the database. Okay, so now we have the data part done. Next thing what I need to do, I need to create a method, public create user. Okay,
So I'll use create user method, and in this method what I do, I'll take this user object that we are passing from add user here. Okay, so this user object. Okay, so let me, I'll use user DAO dot something wrong here. Okay, here I need to define the type, so it will be user. Let me import. Okay, it is asking to return type will be user. Sorry, it should be small public. Let me import this. Okay, so now it is, so got resolved. Okay, so we are creating a method of type user, and we are taking the user object and we are returning the user object. I'll tell you why I'm creating this. Let me go to the add user here. Here through this user, what I do, I'll call this create user and pass this user object. Okay, so from here what I take, I'll take this user object which will be containing this name, email and password, and I'll call this create user method. Okay, so now I'll come to the user DAO, and here what I do, now we need to do a task. That task will be, we need to convert this user object to the DB object, and for that we'll use the DB object. I'll create an object for this. I'll call it doc, and I'll user converter. Okay, I'll create this class dot to DB object, and I pass this object u to this. Okay, and then let me import com.mongodb. Now it will ask us to create the user converter class. So let me create the class. In this class I'll create in, I'll call the converter. Okay, so now we have this user converter class. So let me explain before I write this. Okay, so let me explain what I did till now. I have used this user object to set the values for name, email ID and password which we are getting from the JSP, and then I created the Mongo client object, and through the request I'm getting the attribute Mongo client, and then I have called the user DAO and I passed the Mongo this object to the user DAO constructor, so that it will, when this user DAO will created, it will get initialized, and then through this user DAO I'm calling the create user method and passing this user object. Okay, and then I'm coming to user DAO and I'm calling the DB collection, and through this user DAO I'm calling this get DB mongo.getDB.get collection to connect to the MongoDB database and collection, and then I'm creating a create user method and I'm passing the user object to this, and then I'm trying to convert this user object to the DB object. Okay, for that we have created a class user converter that we are going to write in the next lecture. So let's write the user converter. So what this user converter will do, it convert the user object to the DB object and DB object to the user object. So we'll write one method to convert the user to DB object, and we will be writing one more method to convert the DB object to user object. While retrieving the data, we'll convert the DB to user, and while inserting data we'll convert user to DB. So for now we are converting to DB object, and that's why we have created this class user converter, and we have created this object created this method to
DB object, and from here we are calling this user converter dot DB object to DB object method, and we are passing this user object. Okay, so let's see what we can write here. So this method is of type DB object, which is of type static. Okay, so inside this, what we need to do, we need to convert this user object to the DB object. So for that, we need to use the basic DB object builder. So this basic DB object builder is a class which helps us to build the DB object in MongoDB, and for this we'll create an object and we'll give it a name builder and basic DB object builder. Okay, we'll use basic DB object dot, we'll use the start to start building the object. Okay, and then with this, what we do, we will start appending the key and value. So here the key which we want to give inside the MongoDB database, that will be name, and the value will get from the model class, that is from this user u.getName. Okay, so let me separate this append here. Dot append, we'll use the another one, that is email, and for email we'll use u.getEmail, and then the third one dot append will be the password, and for password we'll use u.getPassword. Okay, and we'll close this with semicolon. Okay, only one is sufficient. Okay, so what we are doing, we are creating an object for basic DB object builder, and with this, what we are doing, we are appending the values, key and value, that we want to insert into the database. So key, we are giving name, email and password, and value we are getting from the model object, that is u.getName, u.email and u.password. Okay, now we need to return something here. Okay, so for that, before returning, we need to check whether we are getting the ID or not, whether the object is created or not. So for that, we'll check here, if u.getID not equal to null, if ID is not null, when you insert data in MongoDB, it will automatically create the ID for us. Okay, we'll use builder equal to builder dot append, and here the key will be underscore ID that MongoDB will create for us. Okay, and value will be new object ID, and that we get from u.getID. Okay, here it is asking us to do something. Let's see. Okay, we'll import Bison. We know because MongoDB store data in the Bison format, that's why it is asking us to import this org.bison.types.object_id, because object ID is of Bison type. Okay, and now here, instead of returning null, we'll return builder.get. So when you use builder dot, you'll see there is a get method that will create the DB object. So we'll return the builder.get, that will return us the DB object. Okay, so now what process we are following, we are getting the users.jsp. Through this we are taking the name, email and password through a form, and then we are submitting this through a post method with this URL, and then it is coming to add user.java, that is a servlet, and here we are doing the validation, simple validation for field here, and then in the else part we are creating the Mongo object, and we are calling the user do, and we are passing the Mongo and user object here, and then we are coming to user do. Here we are, through the constructor, we are establishing the connection with the database and creating a collection, and then we are creating a method, that is user method, and we are taking the user object value here, and then we are calling the user converter through this DB object, and we are calling this toDB object to convert this user object to the DB object, and then we are coming to user converter and this toDB object method, and through this basic DB object builder we are building the DB object. And what we are doing, we are simply giving the key and value pair. So key we are giving here in name, email and password, whatever value you want to give you can give, and here we are giving the value through that we are getting through this object, user object u.getName, and then we are checking whether the ID is null or not, the data has been created and inserted into DB or not. If it is there, we are appending the ID with the ID, and then we are getting the object here. So now we have the flow ready. Let's run this project. Before running this project, we need to start the MongoDB server. So in the next lecture, I'm going to run this full application by starting the MongoDB server and by starting the project server and deploying the project. Okay, so see you in the next lecture. We'll be seeing the end-to-end running this application. See you in the next lecture.
Hello and welcome back. So in this lecture we are going to run our application and we are going to add a user. Okay, so before that I forget to do one thing. We are building the DB object here. So we are converting the user object to DB object here, and we are returning the DB object. Okay, now in the DO class I need to insert this DB object into the MongoDB database, and that part is 3 lines of code that I need to write here. So I need to use this .call.insert. Okay, and I have to pass this doc. So okay, so this document I need to pass so that this collection object will insert this document into the MongoDB. Next thing is we need to set the object ID. So we are not inserting the object ID, MongoDB will create the object ID, and for that reason we have to create an object ID, and then we need to use this doc.get. Okay, get string, and string will be underscore ID that MongoDB will generate for us. Okay, now we need to do 2 things. We need to cast this object ID, and we need to import this object ID from the Bishon, because this will be the Bishon document. Okay, so that is done. Next thing is we need to set this to user object u to use dot set ID, and we need to pass the ID. Okay, now we need to convert this ID to string. Okay, so for that we need to use the toString to convert this ID to string. So for that I'll use id dot toString. Okay, so now that is done, and then we'll return the user object. So now it's done. We have written the user converter do and add user. We have listener class there that will initialize the MongoDB properties. So let's run this application and insert the first user. Okay, before that let me start the MongoDB server. So to start MongoDB server, you need to use MongoD DB path, and we need to give the path where we want to store the data. Okay, so now MongoDB server has started. Next thing is we need to open the another command prompt, and here we need to connect to Mongo. Why I am doing this? Because I want to show you that we are not having this user DB created already. Okay, if it is created, we will delete that. So we'll use show dbs. See here it's already there, users DB. So what I do, it's users DB. Yeah. So what I do, I'll use users DB, and then I'll use db dot top. Okay, so now we have dropped this database. So let me run the command show dbs. So here, so now we do not have the users DB database. Let me okay. So see here, now we do not have any database with the users DB. So let's run this application. So I'm starting the server now. Once the server is started, our application will be running on the server. So this is okay. So here I'm going to insert the first user. I'll use my name Sunil, and I'll use something sunil@sunil.com something, and then we'll use the password something. I'll type randomly, and when I click add user, it should add this information to the MongoDB database. So click on add user, and here you'll see the message users added. So let's go to the DB, and here what I do, see here now we do not have the users DB database. So let me run the command so dbs to see whether database has been created or not. See here users DB is there. So I'll switch to this database, and I'll use so collections. Okay, so now users collection is there. This is because here in the user do.java class we have given the database name as users DB and collection name as users. That's why we are seeing a users collection here, and I'll query this to see the information which you have entered through the JSP form that has been entered or not. So db dot users dot find and hit enter. See here we have entered the name Sunil, email and password, all these three information along with the object ID that has been created by MongoDB database automatically. So this way we can, let me add one more user. Suppose I want to add John at the rate something.com and some password. So let's see whether John is being added or not. So let's go to the database and run the command and see here John has been added. Okay, so now our application and our project is successfully running and we are able to add the user. In the next lecture we are going to see how we can display the user on this same page. When I click on add user, it will show user added and we'll see the list of user below that. So see you in the next lecture. So welcome back. So in this lecture what we are going to do, when we try to add user here, we will try to see all the users that has been already added to our MongoDB servers are listed below here in a tabular format. So let me add some users. So first thing I'll add Sunil @gmail.com something, some password and click on add user. Okay, so see here now it is coming here. So as soon as I have added the user, it is being displayed here. In the same way, if I want to add Ramesh and email ID something and password, and when I click on add user, see now both the users are being shown in a tabular format. Okay, so this logic we are going to understand. So I'm not going to write, I'm going to explain. I have already written and I'll explain, because writing is taking a lot of time and we have done all the basic things till now, so we are ready to move. Okay, so let me tell you first thing what we need to do. We need to write a JSP. So for that I have written the user list logic here. So for first thing, if the user is not empty, okay, so if this request scope.users, if users is having some values, then only this table will be shown. Okay, that's why when the first time the application is getting loaded, it is not being shown anything. Okay, so here we are creating a table, we are creating a caption, and then table body, table row, and this is the column name, ID, email ID, password, edit and delete. Okay, so this edit and delete we'll understand later. For now what we are doing, so till here we are creating the heading for the table, and here we are writing the logic for C colon for each items in the users. So in this request scope.users, this will be the list when we have more than one user. So that's why we are using for each, and then if it is having values, for each value what we are doing, we are printing the user ID, name, here ID and user ID. So we are getting ID from the user, this request scope. Okay, and then okay, this part I'll explain later. This we are taking for editing and deleting, that we'll do in the next lecture. Okay, so for editing and deleting we are getting the ID so that we can fetch the data from that ID. Okay, and here what we are to print the values on the table, we are using user.id, user.name, user.email and password. I'm not printing. Okay, and then here we are giving the edit and delete buttons. Okay, a link for editing and deleting the user details. So for that we are defining the URL, edit URL and delete URL. This thing we will discuss in the next lecture. So this is the table that we are creating, that is being displayed here. It is not coming properly in this Eclipse or STS, so let me run it in a browser so that this table will be visible correctly. Okay,
So I'll open this in the browser. Okay, so it is open now. See here. Now I'll add one more user. Suppose I'm adding John and some password for john@something.com and some password. Okay, and click on add user. See here, now it is saying the registered user and it is giving all the details: ID, name, email, password, and here we are seeing the link for editing and deleting that we are going to do in the next lecture. So let me explain what else we need to do. So we have seen what we have done in users.jsp. We need to add something in the add user.java servlet also. So here what I'm doing, I'm creating a list of type user. Okay, so I'm creating a users list of the type user and I'm calling the user.do object and I'm calling this read all users method. So this we need to write inside the users.do.java. So what is this? This is the method of type list user type. Okay, and in this what I'm doing, I'm creating a user list, array list of user, and I'm using the db cursor. Db cursor is the cursor which will enable us to iterate the data inside the document of a MongoDB table or collection. So collection.find, and it will cursor will be there on the document or on the collections document. Okay, and with this we can use the while cursor.hasNext will check whether the collection is having more document or not, and it will db object will use the db object and create the document and cursor.next. Okay, so this all the documents will be there in the doc, and then we'll call the user, we'll create the object for the user class and we'll pass it, call the user converter dot to user. So this is the db, this is the db document. Okay, now because we are getting this from the cursor, now we need to convert this to the user object. For that we need to write the toUser method in the user converter. So we'll go to user converter and we'll write a method to convert this db object to user object. So we'll take the db object doc, and what we do, we'll create an object for the user and we'll use user.setName, set email, set password, and we'll use this doc.getName. So with this document we'll get the name and convert that to the user object. And once done, what we do, we will get the object ID as well from the document, and then we'll set this to string and we'll return the user object. So from this toUser we'll get this user object which will contain all these values. Okay, and then we'll come to the user.do and we will get the values inside this object, and then this will add to this list. So now all the values will be there in the data list and this list will return. So when we call from this add user here, user.do.read all users, it will come here and it will get this data. Okay, data list. So now this user is having this data list, user list, and here what we do, request.set attribute will set to the users, and from here what we do, we'll go to the JSP and JSP will get the user detail from the request scope and it will show us on the form. So same thing is happening here. Let me show you again. I'll add one more user. Suppose I'll add Suresh and something and password something. If I add user, it will show us the detail. Okay, so in the next lecture we'll see how we can edit this. When we click on edit, it should pop up the data here, this data. Suppose this row I want to edit, so this Sunil and Sunil email ID and password should pop up here, and then this add user should be converted to the edit user, and when I click on edit, the data should be updated. Okay, so in the next lecture we are going to do this. And if you guys have any doubt, please ask me. I'm going to add the source code now to the lecture, so that you can download this source code and try your hands on this project. Okay, so I'm going to add this source code so that you can download it and you can start working on it. See you in the next lecture.
Hello and welcome back. So till now what we have done, we have written code to add a user inside MongoDB, and then when we click on add user, along with adding the user, it will also show the list of registered users that have already been registered to our application. So see here, now it is showing the list of users. So we have seen till add user and view all the users till now. Okay, so in this lecture I'm going to show you, when I click on edit user, it will pop up the fields with the details which we have inserted, like Ramesh and email ID and password, and then we can modify that and it will get updated in real time. Okay, so for that what we need to do, we have already added the code for edit request in JSP in the previous lecture. It is nothing but the same form which we will be sending through a form action, and we are sending the edit URL value here, edit URL for servlet, and through post method, and this thing we are getting the user ID, name, email and password from the request scope, and then we are submitting the form edit user. Okay, in the same way I have also written the code for delete user. For delete user we are calling the servlet delete user. Okay, that also we will write in this. Okay, so now we need to write the servlet so that when we submit this form edit request, it will look for this edit URL that we are defining here. Where is it? Let me show you. See here. So variable is edit URL, and it will look for the / edit user. So for that what you need to do, we need to write a servlet. So I have written a servlet edit user. So you can create a servlet class, and inside that we have to give the @web servlet edit user. So when we click on the edit from the web page, it will come to this servlet and it will look for this path, and it will come here through the post method, and then we need to write the simple things. Here what I'm doing, if ID is null, because we are going to edit, so we are going to edit with respect to the ID. So we'll compare, we'll fetch the data from the database from ID, because ID is the unique field in our documents or a collection. Okay, so if it is null, we will throw the exception ID is missing. Okay, so ID is required for edit operation, and then we will try to connect to the MongoDB by calling the Mongo client, and then we will be initiating the instantiating the user DAO class, and we are passing the Mongo object here, so that we will get connected to the MongoDB, and then we will create an object for user class, and with that we will set the ID, and we will call the read user so that we can get all the details from the user or from database. And then here what I do, I'll set the attribute to user. Okay, so whatever we are getting from database, from this read users, we will set the attribute to the user so that we can get it in the JSP. Okay, and then we will create a list of user type and we'll read all the users, and then we'll assign it to the set the attribute to the users. Okay, and then we will redirect to the JSP. Right, now when we come to the post method, here what we will do, we will get the parameter ID. Okay, and we'll check again whether it is null or not. If it is null, we will throw the exception. Okay, and then what we do, from the request we will get the parameter name. These are we are getting from here. Here we have set the attribute to users by read all users, so all the details will be there in the users. Okay, so from the request scope we will get the values here in the post method. So we'll get the request.get parameter name, email and password. Okay, simple system.out.println, that is not required to test. And then here we'll check whether name is null or empty, or email. We'll check whether all the fields are there or not. Okay, so if it is null, any of this field is null, we'll set that name, email or password cannot be empty. Okay, and then we will usually call the user DAO, and we will try to connect to the MongoDB through by passing the Mongo to the user DAO. And then we will, what we will do, we'll set the ID, name, email and password to the user object, and then we will set it to the user attribute, and then we will set the users and we'll redirect to the JSP. And what we are doing in JSP, we are getting the value from the request and setting to the field. See here, request scope.user.name. So we will get the name, all those details. Okay, so we need to write the one more method, that is update user. So we need to write the update user method in the user DAO, because here we will set the ID, name, email ID and password, and then we'll pass it to the update user method that I have written in user DAO. So this is read user that we need to write. Here we are just querying with the respect of ID, basic DB object builder, and we are appending the ID and we are trying to get the all the information associated with this ID. Okay, and then we are creating a DB object and finding the, with respect to this query, passing the ID and getting the required information, and then we are returning the to the user. So this is the DB object we are returning through user converter. We are converting it to the user, and then we'll write the update user, where again we'll write the query based on the underscore ID field, and then we will use this .call.update and we'll pass this query and user converter dot to DB object. So this query will have the data in the form of user object, so we will convert that to the DB object and it will get updated to the database. In the same way, we will also write the delete user, which will have the user object as a parameter, and again the query with respect to the underscore ID, and then we'll use the MongoDB method remove and pass the query, and that particular particular document with underscore ID, the ID which we are providing, will be deleted from the database. So this is what we need to do. Okay, so now we have all the things ready. Let me show you edit user. We have seen already. Here we are passing the user object to the update user. Okay, and same way we'll write the delete user, where we'll be adding the web servlet / delete user. So when we click on the delete link, it will come here and it will
check all those things, if it is null or not, and throw the exception, and then it will set the ID to the user object, and then it will call the delete user, and by passing this ID to the delete user method, and then delete user here will query the database, and with the remove method it will delete the user. Okay, and then once it is coming back from the delete method, it will set the attribute to success, and here we'll use delete user deleted successfully, and we will list all the other users. So we'll create the list again of user, and we'll call the method read all users. So all the remaining users will be listed here, and we'll redirect our request to the user.jsp. So it will be showing all the other users which are there. So let run this application. So run on server, and click on finish. Restart the server. Okay, so now application is ready, the server has started. So let's add something. John @john.com, and password something, and I'll try to add. See here, it is showing user added successfully, and it is showing see here John is here, and it is also showing all other users that are there in the database. And when I try to edit, click on edit, see here John detail has popped up. So let me modify John. I'm writing John and John123 at email ID, and I'll edit. So now it is John and John @John. It should be John. So see here, now it is showing John and John123. So it is getting edited or updated correctly. So let me delete this Ramesh, the first document, our first entry. Click on delete, and see here, now that has been deleted. Let me delete the first John, that is John here, delete, and see here that has also been deleted. Let me edit the John to some other name, Shway, and something. Okay, see here, now John has been edited to this way. And let me delete the Sunil entry, the second one. See here now, so it is seamless. We can start adding a new user, some password, username, email ID, and some password, and click on add, and see here immediately we are getting the updated user list. We can start deleting, we can start editing, whatever. Okay, so this way this project is completed. We have seen how to add, how to edit, and how to delete, and how to list all the users from the MongoDB through Java. So I'll try to add more projects in this course. For now it is good, and next project I'll add that will be having some session management thing. So we'll try to create a profile kind of application where we can log in, we can manage our profile, and we can sign in and sign out. Functionality will be there. Okay, so see you in the next project that I'll be adding soon. Thank you.